big difference.
Okay. I'm going to try to respond to the first thing. There's 8 other points you made after that. Okay. The rotational speed, for instance, if you're describing it in that way, you would see that, like, it doesn't matter the miles per hour or whatever, it would matter the one rotation a day. That's rotational speed. And funnily enough, that's the greatest acceleration out of all the other accelerations. The greatest acceleration is the rotation of the Earth. Okay. And so, no matter how you slice it, if you talk about the rotational speed of the greatest acceleration, it's once a day. So these aren't scaling, tricks or anything like that. These are just what's happening. And when I try to ask you, like, that 1,000 miles per hour, when you're trying to experience that, I'm trying to ask, like, how you would experience that. The only thing you bring back to is the rotation or the acceleration or whatever. And then we talk about those things, and they're small numbers. So, anything else I say, I'm just going to be repeating myself.
Yeah, if you don't get it, I don't know what to tell you.
Thing you can say for sure is that we don't feel any movement here on the Earth. Never do. No one ever has. Now, it's because it would be possible to be moving really fast or whatever, however you guys explain it, be moving at these vectors at high velocity or whatever. Mathematically, we shouldn't feel that. It doesn't prove the fact that we're moving. Just an idea. Fact is, we don't feel it.
Right. So where's the empirical validation, Kosho, of the claim other than just the belief? Because, yeah, Barrel Rider just laid that out pretty clearly.
Okay. Well, there's ways there. I mean, I can name a few of them. Ways that you can experience the rotation or the feeling of it. One would be the change of weight, but just to see the visualization of it or evidence of it, you do like a pendulum or a what's it called? What's the gyro compass, stuff like that, or just viewing the night sky and seeing that it's consistent with the gyro compass and the Foucault's pendulum and the weight change.
How do all those phenomena you just mentioned isolate that it's the Earth moving and not some other effect of the medium that's causing those things?
Consistent with the sky, and they're consistent with one another.
But that doesn't isolate it. I asked you how you isolated it. You to make the claim, you'd have to isolate something that's exclusive about those phenomenon that actually isolates and shows that indeed it's related to the cause you're claiming is the cause. Because there could be 1,000 other causes to why there's weight change and why pendulums precess and why the night sky's moving. There could be several others that are more viable and have been understood far before the globe idea ever came in.
Well, I agree, but I stand by my response because that's what I think. I think that for me, that's what makes it exclusive to that. Is that they're consistent with one another.
So because all three of those things line up, yeah, go ahead.
Why is that exclusive though? Like we know the Earth is either moving or the sky is moving. So there's something moving.
Right. And that's what I'm saying. Those tests, the gyro compass and the Foucault's pendulum and the weight change, the fact that they're consistent with one another, and you could derive the same, 24 hours, size of the Earth, one rotation per 24 hours, or whatever. You can derive those from each of them, so they give you the same answer, which would either be coincidental if they were separate explanations for each of those, or it would just be exclusive evidence to the fact that we're rotating.
Why would it be separate answers if it's the sky?
Oh, it's the sky that's causing those things?
There's a movement in the sky, yeah. That movement around the Earth causes all those things, yeah.
Oh yeah. I mean that would be a alternative answer, but I think that has yet to be there's no explanation for that or evidence for that. But you're right. That would be.
I mean, what's the evidence? What's the evidence that it's the Earth spinning?
As far as what you provided, Kosho, actually the same evidences could be given for that explanation than it is that the Earth's moving, because you didn't really give anything that isolates it. So
Well,
you could use those same evidences to say that it's another concept, the medium, the sky, ether. You could, you know what I'm saying? Because that's all you've done. You just said, well, they're consistent and they line up this way. So if I gave a separate explanation, and I guess if I mean, I wouldn't do this, but I'm just saying, if I gave the same argumentation you did, I could say, well, they're consistent and they're showing this other explanation.
I should elaborate that because a gyro compass, for example, works off the principle that a gyroscope is going to keep its fixed orientation. So you point it towards the North Star, and you move, around the Earth or whatever, and it's that fact that it's a fact that you're moving around the Earth that changes the gyroscope, right? So same with Foucault's pendulum. Foucault's pendulum is the fact that its precession is dependent on your latitude, and the fact that we're rotating once per day is because it's got a fixed orientation. And so there's already a mechanism that allows it to do that if the Earth's rotating. But if it's the sky that's making those things do that, then you'd have to identify what that mechanism is, right, for that to be an explanation.
Yeah, I
Like
mean,
what makes
I've
the
already
stars
explained to
make
you
it move.
guys I've already explained to you guys many times that like within your own paradigm, there's a dynamic equivalence with the sky moving. So, like we could just use Newtonian mechanics. Obviously, we don't believe in Newtonian mechanics, but like the proportion, or more so like the relationship, right? The relative nature of it and the position on Earth, that isn't exclusive to the Earth moving. The sky moving over top of it, different parts of the motion is over the Earth. Like the Newtonian mechanics would provide you a mechanism, right? I mean, and this is kind of the thing, right? What causes the Earth to move? Because like basically, you're saying you need a mechanism that can be verified. Like what causes the Earth to move?
They're a verifiable mechanism, not just a theory or an idea.
Right. Like, yeah, let's keep the same standard. Let's keep the same energy for both, right?
Well, it depends on what movement you're talking. Like if you're talking about the orbit, it's just
The rotation, just the rotation.
Oh, the
Like,
rotation.
yeah, because you want a verifiable physical mechanism as to what's causing the sky to do that. Like, okay, what's causing the Earth to do it?
And well, the claim is that most or all massive objects that are spherical, they didn't start off that way, so they had to accrete into this object, and in doing so, by virtue of that, they start to rotate because the mass
Yeah.
is
So we have
coming
any?
inwards.
Is that a verifiable physical mechanism or just a theory, like Gio said?
That's verifiable. I mean, it's based off it. Like they've modeled this. I'm not sure if there's any examples of you being able to see the screen because there's plenty of examples of you being able to do this both in a model or in just a physical principle. Like when you have masses collected together, it's going to slowly rotate, and as they get closer, they're going to rotate faster.
Well, what's the experiment that shows this?
Like I said, there's models. I can try to find one that.
Models. I mean, okay, so you have a theory. Yeah, I have a theory too. So we're still on equal footing. My theory is that there's a source of energy. There's a creative force in the center, so everything moves around it. So I guess we're still on equal footing.
I mean, what was that based off of? Because the thing I was talking about was based
everything
off
moves around.
Where's the center?
In the center of the rotation that we see,
Where is that?
right inside of Polaris.
What about the other rotation that we see?
What about it?
Where is
It's an
that in
optical
relation to
effect.
the center? Where is that in relation to the center?
180 degrees in all directions. Yeah. It's just too easy nowadays.
And you can replicate that without bending light?
Yeah. Yep.
You could have people looking away from center on multiple sides of the flat Earth looking south
Yep.
with their backs to each other, looking at the
Yep.
same thing from different vantage points, spinning in reverse.
Yeah, I mean, let's just go ahead and make sure we actually
Explain the
address
mechanism.
reality. People don't have their people don't have their backs to each other, looking south.
We're in the ripe month and season where they actually are three locations on Earth.
No, they're not. They're not.
No,
They don't
they're
have
not?
their backs to each other. That's right. Yeah, they don't have their backs to each other.
Okay.
Okay, can you tell me the two locations that are 180
I
degrees
understand.
apart?
You gotta let him. You gotta let him finish. You gotta let him finish.
Yeah, we were having a really good conversation with no interruptions. Can we keep it that way? Can we just not do the interruption game? Can we just keep it one at a time? You can have your time to speak and all that. So let's just not start that, please.
Yeah, one sec, everyone. New perspective. Can you put yourself on local mute, dude?
Oh, sorry.
Yeah, there's some chaos coming through. Cheers, dude. Carry on.
Yeah, I mean, there's not a location that there's like 180 degrees of like two observers seeing this southern rotation at the same time. That doesn't happen.
Is.
What is it?
South America, somewhere in South Africa, somewhere in Western Australia is the icing on the cake. If 2 isn't enough already for you, there's 3.
So which one of those two locations are 180 degrees away from each other, seeing the southern pole star at the same time?
One's looking 6 o'clock, one's looking 12 o'clock, and one's looking 3 o'clock.
Okay, what's
Now
two
demonstrate
specifically?
how that's possible.
Well, no, you're just making a baseless claim that's provably not true. I don't have to explain something that.
Move on.
Yeah, so if you want to show like a specific observation, like this person stands in this country, this person stands in this country at the exact same time, they see the exact same thing, 180 degrees apart, then we could go from there. You know.
I do. I have a time and a place.
Go ahead.
1 second.
Yeah. Like I've never seen the 2015 meme of 3 people on the flat Earth looking south. I've never seen this.
Well, one thing about the center question, though, is that the sun does not circle around those southern rotation or rotations, depending on how you view it. I'm just saying the sun circles around Polaris. That's one thing.
Yeah.
And you could get these this info using Walter Bisland's model. We're in the ripe season, and by that I mean if you go on Walter Bisland's model and pick an arbitrary time and date, and I have one, June 24th at 22 p.m. UTC. June 24th.
Walter Bisland's model doesn't have real stars.
Using Walter Bisland's model, I have 3 locations simultaneously at the same time. They are at night. One of them, which is South America and Australia, they do have their backs to each other. And
Walter
the other
Bisland's model doesn't have real stars on there.
Okay. Thank you very much. I would just, in case you were, thank you very much. Sorry for interrupting.
It's all good, but that's just a fact. Those are proven. He himself admits that he just arbitrarily put stars in there. So we're talking about a real observation. You can go to Stellarium if you want to, but we'll just grant you Stellarium, and you can tell me when people are 180 degrees away from each other looking south. This actually wouldn't even refute my position, but it doesn't happen.
The important thing is there is no center point. You can't have a center point because it's not center in relation to everything else. That's only possible inside of a sphere or inside of a shape. And it's actually not a center.
You're basically asserting what we're discussing, and that you can't just revert back to basically asserting a conclusion.
I'm able to. I've given you the facts. I've given you the figures. I've given you the date. I've given you the time using Walter Bisland's model. They do have their backs to each other. They are looking diametrically opposite directions, looking at the same thing from different vantage points. Impossible without light bending. And even if light bending, there's 3 things you have to worry about. You can't recreate it. If so, I'd love to see it. I spent 4 years of my life trying to figure this out, and I never could. So I'd love to see it.
Okay, well, that's probably why you're not actually listening. Because you think you've already tried and it's impossible or something. But again, the stars on Walter Bisland's model, they're not real stars. So you telling me that you can put someone in different positions at the same time on Walter Bislin's model doesn't even make sense. They're not real stars.
Okay, are you done? I can respond now. I don't want to speak over anyone. What do you mean they're not really real stars? Maybe the ones in real life are. Maybe the ones when Australia and some part of the lower part of South America is at nighttime at the same time, and they are looking away from north, which is the center point in your world, and they're seeing a group of stars, and they're saying the same group of stars.
Yeah, they're not looking south.
You're
They look southwest. See, so you don't actually know about this. That's the ironic part. They don't actually look south. They look southwest.
You're muting me to gaslight me, bud. I've given my information. You accepting it or not is irrelevant. Thank you. Let me go on mute.
You're projecting. You're projecting now because you're the one not accepting the objective nature of what direction they're looking, which is southwest. They don't look south. So I'm about to drop a screenshot of the same UTC time for different positions, people in these 3 different southern continents, and you can actually look at their directions that they're observing the Southern Cross, for example, and it's not south, it's southwest. So that means they're not like with their back to each other looking 180 degrees directly south.
He has left the building, but I'd be interested to see that. Although, I'll just say this, but if you spoke correctly about the Southern Cross, and that would actually be expected. But because the Southern Cross is it's not at the South Pole, or it's not above the South Celestial Pole.
Okay, so what are these people? What are these observers looking at the same time? If we're not going to use the Southern Cross.
Let me see. I think it's.
Let's just look at these screenshots, right, Coach? Look at the screenshots real fast. You see, that's where the Southern Cross is. So wherever the South Celestial Pole, quote unquote, is in relation to that Southern Cross, it's still moving along their observation, right? You see that one's up higher in the sky, one's lower to the horizon, one's further west. They're all off of south. They're all south-southwest. One's way further southwest, and they're at different heights in the sky. So they're not looking at the same place, even if we're not talking about the Southern Cross, because the Southern Cross is always in a certain relation to the center anyway, right, of the rotation. That's why the Southern Cross works for intents and purposes, because it's the same difference. If the South Celestial Pole is, say, one grid up and to the left, well, it's still in different places for all these observers.
Well, okay, so like the Southern Crux is declination -60. I think that star specifically is -60. So yeah, that for that reason, it's not. You wouldn't expect them to be looking directly south unless they were directly north of it.
No, I know, but that's why I'm just addressing how they say that. They just say stuff. That 2 people with their back towards each other, looking 180 degrees away, are looking directly south and seeing the same exact thing. That isn't what happens in reality at all.
Well, I think it's supposed to be true about like Sigma on Tantus or whatever's supposed to be around that spot. I think that, I haven't looked at it on Stellarium, but I think if you did, I think you'd find that they would be you would be looking at the same spot, and you would be looking directly south.
That certainly should be the case for a ball, and I actually don't even have that works within my understanding of it as well. But we know that in reality, you can't use like a commercially available telescope to see Sigma Octantis, right? Like you can't even use any commercially available telescope. So let's just say, okay, we use these biggest observatories ever. Okay, can someone show me all these people at these 3 locations that everyone puts on the cartoon meme looking at the same time at Sigma Octantis with these really expensive, exclusive telescopes that supposedly can see the star in the center? and then we could go from there and get the precise direction. So, but that's obviously never happened. This meme is built upon stuff like the Southern Cross or just baselessly saying it because it's supposed to happen. But even on a flat Earth, with my understanding of optics, you would get optical convergence in all directions 180 from the north. So it makes perfect sense, honestly. I mean, now Sigma Santentis, there's a genuinely valid debate questioning the validity of that claim.
I wonder what the closest star that's visible. Let me see.
Yeah, that's a good question.
Because I mean, I guess one observation you could do is you'd have 3 observers, and instead of, because you can't see it, maybe they can't see it, but if they did like star trails, each of those 3 observers, then you could kind of get an idea of where the south celestial pole is, because it'd be circling around that. But I don't think anyone's done that.
Yeah, and then we also got to like try to truly determine south, because I guess we're gonna use like the southern declination adjustments. How are we gonna determine true south?
I mean,
you see what I'm saying?
Yeah, I was telling this to Brian last night because he was talking about a test he was doing about north, and I mean, if all these observers, they would have to just maybe observe get a stick, make sure it sticks vertical, and then measure consistently where the direction of that shadow is when the shadow is the smallest throughout the day, and that should be if they're south of the Tropic of Capricorn, then that should always point directly south. So they'd have to do both those things and make those verifications, and then take the what's it called, the star trails observations. But that'd be an interesting test.
Yeah, I mean, I would be interested to see the test as well. I wouldn't actually say it's exclusive. The guy called into my show talking about this last night, like shadows. But he specifically thought that you could prove that the sun doesn't go faster in the south by looking at the shadows, which I obviously don't agree with. You have like what you would maybe call like angular speed. You have the angular sun and the angular dispersion of the light relative to what's observed, and then you have the shadow relative to that. Seemingly, it would always pretty much be the same. So, but either way, yeah, to determine south, that's definitely a step in the right direction. Because none of this is ever done. What happens is people, oftentimes flat earthers, just grant it, and I'm not granting it. I don't, you know what I'm saying? I don't see any test that's actually done this. That's actually, because like I said, it still makes sense in my understanding of optics. When you look the opposite direction of Polaris, when you look there, you're going to see the rotation go the opposite way, and it's going to start to converge down into a singular point. So like you could be all over the Earth. Say it was nighttime for the whole Earth. In that understanding, everyone in the south could see it in their own direction, even though flat Earth, they're all different directions.
Could you elaborate on that?
Yeah, it's just an optical effect when you see the stars that they look like they're all converging around a singular point, like crepuscular and anti-crepuscular rays. Only it's like if you spun the sun. So like when you look in the opposite direction of the sun, you see it looks like it's converging to a singular point, but it's not. I mean, the real center, the source, is behind you. So that shows you that you can look in the opposite direction, and it looks like it converges down to a point in the distance there. If I was to start spinning the sun clockwise, as I turned around and looked at the anti-crepuscular rays, they would look like they're converging to a point, spinning around it counterclockwise.
Okay, I can see where you're coming from. Because the same thing is kind of true about a rainbow. The rainbow makes a circle in the opposite sky. You just kind of say the center of that. There's a center of that. I see where you're coming at.
Yeah.
I'm trying to find the closest visible star.
Yeah. There are some real tests that would be like really big for this discussion. In my opinion, it would be really precise measurements of twilight duration corresponding northern and southern latitudes 6 months apart. That's a really good one, because it would be pretty difficult to explain it being the same exact duration in the north and the south if it has to be going faster in the south. Not impossible, but it would require an explanation.
I heard you talking about this not that long ago, and when you were talking about it, people were arguing with you, but I did recall that, at least I've heard, and I was trying to look for the evidence of it, but I have heard that there is a difference in twilight times in Australia than in the United States, and I've heard that from, I think, Australian Globers even, but I can't remember. I don't recall, the evidence for it. And I was trying to look for it and I couldn't find it. But yeah, I have heard that.
Yeah. I find it to be interesting. Like, I was getting triggered last time we talked about it, actually, because Zanuck was just like talking about like southern hemispheric refraction, basically. And I'm like, bro, chill out, dude. Like, let's be real. Like, if it was way shorter in the south, right? Like, hypothetically, like, say you go way out in the ocean in the south and it's way shorter. I mean, for the flat earth to predict that because the sun would be going faster, and then to say, boy, it's just a coincidence that the refraction works out that way in the south. I mean, my God, that's way too much for me.
What was their mechanism for that? I never did catch that.
I don't know. Something he was like, maybe it's because there's not as much land and something to do with temperature. And
There's more refraction.
he broke up.
Just there's less land, so there's just more refraction. That's it.
Yeah, Zanuck was just spitballing, man.
I mean, if that was the case, we'd have less twilight everywhere around where there's an ocean or something. No, I don't know.
Well, the sun. That means that the sun.
Wouldn't there be like less twilight on coastal cities on the east coast? Oh, go ahead.
No, you were delayed. You're good.
I'm saying if that was the case, wouldn't there be more? Wouldn't the same thing happen on any West Coast city in America on a sunset, or like every West Coast city should experience that? Then, if that's the case,
Yeah, there are all kinds of things that would mean. That would mean that you're going to have a trouble explaining the selenilian if it's in the south. Actually, you have a problem explaining it in the north compared to the south. The time should be different. Like the actual amount of time the sun's in the sky when it's supposedly lifted up about half a degree, that would have to be different in the north and the south. What's crazy is like I made that joke. Like I literally just said that as a joke. I'm like, dude, if we did go out and do this test, they're gonna come up with southern hemispheric refraction. Like there's a joke. There's no. I mean, that's why I thought it was funny because it's absurd.
Hear that thing? Did you hear that thing last night with the straw?
No,
dude, that shit's dope, bro. You get along in the
Hey, Jeremy, go on mute. You're breaking up, Jeremy. Go on mute.
straw. That's gonna cut down the refraction.
Is he breaking up for everybody?
Yeah, he is. I'll just make his point real quick. He's talking about how using a straw, very thin, very long, and straight, you could look through it, and his idea is to,
Yeah, that wouldn't work.
Overcome refraction.
That wouldn't work though. You know that, right? Diffusion would totally smash that to shit. You can't look through a straw. You can't look through a straw without losing resolution.
I can look through a straw.
Okay, I'm going to say this one more time. You can't look through a straw without losing resolution.
Losing resolution?
Okay, so Jeremy, so if you have a straw at home, get the straw out, put it between your two fingers, your thumb and your first finger, whatever, and hold it out in front of you, away from your face, and then look through it. You can see crisp lines, okay? And then bring it closer to your eye and start to tell us which part of the straw breaks down visually for you first. Do the same thing when you move it away from your eye. At some point, that straw is going to break down. It's going to pixelate. So if you're going to get a straw that's what, an eighth of an inch in diameter, a 30 seconds of an inch, or a quarter of an inch, or an inch, like what's the diameter of your straw? And then you're going to make it what, 10 miles long, a mile long? It's going to break the fuck down, man. It's not going to work.
Couple feet long. So the idea is that, yeah, all right. Thank God you weren't with one of the Wright brothers or something. So you take a straw and then you look through it, and since the
yeah, Jeremy, you're breaking up, bro.
Right now,
you're totally breaking up.
Now can't come at an angle to change the amount of refraction from just looking with your naked eye. All right, Canada's on fire and it's raining here. My bad.
Yeah, sorry, man. You're just breaking up. Hey, Austin, are you still here?
Yep.
Hey, so I came in right, like a couple minutes ago, and you were talking to Kosho. It sounded a bit, like what I've been hearing from Lindsay Harris. So are you familiar with what he thinks Sigma Octantis is?
I am not, actually. I always forget to watch him, and then next time I talk to you, I remember.
Okay, so Sigma Octantis is the backside of the sun, and it is within the Milky Way. So his model is that the north extends to the equator, and then it leapfrogs into the southern equator, but reversed and stretched out. So every constellation that's in the northern hemisphere is in the southern hemisphere. It's just that it's going to be wonky because of the dynamic of the electromagnetic field. And at some point in both the northern and the southern hemisphere, like you were saying, when you rotate the north, it reverses in the south. So you have a Milky Way in the north and you have a Milky Way in the south, and they meet at some point at the equator, when they both come around. It's like marking two points on two discs that you rotate around each other, and then they will meet up at one point and meet up at that point and meet up at that point and meet up. So it just sounded a bit reminiscent to me that you were hitting on stuff that he's actually talked about. So if you haven't heard him say that and you're getting these thoughts, I think that's pretty significant.
Yeah, I have not, but I do want to check him out. Well, we had him on Globebusters. He was all over the place, frankly, but yeah.
Well,
I heard when he's like kind of doing his own thing, he really like hones in a bit.
Yeah, that's absolutely. I was just going to say, when he does his material, he basically writes out his entire lesson on his whiteboard before he does it. So I think that being, a bit of an open panelist, he's not as focused, which is fine, whatever.
Yeah, maybe I could have him on my show too and just let him kind of talk.
Right.
Yeah, like I'll definitely check it out. Like I've heard the idea before, right? The idea that basically the south is the north, like reflected and stretched. But it does get really tricky. It certainly can't be like just a direct reflection that's stretched, because they don't really match up, So it'd have to be something else. It just like there'd have to be more than just it being stretched. It'd have to be something else that's causing it to look different. I don't know how much he's done. If you could match him up some way consistently, that would definitely be
well,
interesting.
He had one of his listeners actually made a model. It's on his channel. I don't know how far back, within the past couple of months, and it's a very short video. So if you see something that's much shorter than what he normally puts out, that's probably one of his complimentary videos. But basically, the guy mapped the sky out on these wheels that were linked together by their teeth, and as you turned them, they all turned together in syncopation, and they would match up with their counterpart, and it was pretty impressive. So I think that it's interesting that we have people that are working on models, quote unquote.
Yeah, that's very cool, bro. Here, look, let me help with the leader real quick.
Hey, Jeremy, I wasn't trying to put you down, man. I was just thinking out loud. I'm just saying, like, if you just do that with a straw, move it away from your eye, move it close to your eye, you'll see in both directions. At some point, it breaks down.
Okay, but can you see through a straw? Can you look through a straw and see something in the distance?
I would say you have a better chance of doing that when it's closer to your eye than if you lengthen the straw. At some point, that length is going to diffract, and you're going to lose resolution, and then you won't know where the straw ends and where the outside begins.
Okay, so are you saying you can't see something in the far distance if you look through a straw? I don't know what you're saying.
Yes, I'm saying that to a certain extent. Yes, I'm saying that if you look through a straw that you make longer than normal straws, at some point, when you think you're seeing the end of the straw, you've probably already gone past the end visually, and you couldn't tell when it blurred and mixed with the outside world.
So if I had a light, and then I'm looking through a long straw, I can't see the light.
No, I did not say that.
Okay, so we can see through straws. All right, good.
Yeah, but it's not just simply that. It's not just good, because you don't have really a point.
We can put a light out in the distance and see if we can see the light through the straw.
Well, Jeremy, while your connection's all right, maybe you should explain fully what you mean, because explain to Travis what it fully is, how you were talking about it.
Okay, well, they say things are refracting because of the way that the light enters your eyeball, so you see it higher because it's coming at this downward angle. So if we get some kind of long cylindrical tube to look through, and that would have to cut down on the refraction, because now we're only going to be getting the stuff that's coming straight in at us, because we now have this tube or cylinder around your eye.
Oh, okay. So my question is, how is that different than just looking through a telescope or through a camera lens? That's just a more dynamic or more what's the word? It's a fancier straw.
Yeah, I don't know.
Right? I mean, isn't it? That's all you're describing. You like, if you look through a telescope, well, that's a kind of a straw. It just has lenses inside of it.
Yeah, but the light can enter the telescope from whatever angle it wants, right?
Well, I would say that that's the same way with the straw, but that's me.
Yeah, but the straw, there's no mirrors, there's no lenses up front. It's just your eyeball looking down through the straw, and now the light can't bend like that and enter your eyeball.
Yeah, I mean, I guess what I would have to do is get out on the Chesapeake with my cameras, and then maybe get out with a
Travis?
What?
Are you Travis?
Yeah, man. What's the matter? You don't dream about me or what?
Oh, you sound different.
He only has one ear.
I use part of my hearing for vision because of my eye.
That was funny, Coach. That was good. But anyway, what I'm saying is what I need to do then is,
you need to go to McDonald's, get yourself a straw, and then line it up. No, you see
Yeah,
what
but
I'm
the
saying?
thing is
How they say refraction works?
in a sense, yeah. I mean, I'm following you to a certain extent, but at the same time, I don't believe they can show us whatever they explain. Like Kosho, if Kosho wants to start explaining something to us, and I say, show me, he won't be able to do it. He can only explain it, demonstrate it. Oh, why can't we? Oh, it's too big. The scale's too big. Well, that's just the biggest cop out ever. And you can claim anything and then say, oh, the scale's too big or the scale's too small. I can't possibly make this in reality because it's just too small and I have two fat fingers and they can't get small enough to make this work. So you're just going to have to take it for granted that I can write this equation out and prove it by the equation.
Probably a scaling fallacy, but yeah, no. With this tube or straw thing though, we'd be able to see if it's even different. You know what I mean? Because mathematically, Kosho, how long and thin does the straw got to be to where it's impossible to get a half a degree of refraction like the black swan or whatever?
A half a degree?
Well, the black swan's off a half a degree. How do we make sure the straw is long and thin enough so that there's no possible way a half a degree of refraction could we would see that?
I thought Matthew said 0.03 degrees.
No, and then we knew that was wrong, and it's actually like 0.8 or a half or something. Whatever though. Does anybody know exactly how much the black swan is off by? How many degrees?
Yeah, but
Well,
see, the thing is, the answer is no. The answer is no. No one knows dick about the black swan. First of all, there's no scientific paper on the black swan. There's no peer review on the black swan. I don't even think it's worth calling the black swan because no one knows what knows if it's this. No one knows if it's that. No one has any information except for guesswork. Not even me.
I'm good. I'm just going off their story though. And according to their story, it's off X amount of degrees. And if we look through a thin enough tube and a long enough tube, we should be able to cut that down, right, Kosho?
Technically, but I think there'd be other problems. But assuming that there aren't any other problems, then you're just worried about overcoming that that bend, like the angle that the light is, the angle that the light is supposed to be bending. I think if it's bending by the number that we used last night, it was like what was it, like 2 centimeters? I mean, I forget if I used 2 or 1. Let's assume I use an inch. Okay, so it was 143 feet before that you would be able to. You need 143 foot straw, 1 inch in diameter. Right.
Okay, but we can make that obviously much smaller though. The girth. I know you like a lot of girth, but
I mean, if you think you can get much smaller than an inch and see through it, then yeah, maybe.
Well, all right, whatever. I mean, it's something we could do to cut down on refraction. I don't know. I can see through McDonald's straws. I don't know about you guys. I have one eyeball, so.
Yeah, I mean, I think that in this discussion for the globe setup, stop talking. Like, we're allowing this to too much. We're taking too much for granted. Don't participate in this conversation until you can come back with something that's going to back your claim. Because all we're doing is saying we see this, or we don't see it. Right? I mean, that's the whole thing, guys. I'll say this once again. This is key, and we've been saying it backwards this whole time. Am I coming in clear right now?
You might be roboting a little bit.
I don't want. We see too far. That's not the question. Am I roboting?
Bro, I'm just saying the straw. If we get it long enough and thin enough, it's supposed to cut down on refraction, according to these guys. So.
Okay, but But what I'm saying right now, hold on, I'm just Carl.
I mean, it's a chance to falsify one of their claims, but whatever.
Yeah, Travis, you were breaking up before. We only heard parts of it, so I wanted to really hear what you were saying. But you might be.
All right, I stopped walking right now, so I'm being still. Can you guys hear me?
Good now, yeah.
Okay, so I'll try to be brief. Jeremy, you're giving too much. You're taking too much for granted, right? We don't have anything to falsify. They have to prove to us that they've eliminated all of the other options and have nothing left except Earth curve. Okay? They haven't done that. So they can go away and figure that shit out and leave us alone until they figure it out, because our claims are that we see something and we don't. So we have to stop saying, oh, the globe Earth is disproven because we see too far. No, that's not the issue. The issue is when we don't see far enough, because sometimes we can see really, really far and then we can't. So when we can't see as far as we did the day before, that refraction. So when we can see farther than we did the day before, why is that? Refraction. We never ever have to appeal to Earth curve. I'm done.
Black Swan debunked.
Well, I mean, this is their claim. We can try to falsify it or not. I don't know. Kosho, do the math. How if the straw is McDonald's size, how long does it got to be?
God damn it.
Just do the math, please.
It was funny, earlier we were talking about how ancient people, Eggshells was saying, isn't it crazy? Ancient people had to go to some other dude to get them to do math for them. How crazy is that? I was like, yeah, there's people in this room that still have to do that.
Well, it's delegation. I can't do everything. I got to have,
Fair enough.
You think Elon Musk does his own math? He's probably got a math guy like I do.
Okay.
Yeah, let me ask you this. Let me ask you this question, Kosho. Do you go out and take hours and hours of photographs for information and records? No, you don't.
Women.
So that's just the opposite of the math thing. You need people to take photographs. We need people. That's called teamwork.
Teamwork makes the dream work.
Yeah, but if anybody else besides Ed wants to pipe up and rebut my statement that the issue is not that we see too far. The issue is, why am I not seeing as far as I did yesterday? Because the Earth didn't all of a sudden get fucking bigger. Or smaller, for that matter. That would be smaller, wouldn't it? Because if it got bigger, you'd see farther. If it got smaller, you'd be seeing less. Yeah, that's strike that, reverse it.
Okay, Willy Wonka.
Was just thinking that.
Hey, listen, Kosho, you just climbed a rung in my book for that reference. Nice job.
That's a good movie.
McDonald's straw, bro. How long has it got to be?
Yeah, isn't it kind of a, Travis, to what you were saying, almost like it could be viewed as a reverse situation, like, to say over a planar surface that we see very, very far, but then sometimes we don't see as far. There's refractive effects, so that's what's causing you to not see as far. Whereas the globe claim, in some cases, they would claim it's the opposite, that when we don't see far enough, that's Earth curve, and then when we see further, then that's their form of refraction that they try to invoke to say why we're seeing further over the curve.
Yep, exactly. Right. And as long as both options exist, then both models are possible. And I'm fine with that if we want to go in that direction. As long as you give me my argument, I'll give you yours. But then, we've got to go into the evidence. And look, I did this like 2 years ago. I made a video all about this, and it's still, you know what I mean, not breaking the scientific world, and it should, because we can show this on small scale. We can break the ratio down, make it into centimeters, make it into yards. The Sky Free channel, both Casey and Sean have done this in the microcosm. They've gotten radio controlled boats, and they've shown that with the measurements that we've been given on the globe model, we can break it down to centimeters or whatever and show you that we're seeing too far on these days. We're seeing over the curve, so to speak, but we're not. We're just looking over the distance in front of us, and its distance or its proximity is dependent on one thing and one thing only, and that's the condition of the medium, which medium we all know and affectionately refer to as the ether band. Everybody drink. But yeah,
nobody refers to it that way.
Your mom does.
Nice.
Hey, listen, all I needed was Conspiracy Cats in his debate to spit out, it's not the ether band or whatever. I'm like, yeah, there you go. Yeah, I'm in your head. Like, he used that term to an audience who would not know anything about my term unless they were familiar with who I am and where I've been.
Well, that's like Walter Bislin added to his whole website. Whitson started using this term azimuthal grid of vision. And a week or two later, Walter Bislin puts right on his website, he mentions Whitson's name and, azimuthal grid of vision. He adds it right on there.
Well, I mean, at least he gave him credit for it. That's good.
But it was in that same way, it was like something like, and no, it's not the azimuthal grid of vision. It's something like that, the way he worded it, just kind of trying to, clearly knowing that a lot of people were coming to him or mentioning it, or maybe had heard various audio and streams of it, and using his model for it. So it's like he had to give the shout out.
Right.
And coincidentally, McDonald's straw would need to be 33 feet. Just coincidental number.
Wait, say that again. How many feet?
33 feet for McDonald's straw.
You gotta be fucking kidding me. Come on. Are you kidding me? 33.
According to the angle. Yeah.
33.
I could have guessed.
Don't you think that's a bit weird?
It is weird, especially since that's the highest that you can use a straw, if it's an inch in diameter at least.
That's also the golden arches. The golden arches look like a sideways 33.
That is true.
But I'm still trying to think how this is viable. The idea is that the globe earthers are saying that that the light is bending and curving to your eye to cause the effect of basically seeing around the curve. So the idea is to get a really long straight tube, and then I'm thinking of it as almost like if you take like a coat hanger, like a piece of metal, and you bend it, like a very slight bend, you're not going to be able to fit that through a tube. Basically, like a slight bending piece of wire, you're not going to be able to, that's rigid, you're not going to be able to fit it through the tube at some point. So is that kind of the idea, that in that analogy, like the bending sort of light that's claimed, that's coming to the eye, that if you had a long enough tube, that bending light would not be able to traverse through the tube, showing that it's bending versus not? Is that kind of the idea?
That's what I'm talking about.
I'm just trying to put it on the scale of harebrained or less harebrained as an idea. So
I don't
Yeah,
think it's that harebrained.
Yeah, but then Geo, what you would have, I think, is two different optical effects. One that you would see with your eye, naked eye, just looking out straight ahead of you, and then one through the straw that's going to change what you see with your eye. And then the only cause is going to be the straw.
How is it gonna change it exactly?
Based on what Geo just described, that you have something that you call a light ray that can't get through the straw.
Right, because it's not completely straight. Or if it is completely straight, it will go through.
Okay,
So-
but again, my point is that when you, so what I can see with my naked eye at 6 miles, sorry for the traffic noise. What I can see through my naked eye at 6 miles probably breaks down at about 3/4 to a mile. Once I get past that, I start to lose resolution. I won't be able to see things as clearly or sharply. Okay, so that's what happens with my naked eye. So when I hold up my camera to my eye and I can see farther, the cause is the oculus. So then if you bring in a straw, you're just going to have the mechanism affecting what you see. But that doesn't prove...
Why? How does the straw affect what you see, other than it being straight or curved, which would block it or not block it?
You're okay. So at this point, this is just a conceptual discussion, right? So if anybody has evidence that anybody's done something like this that we can look at, this is all just going to be pure conjecture.
Right, but you are making claims that the straw somehow affects what you're seeing, and I'm asking how it exactly does that.
Oh, okay. So by analogy, a telescope or a camera lens is just a glorified straw. And if I look through it, I will change what I'm able to see.
Right, because of the lens.
That's what I'm saying. Thanks.
Right, but there's no lens in this straw. It's just a mile-long lens, and the light coming through it will either be the light will either be going through it, which means it's a flat Earth, or it won't be going through it because the thing's curved, because Earth is curved.
Okay, great. So, did you just misspeak because you said there's no lens in the straw? The straw is just a lens. That's what you just said.
No. I didn't say it's just a lens. I said there's just light shining through it, or something.
No, go back. Go back and listen to yourself and come back.
It doesn't matter. I just clarified anyway, so you can address it.
Well, Ed, you know how they claim like through sugar water and it's like bending?
Yeah, have you seen Jesse's video about it?
Well, I'm not trying to go into that. I'm just saying that because of like that concept, if there's an effect like that happening that's letting you like periscope around a curved Earth, then they're claiming that your vision is doing a similar effect. So in general, having a really straight long straw that you're looking through would not allow that curved light to make it all the way to your eye. And then I'm just still trying to figure out whether this is viable to even be. Because the other thing is, aren't you changing the atmospheric conditions inside the straw? Like inside the straw, you might have different temperature, different pressure,
Right, but the thing is, it's just a straw, so there's not going to be much of a gradient, so there's not going to be much refraction. If any.
Okay, so...
Go
ahead.
Oh, I don't know. Oh, I guess I was just, yeah, I know. But well, the thing is though, is that, I mean, the thing you're seeing around the land off in the distance that you're seeing around the curve is much further than the straw length is. So are they saying the light curves and then it straightens out by the time it gets to your eye, or is it still curving that much by the time it gets to your eye?
No. I'm talking about this experiment you mentioned a couple of minutes ago. where you have this rigid thing and the light is shining through it, and either you pick it up on the other side because the thing is not flexing around the gravity of the curve of the Earth. That means it's not going through, or it's a flat thing because Earth's flat and the light is going through. I think that was the experiment you talked about, right?
Okay, so Ed, the question is now posed to you the same way you guys posed it to us. If you can see the light through the straw, is the Earth flat now for you, or will you find out some way of making a new equation to make it round and yet go through the straw?
How would it make it around the curve of the straw? I don't understand.
Okay, I'll say it again. It must be a language barrier. If we do this, or someone does this, and the light can be seen, which then means it's traveling to you in a straight line, which means the Earth is not curved, are you going to go, but the Earth is curved? So now we need to change our maths, massage the maths, not so that you change the straw, but that you maintain your globe belief.
You said quite a lot there, but basically the experiment would have to be done valid. You know, not just we're shining a thing, we can see it, therefore flat. No, it needs to be done
Not answering
specifically.
my question, Your Honor. You're not answering my question, Ed.
Yeah, I am actually answering the question. It needs to be done in a very controlled manner and not just,
okay, Ed,
we're shining a laser over this lake and we can see it. They're flat. No, that I'm not going to accept that.
Okay, great. So, again, for the cheap seats, if we do this according to your specs, we haven't done it yet, but you go, Travis, do this, 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 and this. And I say, okay, Ed, is there anything else? You're like, no, I checked it all out. This is exactly what you need to do. If I do exactly what you say and we see the fucking light, but the Earth's still a globe, so we just need to change the maths.
Wait, what did you say? What was the last sentence? I think you're cutting out or something. Well, it seems like a kind of a way of asking, if something is definitive, will you accept it to be definitive? Is that kind of is that what you're asking in a sense? If it is something that's definitive,
he's basically hypothetically saying that if we do perform this to your up to your standard, Ed, and we see the light on the other side, how do you explain that? Is essentially what he's getting at.
Yeah, if it has to be bending to see around the curve, and then we can show it's not bending because we're seeing it through a straight tube.
I see. Yeah, that would be very interesting, and I would have to accept that. But I'll make this absolutely clear. It wouldn't be according to my specifications because I'm not really an expert in that field. So.
Well, no, I mean, I'm specifying the things that you laid out. Like if we met all the criteria of standard and perform the experiment without any unforeseen variables, and we got
so if other people can do the same experiment and get the same results with the same kind of setup, then why would I not accept that? That's odd.
So at what distance do you imagine this happens?
I don't know.
I don't know if it was as much as of an acceptance rather than the explanation behind.
The explanation behind it, well, I don't know. I mean, it hasn't been done yet, so how can I tell you that?
Right. Let's just assume that it has been done, and the light was seen. Like, what could we fathom? Like, what could we come up with to try to explain away?
Oh, you want me to explain it away that the Earth is still a globe? You want to hear some kind of thing I'm making up then?
Well, not necessarily. I mean, if you have something that you could throw out there, sure. But basically, that's what he was getting at. Like, he's essentially saying that you would. Yeah, he was essentially saying that you would have to change the math to fit what was just witnessed.
Yeah, do you mean like I would have to somehow try to fit this in the globe narrative or something? I thought the question was, are you then going to accept that we're on this flat plane or something? Okay.
No.
Well, again, it hasn't been done, so I'm not sure what to tell you.
Right. No, I understand.
Well, I mean, look, we've had so many good conversations in this room, and I don't understand why we can't get two of us, even Ed and someone else, or Kosho and someone else. Like, why can't we work together and create a scenario where Ed goes away and crunches the numbers with Jeremy, Kosho goes away and crunches the numbers with Geo or whatever, and then they come back and they say, oh, good, look, we got this right, but we're a little bit different here, so let's nip and tuck and get it. Okay, so if we can make an observation that's like, say, 6 miles long, if we can make an observation that's 6 miles long, and we have a straw, blah, blah, blah.
Yeah, I've been talking with flat earthers about these things since Brandon's server, so I'm these things haven't been done, and most of them are flat earth claims, and I don't see why I should put any effort into it other than talking about it when I feel like.
The reason why is because people like me are going out and taking photographs and getting documented visuals that can demonstrate that refraction is the cause for seeing too far and seeing not far enough, or not seeing far enough.
Right,
okay?
well, that goes with the globe model. I'm not sure what the problem is here.
Okay, it goes with both models, Ed. Okay, so both models are still viable. Okay?
There's no evidence for that. You haven't provided anything to back it up. All you have is pictures and your words.
Okay, Ed. If you look at the documentation that I have, I can show you at various distances, 1 mile, 3 miles, 6 miles,
right,
9
and
miles.
What kind of measurements did you take of the moisture levels, of the temperature, and not just from your location, but from everything in between you and the target you're looking at too?
Also, can we not do the interruptions? I feel like you're cutting them off. Just let everyone speak till they're totally finished, you know?
I wasn't trying to cut him off. He had a silence, and I thought, well, this is actually a good question to ask because he's making a claim.
No, I'll give you the benefit of the doubt that maybe I broke up, but I was in mid-word and you jumped in and interrupted me. But let's not worry about that, okay? What I'm trying to say, and you just casually brushed it away, I'm saying we need to do this. Like, I have no interest in doing the math, okay? I bought a barometer, I bought a thermometer, I bought a hygrometer, and yeah, I can't be in 10 places at once. But I'll tell you what's interesting now at this stage is that Ed is now saying what I've said for the past 4 years, that we have to take measurements all along the corridor. So guess how many people that's going to take? Not one, I'll tell you that. But the fact that you're hand wave dismissing all of the thousands of hours that I've put in of my own time and money, and the evidence that I can show you at 1 mile where the obstruction is entirely refraction and only refraction. When we understand that when refraction happens at 1 mile, and then we see that same effect at 3 miles and 5 miles and 9 miles, that refraction. Am I breaking up or something?
No, you're good. He was just hot micing.
Okay. So Ed, again, your hand wave dismissal means nothing.
Yeah, it's not hand wave dismissal. I'm asking you for detailed evidence, which you're unable to provide. So I'm going to have to take your claim as such without evidence.
So are you saying that Rumpus is incorrect when he says all you have to take is your local measurements and then just project it out because it's always going to be uniform? You disagree with that?
It's always going to be uniform. How exactly? Over what distance? Over what are we talking about exactly?
It doesn't matter. It doesn't matter.
Yeah, it does matter because Rumpus Rumpus is extremely detailed. So I need to know what the fuck he's talking about specifically.
He's talking about the fact that when I have said what you said, that we need to take measurements all along the corridor. He says, no, we don't. No, we don't. We just have to take it in all along, and we just know that it's like that all the way.
Okay. Well, I'm not sure again what he's specifically talking about.
I'm telling you.
Well, that's fine. If you think that's what he said, fine, take it up with him. He's not here, so why are we talking about it?
I'm not going to take it up with him because I disagree with him. You and I agree.
Well, fine. Take it up with him.
Okay, listen again. I'm not going to take it up with him because we don't agree. You and I, however, at this point, you are saying exactly what I've been saying for the past 4 years. So thank you very much. So I cannot do anything more than take my proximate measurements and know what I'm seeing, right?
Well, how can you know what you're seeing if you didn't take any measurements in between you and the target?
Do you think that you can look over 6 miles and recognize
Mirage what? You cut out, I think.
Do you think it's possible for you to look 6 miles away and recognize an inferior mirage?
Not necessarily, because you don't know what you're supposed to see if you're not taking any measurements other than, well, I'm just looking.
Okay, so let me get this straight. You don't think it's possible to take a P900?
I said not necessarily.
Okay, so I'm going to tell you that you most definitely, absolutely can notice and recognize an inferior mirage at 6 miles, even with your naked eye at times.
How would you be able to distinguish between what you're seeing and what you're supposed to see if you don't take any measurements whatsoever? You're just looking.
Because I can show you the target unobstructed and clear straight down to the shoreline. And then I can show you that same target 6 miles away, blocked and obstructed by an inferior mirage.
How do you know it's an inferior mirage if you didn't take any measurements?
Okay, is anyone questioning whether or not we're being trolled at this very moment?
Yeah, no, you need to please answer the question. Because if you don't know that it's an inferior mirage, then it could be Earth's curve, Travis. So again, how do you know it's an inferior mirage if you didn't take any measurements?
Does anyone besides Ed recognize that Ed is trolling at this very moment, right now?
Oh, come on. Stop talking about me and just answer the freaking question.
Nobody's going to answer. No one's going to pipe up? Come on.
Yeah, so Gio, are you not going to do anything about this? I thought this is against the rules.
What, trolling is against the rules? I agree.
Don't tell me you mysteriously disappeared again.
Well,
okay.
You guys are doing pretty well. So, I mean,
Ed, what can you tell me about an inferior mirage? What do you know about what makes an inferior mirage an inferior mirage?
Okay, so I'm going to say this one more time. You made a claim you know it's an inferior mirage, and my question to you is, which I asked you before all of this, how do you know it's an inferior mirage if you didn't take any measurements?
Well, you can just see it.
Are you serious?
Okay, so here's my answer. Here's my answer in 2 parts.
I don't think you have to answer that question.
Okay. Am I coming in clear?
Yeah. I would just, Travis, I was just telling you.
Am I coming in clear right now?
Yeah, you're pretty good. I mean, it was a little bit breaking up, but you're kind of clear. But I don't even think you need to answer that question, because if anybody doesn't know what a inferior mirage is, it's just weird.
That's right. That's why I'm calling him a troll right now. It just makes no sense why anybody would say, how do you know it's an inferior mirage? That's absurd.
But I think maybe he is asking how you're defining it as an inferior mirage versus physical Earth curve. Is that right, Ed? Is that what you're trying to... I mean, the visible phenomenon is the inferior mirage. You're not doubting that. You're just claiming whether it's a refractive effect or whether it's an effect of physicality of Earth.
Yeah, if you're not taking any measurements, how do you know any of this?
Okay, so first of all, I have not found any evidence that your side even knows what conditions are necessary to create an inferior mirage. Okay, so that's my first part of that's the first part of my answer.
That's poisoning the well.
No, it's not. Dude. He's just making a statement because he's aware of the in the field.
He's making a generalized derogatory statement.
Okay, I'm going to say it one more time. In my research, I have not found any evidence that anyone who talks about inferior mirages knows what conditions are necessary to observe an inferior mirage. How's that?
Sounds good.
And somehow you know exactly what you're looking at and all that stuff. Okay, interesting.
Okay, Ed, now you're ignoring the fact that I rephrased my statement to make it palatable for you, and you didn't even respond. You went to the second part of my answer that I haven't gotten to yet. So let me ask you again. Did my restatement satisfy your position?
Just say yes, Ed. Come on, man. He clarified it. He's trying to be as minimally disparaging to any other side as possible. He restated it. Can you just accept that part of it and move forward?
I didn't hear it correctly. I heard something about conditions.
Yeah, I'm done.
Well, I want to hear the second part of it. So just pretend Ed said yes, sure. Just pretend.
No, just repeat it, please. I didn't hear it.
No, you can go back and rewind it and listen to the sultry sound of my voice, okay? I'll talk to Geo at this point. Okay, so Geo, answering your question. The second part of my question has to do with how do I know what an inferior mirage is? And that is by looking at it and understanding that it has an inverted mirrored image of the superior erect physical target. If it's a lighthouse, if it's an island, if it's a car, whatever it is in the distance, the car is the physical erect image. And then below that physical erect image is an inverted mirrored image of the top image. There's no differentiation in the image where the top ends and the mirage begins. That's called the vanishing line, where diffraction happens and you lose all the crispness of the linear aspects of the angles and the shapes that are out there in the distance. And then there is a limit to the mirage. That is, it only mirrors a certain degree of the target at times. So there are numerous aspects, the vanishing line or the fold line, a mirrored image, an inverted image, and a particular degree of the event itself. How's that, Geo? Is that good?
Yeah.
Okay.
That's detailed and thorough in terms of the observational effect of it. I think, and I don't know whether Ed still wants to engage in this or not, but I mean, Ed, can you accept that's what an inferior mirage is and that's what's being observed?
Could be a reflection in the water.
Okay, so here's where I know more than you at this point. There's a difference between a mirrored image and a mirage. Can you differentiate for us, Ed? If you're up in the mountains and there's a large lake and you see the reflection of the mountain in the distance, that reflection is on the water. But there's a massive difference between that reflection and if there were a mirage, because the mirage is not on the water or on the ground, it's in the air.
Well, you're not on any mountain, so...
Okay, Ed, again, that is a non sequitur, had nothing to do with what I said.
No, it isn't. You talked about your footage specifically.
I asked you if you could differentiate for us, please, the difference between a mirrored image and a mirage.
No, thanks.
Well, yeah, I mean, it's just not going to be productive to talk with that. Because, I mean, Ed, the next thing, if I were you, I would say, okay, Travis, I hear what you're saying. Okay, yeah, because I said it could be a mirror, and you just define the difference between it being a mirror reflection off the water versus a mirage. Thanks, Travis, for clarifying that for me. Let's continue with the conversation. But
he could just do that instead of asking me silly questions.
All right.
No. So I'll be more specific with you, Gio. Okay. The difference between a mirrored reflection that's on the water, and you can create whatever scenario you want. The difference between that and an inferior mirage is that in the mirrored image, in the mirrored reflection, you can actually see where the target touches the water. You can see the boat on the water, and then you can see the water reflecting the boat, and you can see the water line on the hull. When you have a mirage, you don't have that delineation. That line gets blurred in what's called the fold line or the vanishing line. So if you have a vanishing line or a fold line, that's a mirage that is happening in the air, not on the water.
Can you look in the chat? I posted an image there. Can you tell me where this line is, please?
The fold line you're talking about?
Yeah, he just talked about a line. I forgot the name, and I would like Travis to show me on this image, or tell me if he can show me where about it is.
Oh, sorry. I thought I was unmuted. Sorry. Okay, so if we want to go over to the canopy, if everybody's looking at that image, okay, find the triangle of the canopy, right? The top image is the physical image. The bottom image is the mirrored image. You're not going to have a direct ratio. I would say the ratio of the physical is 2/3 and the mirage is 1/3. So if you just go 2/3 down below that top canopy and draw a line, that's going to be your vanishing line. Extend that line all the way across this image, and it should divide that entire image right where the mirage happens all the way across the image. That's the fold line. This is a mirage. It is not a reflection.
Okay.
Can
it be both?
Technically it can be, but when I'm using the term in this discussion reflection, I'm talking about just a mirrored reflection. I mean, I made a meme about this last year where I showed a mirrored image of a lake with a mountain on it, and then I showed another mountain in a mirage, and they're clearly not the same phenomenon. Clearly.
Yeah. It's like there's more of that stretching and expansion in the center where the fold line than there is when it's just a straight reflection. Like a stretching.
Okay. I still don't see how this can show you anything about if the shape of the Earth is flat or curved. Since you haven't done any measurements, you don't know what you're looking at and what you're supposed to see.
Great. What measurements need to be taken?
Well, I already went over that.
I don't remember. Can you please refresh my memory?
Uh-huh.
No.
Sounds like you're playing a game. So, yeah, you need to account for all these variables for refraction, for example.
What variables? Give me three.
You need to know distances and all that stuff. So, you don't do any of that.
Yes, I do.
Why? It's like it's a good conversation until you go personal. Why can't we just stick with the information?
I am sticking with the information he's providing, and it's his words and pictures.
All right, but he asked you what could be some of the things to measure for. Why can't you just put down the ego, put down the need to attack him and create a shit show, and just do it with your mind only, just logic, and think about what...
I just said it, man. I said the variables for refraction.
Yeah.
What are the variables? What are I didn't hear them. What are the variables for refraction?
Are you kidding me?
Dude, just think about this. Anything that's productive in a conversation is when there's information being exchanged that we can all think about.
But he's had this
ponder
for
and
years. Are you telling me he
right now? And what you're doing right now, the interruptions and the going personal is the least productive thing in the world. If you want to go online and fight with adults, I'm sure there's other places you can do it. So I'm just doing everything I can do to moderate this to keep it a good conversation and not go into shit show land. If you don't want to respond to that, even maybe I could respond, somebody else could respond, but you just try to go to some personal attack. Please just let's not go there. So did you want to respond to it? It's not about like roasting or debating. No one has to be proven wrong or anything dramatic. It's interesting to talk about this, to get some of this information, because what you said is that he hasn't measured anything and so on. So then he asked, okay, what could be measured? Could we keep it productive? And could we at least talk about that so our brains can think about it and have something productive, please?
Yeah, well, my answer was clear. You need to account for refraction. And then he asked, what are the variables? Well, are you telling me he doesn't know that after all these years? He's just pretending.
All right. Well,
Ed, hold on. Don't mistake my asking for clarification, right? Because I want you to say what we can deal with. Because what if I say two things and you're like, oh, that's not enough? So I'm asking you, give us what you think is necessary, and then we can deal with it. I'm not playing a game, so don't misunderstand my trying to be specific by asking you to be clear with playing games. I don't play games.
All right, well, you know what causes refraction. Account for those variables specifically.
I don't. I do not
Come
know
on,
what causes
Travis.
refraction. No, I do not.
This is ridiculous. You know.
Ed,
You've been in this discussion for years.
Okay, then if you're going to say that I should know what the variables of refraction are, then you should know that for the past 4 years, I have been challenging them as refraction. Okay, Ed, I know what they say, but I don't know what the variables are in reality because I don't think that they are correct. So they say temperature, both air and water. They say the refractive index, which has to do with the gradient of the air temperature. And then there's also the relative humidity. And there's also the barometric pressure. And is there anything else that I need? Oh, yeah, the distance, right? And I'm really confused as to why you would say I've not measured the distance when I have used Google to know, have measured how, or at least
Google uses globe distances.
Travis, you were good there, but you just broke up right at the end, just so you know.
Oh, I see.
The last thing, I think he broke up.
I mean, is it cool if we use all that information from a weather balloon that's maybe miles away? Are you good with that, Ed?
I don't use weather balloons.
No, I'm saying if we were to measure the refraction with using weather balloons that were hundreds of feet, if not hundreds of yards away, would you be cool with that?
Well, it would be 8 miles away. So how exactly are you going to measure something that's 8 miles away? Well, what's going on? Oh, it's Travis.
So at least, I guess you guys can hear me.
Yeah, it was real. A unique robot there. It was real bad roboting. Yeah. We just heard you right at the end, though.
Sorry, did you say yes to the weather balloon or?
Well, not really, because how are you going to measure something that's 8 miles away? See, that's the point. You're not
8 miles
taking any local measurements. It's just far away.
So if Travis were to use a weather balloon that was hundreds of yards away and not anywhere near the optical corridor, that would be an issue for you? That's reasonable. That would be an issue for me too. I hear you.
Yeah,
Right,
I'm just taking the standards that have been put on me. Right, I need to have been there. I need to have taken the measurements and all that stuff. So I'm using those exact standards for the information I'm receiving.
No, forget the standards. What would be reasonable to take the refraction measurements of a weather balloon that's hundreds of yards, if not miles away?
I'm not an expert in in that field, so I couldn't tell you.
Oh, all right. I was just wondering.
You see, the difference between me and Andrew Thomas Young is that I'm not trying to figure out what causes the inferior mirage. I'm not trying to figure out what causes looming. I'm saying that in this observation, there's an inferior mirage, which limits my visibility. And then I have another condition where I see farther, and there's no inferior mirage. So I can see those things clearly. I don't have to write a mathematical equation. I can show you cause and effect. Here is the shoreline. Here isn't the shoreline.
You're cutting out every other word.
God damn it.
Travis, you in the Northeast?
I think he's in the North Pole.
It's wild smoky here. Did Coach ever come back with the straw math? Just curious.
All he said was the straw would have to be 33 feet long.
Of course, it had to be 33.
Of course.
That's not bad.
Okay, so I don't mind
33 feet. Go ahead, Travis.
Yeah, I don't mind repeating myself, because I'm in a. I don't understand how we can drop calls in this day and age, but what I was saying before was that I don't need mathematical equations to explain what I see. I can look out, I can see a target at 6 miles, and I can see the shoreline beneath that target. I just see it. It's just right there in front of me. And then on another day, I can't see it. Why not? What changed? Oh, there's an inferior mirage there. I don't need to write a mathematical equation. I don't need to figure out what the fuck caused the inferior mirage. I don't give a shit. All I'm saying is that I can say and see what I can see and say what I see. That's the simplicity of observational science.
Hello, is anyone in here?
Yeah, I'm here, Jeremy. Close the door so we can be alone.
Oh, my bad.
So, Ed, what other variables? I mentioned pressure, temperature, humidity, distance. What else do I need?
Well, you need those things not just at your location, but you already agreed with that.
I agree.
I'll answer by saying whatever else might make a create a different index of refraction in the air.
Great. So, please, Ed, for the love of God, please help me find even one goddamn source that says, oh, by the way, kids, if you want your teacher to take you out on the Chesapeake Bay so you can see an inferior mirage, here's the kind of day that you should go out. I would love to see something that simple that a 6th fucking grader could say, Mrs. Jones, will you take us out to see an inferior mirage because we know all the variables. And Thursday, all the variables, like, it doesn't exist, Ed. It doesn't exist.
I personally think that in order to know which way the light's bending, yeah, you could do temperature, pressure, humidity readings all through above and below the optical corridor. That'd be neat. But and that can be only be done with something that's not subject to refraction, obviously. So some tangible thing, I don't know how else you would know, but
well, listen, can I go back? Did Ed, did you hear my plea to you?
You want me to give you more variables that is could cause refraction?
No, I want you to help me and all of us really by simply taking some time. Like, make your own schedule. But tell us, like, oh, Travis, I need a month. And then go away for a month and try to find some school website, some EDU website that will tell you if you want to go out and see an inferior mirage, or if you want to go out on and see looming, this is the day that you need to go out. Could you do that?
This is the day that you need to go out. Okay, so you're asking for a website that specifically predicts refraction in your local area as opposed to just the weather. Is that what you're asking?
Yeah.
Why the fuck would such a thing even exist?
Because your science seems to think that it can cross every T and dot every I and make predictions. Okay, this has been the whole argument for the past 5 years. Where I have been challenged by your side to make these predictions.
Okay.
So your side, Rumpus and Ruhith and Wiggles.
They're not here. You're talking to me. Please stop mentioning other people.
Well, you're pussing out, so I have to appeal.
No, stop lumping me in with other people. Just talk to me.
Okay, well then stop pussing out.
Stop what?
Being a pussy.
What the fuck are you talking about?
Do you not think that a mirage can be predicted if the science seems to think that they know what causes a mirage?
Sure, but why would anyone make such a website that would predict local refraction phenomenon across the world? I don't see the motive in that.
Well, either you're being dishonest or you don't belong in this conversation.
Can you just give me any reason to make such a website, please? What incentive would there be to make such a thing?
So that people could know when they can go out and watch a Fata Morgana in their area.
Oh, I see. Well, don't those things exist in the desert?
What day should I go out to see those things? And no, they don't just exist in the desert. I've captured a Fata Morgana here on the Chesapeake Bay and on the Channel Islands.
How do you know that? You just said you don't know what's causing them.
Okay, Ed, either you're stupid or you're a troll. Which is it?
Yeah, that's not a reply to how you know it was what you're saying it is.
If you have been paying attention to me this far, then I've already answered this question. So the fact is, either you're not listening, which is being a troll, or you're stupid, because I've been very clear, and I think that anybody else here could say, yeah, Travis has already addressed this, Ed. You're just not being honest.
Argumentum ad populum and a false dichotomy.
Oh, now you're worried about being making fallacious arguments. Oh, great.
Well, I'm just waiting for an answer to my question.
Is the false dichotomy you could be stupid and a troll?
Well, yeah, that's one of the other options, sure, but there's even more options.
Okay, so, Ed, do you think that science has put out descriptions of what a Fata Morgana is?
Can you just explain to me how you know what you're looking at? when you don't take any measurements.
Because your goddamn science has page after page after page after page of EDU sources that tell the reader what a Fata Morgana is. That's how I know.
Okay.
What else you got?
Still waiting for the incentive to make a website that tracks local refraction phenomena.
Do you not think that it would be helpful in the same way that you could teach a child how to plant a seed and understand how the seed germinates and grows? And, oh, look, Johnny, you can do it yourself. Oh, dear teacher, I was just reading about inferior mirages. Surely we can go out and watch an inferior mirage. And she says, well, Johnny, we have to know the conditions. We have to know this. Well, here, let's look it up. Don't you think that science can be reproduced, can be demonstrated, can be tested and observed? Do you not think that science can be observed, tested, repeated, and verified, Ed?
Right. I still don't see why you would need a website that tracks local refraction phenomena. You can just look up what's causing those things, as you said, in a science textbook or a website or whatever. And then you can see what the weather is in your area and check if such a thing would even be possible to appear under those conditions.
Okay, Ed, I have 2 textbooks, one from the early 20th century and one from the later 20th century, and they only describe the phenomenon. They don't tell you how you can go out and see these things for yourself.
Okay.
So it doesn't exist, Ed. That's what I'm trying to say. So now we're back around. So
did you just look in those old-fashioned textbooks, or did you do an internet search as well?
Fuck me, man. What part of I have done research myself for the past 4 years and have tried to find this information? What part of that, which I've already said 3 times, didn't you hear?
Well, you're talking to me about fucking textbooks from the 20th century, so...
That's because you made an appeal to textbooks, you dick.
Yeah, well, guess what? There's more than just the fucking 20th century, dickhead.
Show it to me. Show it to me.
Okay, settle down.
Show me a textbook, Ed.
Everyone settle down.
Show me a textbook, Ed. Hey, Ed. Show me a
what's
textbook.
that?
Show me this textbook that you're talking about.
No, thanks.
Where is it?
I don't know. Go look it up. You want to know.
I've looked it up for the past 4 years and I can't find it. Will you help me?
Sure.
Yeah, I mean, Ed, can you? I mean, I think. Okay, I don't want to speak for Travis, but I mean, I think what I'm kind of hearing in a certain sense is that, you know, there's a lot of sciences in the world. You know, chemistry and, you know, biology and, you know, studying insects and all of these different things. So mirages are part of like the earth sciences, and it would be within that field. And of course, the effects of miraging and how the earth looks over a long distance is also related to the shape of it as well. So there would be a strong, you know, need or desire for humans to understand these effects and all of the conditions that cause them, and how that potentially also relates to the shape, you know, for various purposes. Like Travis was saying, you know, if you to learn how, you know, a plant sprouts or how chemistry works or any of these things. So I think, like I said, I'm not speaking for Travis, but kind of what I'm hearing in a sense is that he's suggesting that perhaps there's a lacking amount of data and information to isolate and solidify these different effects and exactly what conditions cause them, and how, if we knew that scientifically, then we would know, oh, okay, these are the effects that cause an inferior mirage. So if I go out on a day that has these types of effects, I'm going to get the inferior mirage. So the fact that that doesn't exist, it does seem like, if nothing else, it's sort of an empty hole in, you know, the earth sciences and in sciences in general. Whether or not you think it's productive or not, or whether there should be a website that you could go to do it or not, can you at least understand that sentiment?
Not really, because yeah, you guys seem to misunderstand something, I think. I'm not calling you stupid or anything, but the majority of people on Earth don't give a fuck about what the shape is. It's only it's only in these servers that. Can you just let me finish?
Sorry.
It's only in these servers that this topic, this quote unquote debate, is such a heavy thing in people's lives.
I don't give a shit. You're a fucking troll. You are now appealing to the population as a
no. I'm answering Geo as to why there's not such a website predicting refraction phenomenon in your local area.
What the fuck does what the population have to do with science? Don't you think that if some scientist 200 years ago took all of these measurements, that would be reproduced and reproduced and reproduced if it's been verified, so that other people can just look? Okay, we have verified this for the past 200 years. They're the numbers. It doesn't. They don't fucking care who believes it.
At some point, people are going to stop reproducing and testing it, and it will just be something children do to learn science, to get introduced into science.
Yeah, but I mean, you're kind of debating like what the usefulness. I mean, there's a lot of things in science that probably a lot of the mainstream population would see as completely irrelevant to them, to their personal lives. Yeah, I know, but that's not really what the discussion is. I'm sure there's someone out there or people who think things about whatever, and there might be groups of people that don't care about how a refrigerator works or something, but that's just not really relevant to the discussion. We're talking about, data and information and science about the very earth we live on.
Right, but he's asking me for things that predict refraction phenomena, and under what specific conditions, and he's claiming this information doesn't exist. Well, I just did one search, and I'm finding tons of websites that explain to you what's causing a mirage. So if if you apply those conditions and see, well, the weather now is cold here and warm there, so that should give me whatever, then you can try to find those conditions locally and go to them and see if it works.
Okay, Ed, choose one of those sources. Okay, just choose one.
Why?
Hold on, because you're having a discussion and you just said that you just did a search. Did you not just do a search, or were you lying?
No, I posted even one for you in the
Okay, well, I'm walking right now. Okay, great. I'm walking right now, so I'll look it up later, but I'm going to tell you this right now. Every single time one of you guys has posted a link and I went and looked at it, it fucking didn't say what you said it did. So you just go to the first link, find one thing that you think relates to this discussion that we're having that explains what causes a phenomenon of refraction.
Yeah, I'm looking at it right now. It says how a superior mirage is formed. And it's giving you observer, line of sight. It's talking about warm air and cold air. It's giving you an example.
Stop.
So then if you go look for those conditions of the weather that's being described here in this thing, then you might find a superior mirage.
Okay, warm air and cold air.
I'm just using the words that are written there. I'm not going to explain everything in detail. You can look at it yourself.
No, Ed, I've already looked these up. This does not tell you what the conditions are. It just
does.
Okay, what's the condition?
Again, I'm not going to explain it in detail. You can look at it yourself.
Ed,
but it is what you asked for. So Ed, just telling me, no, it doesn't exist without even having to look at it, no, that's not going to fly.
Ed, I'm walking right now. I can't look at my phone.
That's fine, but then please don't say it doesn't exist until you've seen it.
I didn't okay, listen. I didn't say it doesn't exist. I've said that I have looked for descriptions of when you can go out and see these things on particular days. When you have a description of superior mirages, which is basically cut and paste of all the other cited sources, they just cut and paste from each other. It says something about warm air and cold air and inversions of temperatures. Okay, that doesn't tell me anything about the condition of the day.
Yes, it does.
Okay, great. So what temperature must the day be?
Again, I'm not going to go over the exact details. You can look at it yourself.
It's very generalized. I mean, I could read it here. It's what Travis is saying. I could read it, but yeah, it's very generalized. It's not.
It's too general, Ed.
No, it isn't.
Okay, great. So what temperature must the day be, Ed?
Again, I'm not going to go over the exact details, and you're walking outside anyway, so just get back to me after you've read it.
No, because I'm not going to waste my time. I already know.
You're not even going to read the source you asked me to post. Are you kidding me? This is so dishonest.
Yeah, are you not the one who's being dishonest? How hard would it be for you to tell me right now what that paragraph says the temperature of the day must be and the temperature of the water? Why?
Yeah, no, I'm not going to do any of that because you asked me to post something specifically, and I did what you asked. So there. Now go look at it.
I'll read it. The part that's relevant for the inferior mirage. On a hot day, the sun rapidly warms up the Earth's surface, which in turn heats up the air directly above the ground. It creates a substantial difference in air temperature between the warm air near the surface and the colder air above it. A medium with non-uniform properties has now been created with cold air, which is optically more dense, situated above warm air, which is optically less dense. Since the light follows the quickest path, it says past, I assume they mean path, and warm air with less resistance. Sorry, I'll read that again. I'll say path because I think that's what they meant to put. Since light always follows the quickest path and warm air with less resistance is much faster to travel through, the light will bend towards the hot air close to the ground.
So Gio. Okay, so Gio, my question to you is, what's a hot day?
Well, I mean, exactly. There's lots of different definitions of that, depending on...
What the fuck constitutes a hot day, Ed?
Well, I think what you want is something, for example, if you're going to boil water and you're at a particular pressure and a particular, altitude, and then you apply a particular amount of heat to a particular vessel and a type of water and all those factors, it's going to boil at that temperature. So somebody could tell you at this altitude, at this temperature, and this type of water, et cetera, it's going to boil at that. It sounds like that's more what you're talking about, something that would be solid.
Right, but guess what? I have photos and video captures of inferior mirages before the sun rises. So it's not a fucking hot day.
What are you even talking about? Have you ever lived through a heat stroke?
Okay, Gio.
Heat streak, I mean.
Really?
Really? Like in the weather.
Give him the hook.
Yeah, he's just saying, dude, that they don't always happen on hot days with this explanation that was just given. I mean, the thing is that these refractive effects are connected to the shape of the Earth. And I'm not speaking for Travis in this, but it does seem as though there is not, like, in terms of the sciences that are out there on all kinds of things, like germinating seeds, like Travis mentioned, all these other things out there, there's quite a bit of science that is out there on it. But it does seem like with mirages, there's like, whether it's purposeful or whether they're just there's no funding in it. Andrew Thomas Young is sort of one of the experts, and even his information is it's a bit like Swiss cheese. There's like lots of holes and calculations and just information he doesn't have, and he's like the PhD world's expert on it. So it does seem like, and again, I'm not speaking for Travis, but it seems to me like there's a lack of scientific clarity and of the variables and factors of what is causing all these effects. And ironically, that it is connected to the shape of the Earth because it has to do with, how the Earth appears over long distances. So it does seem like there's like there's some lack of clarity here in this. Is that
yeah, that's fair enough, Gio. I appreciate that. That's fair.
Okay, well, again, I'm finding tons of websites that pretty much explain it.
Yeah, so have I. They're all cut and pasted the same thing. They all say the goddamn same thing, Ed, which is nothing.
Okay. What do you mean it's nothing? That doesn't add up.
Tell me what a hot day is, Ed.
Well, hold on, Ed. You would agree that this is very vague. This is very vague. Yes, it does describe it a little bit, but I mean, this would be like akin to if you said, well, just get some water and heat it up. I mean, that's not really enough to tell you which temperature is going to boil at because of altitude and all these other specifics. So this is really not giving specifics. You'd have to agree with that, right? It's not saying you have to have X amount of distance of this temperature, which, and it has to maintain this temperature. And then the pressure has to be maintained at this level. And if it goes over that level, it'll shift from an inferior to a superior mirage. Or, there's none of that. Like, there isn't detail. I mean, this is just sort of like a little bit of a fly-by-night, description, very general.
So Ed,
disagree.
Okay, so Ed, what do you imagine constitute? Let me ask. When does a day become hot, Ed?
I don't know.
Well, I mean, they're using that to try to describe the hot and cold air differences.
Yeah, it's explained in layman's terms. Yeah.
Okay, great. Explain it to us.
Well, Gio already did that.
No, he didn't. He didn't tell us what a hot day was.
Right, it's explained in layman's terms.
Which is nothing. It says nothing. The fact that you are not admitting to this is incredible.
I don't need to admit anything. I just told you it's layman's terms. But what don't you understand?
Okay, Ed, what is a layman? What's a layman, Ed?
Well, I'm just gonna refer you to the dictionary since you keep asking me to define words. Just go there.
No, because if you asked me, I could just tell you with my own words. So can you not speak your own mind?
Well, word before you're making an argument about it. So why don't you go ahead and just make your argument?
Oh, man. This is just gold for anybody who finds this. Like 50 years after this, somebody's going to find this and just be amazed at how incredibly dishonest you people are.
Did you not have an argument to make about the word layman? If not, then why even ask me what the definition is?
You don't misunderstand a question as an argument. Because questions are not arguments, Ed.
Right, so that's why I'm asking you for your argument instead of asking me silly questions. Well, if you don't have an argument about it, then why even ask me what the definition of the word is?
Well, I know you guys are on the brink of going into an all-out brawl here, so let me just ask to keep it in the realm of productivity. So, Travis, if this information was, well, let me ask you this, Travis: if you had the equipment to test all of the variables throughout the entire corridor, and you could then use that in correlation with the observations of the mirages, like if this information was available, what would that provide for us, or what would that be able to isolate? Maybe that's the question. What could we further isolate from that?
Okay, can you hear me clear all right?
Yeah, you're good.
Okay, so I've made this statement on my channel numerous times. If I were able to put together the dream team, my prediction is that we would find an X factor that either they never knew about or that they've been withholding that information. I don't believe that the simplicity of air temperature, water temperature, relative humidity, barometric pressure, or whatever else is enough. I think that there's an X factor out there that they're not telling us about.
Such as?
I don't know because I don't have the fucking dream team to go out and do these experiments.
Yeah, so there's also a lot of implications in it because if we had all that ability to test and measure everything through that whole corridor, the claim of the globe in terms of why we're seeing the Earth in an extended planar geometry a large majority of the time when we can see very far, that is a refractive effect that they're claiming is occurring. And if we had all these variables, we then could start to isolate whether that effect is occurring or not. And yeah, so that starts to really dispel or get to the root of that. Because if you have all the factors, for example, if let's say why water boils. I don't know if I'm going to be able to pull this analogy together, but I'm just thinking if they were making some claim that it's something other than heat causing the water to boil, if we then started doing all the measurements to see what was going on, what was going on in the environment that you're heating up the water, if you were able to isolate that the thing they're claiming it is not there and is not consistent, but these other variables are, then yeah, that starts to like weed out and isolate, what is going on and what's not going on. And perhaps
right. But there's something else happening here. It's the other way around. It's not like someone's making this claim of this other thing happening. Well, actually it is, because that's what Travis said. He said there's this hidden factor. And I'm wondering, how did you determine this hidden factor even exists?
Okay, are you ready for my answer?
Yes.
Okay, my answer is that I have looked up all of these websites, taken their generic information, and I've seen the effect in a variety of circumstances that contradict what the literature says. I've seen it in the wintertime. I've seen it in the springtime. I've seen it in the summertime. I've seen it in the fall. I've seen it in the morning before the sun comes up. I've seen it in the middle of the day. I've seen it in the latter part of the day when the sun's down. Like, I see it all the fucking time. And so there's no specificity. So then the temperature doesn't fucking matter. The barometric pressure doesn't fucking matter. The humidity doesn't fucking matter. So then I've eliminated those three. So then there's something else out there, and there's nothing left to eliminate. So then there's an X factor out there.
But
okay,
then we're back to my original question. How do you know all these things if you didn't make any measurements?
Okay, I've made goddamn measurements in my local proximity, Ed.
Yes, in your local proximity, and not as we agreed between you and the target and at the target site.
I can only do what I can do in my proximity. So here you go. Here's another example.
I understand, but that doesn't mean you know what you're looking at if you didn't take those other measurements.
Please don't interrupt me.
Just don't interrupt, please, Ed, please.
Okay, and then there is the Sky Free channel. And the Sky Free channel takes measurements in a localized area, not across the entire corridor because they don't have more than 2 people. But when they showed us the measurements, before they showed us anything on video, they showed us that the air temperature and the water temperature were exactly the same. Okay? So guess what that means? Okay, so guess what that means you're not going to see? You're not going to see a mirage. And guess what they fucking showed us?
Where was this measurement done? Was it just at one point, or was it across a huge area?
Okay, how much of what I just said were you not listening to?
Well, I did listen. I'm just asking if this was a local measurement or was it done over a huge area, because you're saying the temperatures are the same. I'm wondering how does this same temperature, how far does it go?
I told you they were 2 people. They took a local measurement, and because they were only 2, they couldn't do it farther along on the corridor. But that's beside the point, because okay, listen, how about this, Ed? How about this? Since you are bringing up your standard of taking the measurement all the way across the corridor, please find me any source that even goddamn mentions taking multiple measurements along the corridor.
Well, there isn't any, and we both talked about this, and you agreed with me that those measurements need to be done.
Right. So how is it that the sources that you're looking up can even propose to say what they're finding if they are not making these measurements themselves?
I don't know if they have made those specific measurements.
It's
not mentioned there. Why? You just asked me for how those things can occur in the first place, what the conditions are. And I went and looked, and there's tons of websites that describe these conditions to you.
Yeah, but they don't tell you that you have to or don't have to worry about taking. They only tell you if it's a hot day. Well, it seems like it's a hot day, and I don't see an inferior mirage.
Okay.
Yeah, so you mentioned that like some other factor, like an X factor kind of thing, meaning it just reminds me real quick, like Weston A. Price, he went around studying like tribal peoples back in like the 1920s and 30s to study their diets. And I'm not trying to do a long thing on him, but he labeled that there was a nutrient that he called activator X, and he didn't know what it was at the time, but he had reasons to indicate why it was there. And what foods it was found in, and what the effects of that nutrient were. And like I said, he just called it activator X, and the science at the time didn't know what it was. Nowadays, I mean, he's passed on, of course, but nowadays people do think they have an idea of what it was. which I'm not trying to go on a long thing on that, but I'm just saying that it's similar only in the way that he was going out studying these traditional ancestral diets in these tribal communities, finding that there seemed to be a nutrient very rich in their foods that was causing them to have. He was a dentist, and so he was studying their teeth health, and they had immaculate teeth health. And they didn't even brush their teeth. They weren't swishing with any antibacterial anything, and they had no, they didn't have any cavities. They didn't have, they had these immensely strong teeth, and so he was like, okay, what is causing this? What in their diet is very high in their diet versus people in the Western diet that have cavities and have teeth that are problematic, gum disease and all the rest of that. So yeah, so I'm just saying that I only bring that up to say that what you're mentioning reminds me of that in a certain way, to where you're observing things that don't necessarily fit the simple explanations that are given, and you're seeing in some ways contradictory effects in these mirages depending on the conditions and depending on the what they claim it is. And so that partly why, like, you're seeing something occurring that doesn't just fit the simple explanations, and therefore are thinking that there could be some activator X type of factor or some other factor that isn't currently being understood or explained properly.
Yeah, that's precisely what I'm saying. Yes.
But
Right,
what
but
was
then
that
this
thing for the
this
tribe?
doctor.
Sorry to interrupt, but you can't just leave us hanging like that, Gio. What was that thing in the tribe for the teeth?
Yeah, I want to know too, actually.
Well, currently, many think that the actual nutrient, there's a complex of nutrients that come very rich in animal foods and certain animal foods. But the one that they think is the actual activator X is vitamin K2, MK4. So there's two versions of K2 that are well known about, MK7 and MK4. So this is a vitamin K2, and this is the MK4 format. And the MK4 is this, it's a very unique, interesting nutrient. It's only found in animal foods. It's very, very rich in these animal foods that these traditional diets are eating, like liver and eggs and raw dairy, butter, raw butter, things like this. And this, the vitamin K2, MK4, and it's this incredible nutrient. Like, it seems to it essentially tells the minerals where to go in the body. So that's one of the things it does. It's implicated in a whole bunch of components of health with the immune system, the nervous system. It's like this core nutrient that seems to have a profound effect on multiple areas of the body. But in terms of the teeth, that vitamin K2 MK4 has this mineral organizational process to it, meaning it organizes the minerals and tells them where to go in the body. So it instructs those minerals to go to the bones, in this case to the teeth. And so since your saliva is in your mouth, it's always mineralizing your teeth. And if your diet is very low in this MK4, this vitamin K2 MK4, your teeth are not getting mineralized properly by the saliva, which then causes other decay and cavities and so on. So when you have a high level of that MK4, it seems to change the condition of the saliva and the blood for the bones as well, but the saliva for the teeth, and causes this exceptional mineralization, which is what is currently modern day, along with other nutrients. It's not only that one, there's other ones that go along with that, and they all come in the animal food complexes. But yeah, it's the vitamin K2 MK4 that they currently think is the closest thing to what Weston Price was labeling as activator X.
Interesting. Okay, sorry guys, I had to know that. Okay, go on with your convo, guys. Sorry.
All right. Well, what I was gonna say in response to that, that is a good point, Gio, but that's not what's happening here, because Travis doesn't have all these measurements and he doesn't know all the specific conditions.
I don't have to have all the
So I wasn't finished. So you can't compare that to this doctor guy who
I don't have
actually studied I wasn't finished. So you can't compare this to this doctor guy who studied all these things and was an actual scientist and who a lot more about the human body, etc. Do you see why it's a false comparison?
No, it's not, because I don't have to have.
I was asking Gio, man. Come on.
Well, let Travis respond, and then I'll respond next.
Yeah, since all of your sources that you can cite have general descriptions, I don't have to have all the measurements. I just have to actually know that it's a hot day.
What I was going to say, Ed, I think they're actually pretty similar in some ways to what Travis is doing. Obviously not identical. And obviously Weston Price, we only have his documentation in his books and things that he wrote. But I mean, a lot of what he was doing was, observational, meaning I don't know how much, he was taking samples into laboratories and doing blood samples and things. I don't know that, his entire lineage in terms of that, but it is similar in a lot of ways because he was going to these tribes. And when he was going to these tribes, he didn't have like microscopes necessarily that he was looking at their blood. Now, I'm not saying he didn't take samples and do some of that. I don't know all those details, but he was doing a lot of observational correlational, like looking at their diets. And these are thousands of people through hundreds of different tribes all around the world. He traveled all around the world. And there's actually a lot more history to this because he actually was one of the ones that helped form the American Dental Association. And then he got sort of shunned and pushed away because he was discovering how nutrition was actually linked to health, to oral health. And he got pushed out, quite heavily because obviously, you get into the mercury fillings and the huge conspiratorial part about dentistry and, all of that. And so I'm just saying he got pushed away from that. But my point is just to say that he was doing a lot of observations, literally going to these tribes, writing down, okay, these guys are eating, animal bones and bone marrow and raw eggs and this and that. And, and then he was also documenting between what the people in the tribes ate and then people from those tribes who went to the Western world, to the Western culture and started eating lots of sugars and grains. And then he would compare those. So they had the same genetics because they were from the same tribe. One of them stayed on their traditional diet. The other one started eating all of the modern, foods that deteriorate the body. And he was able to compare those two. Anyways, I'm just saying what Travis is doing in some ways is similar, meaning doing a lot of observational work and comparing and contrasting through a lot of different scenarios. I'm just trying to relate that to Weston Price, just analyzing these diets and analyzing the sort of the genetics and all those correlations. So I'm not saying it's an exact
right, but the doctor guy analyzed the diets and whatever. But what is Travis doing exactly? He's just looking at things and not really doing anything much more. How is that the same?
I guess you could say Weston Price was just looking at what they were eating. If you want to try to make I don't know how deep we can go with this analogy, but he was going to these tribes and reporting what they were eating. Like I said, I don't know, especially back in the 1920s and 30s. They didn't have, advanced spectrometer testing and microscopes. They had some of that, but it wasn't the same as it is today in terms of all the advancement of that part of it. So, that's why he wasn't able to isolate what it was until nowadays. They were able to isolate more of these compounds, and then they were able to isolate this vitamin K2, MK4, far after he passed away, and they were able to isolate it. And then they were doing further, able to do further tests on it and so on. So, I think in that way, it's similar that obviously Weston Price was not able to do the scientific detail to figure out what that was, but he was doing a tremendous amount of observational and correlational and all the documentation and everything he was doing. And he was onto something that there was this activator X. And then later,
of course, and I'll give you that.
If Travis is finding things that are either contrary to the mainstream explanations or to what Andrew Thomas Young is saying or others, then for you just to sort of disparage Travis and just say, oh, he's just out there taking photos, that's not fair. I don't think it's fair for you to do that. He may be onto something very valid, and I think that's worth for you to consider.
Well, I don't think it is, because this is not the 1920s anymore, and the atmosphere and all this refraction stuff has been studied just as much, if not even more, than this nutrient you're talking about.
Well, then
so they're both on the same level. So if this factor X even existed, they would have known about it by now, just like this nutrient you're talking about.
Yeah, which means that they don't know about it. Okay, I'll be positive and say that they don't know about it. But you seem to think, again, Ed, that the information exists out there and you haven't provided it, and you won't be able to provide it.
But that's what I was going to say. I did. Hold on, I didn't mean to interrupt you, Ed, but that's what I was going to jump in and say. I was going to say that the thing is that what Travis is asking for is not even trying to get what Activator X is. He's just trying to get something more than these vague descriptions, hot air and cold air wafting around. He's trying to at least, you know what I mean? And you look into Andrew Thomas Young's work. Now, I haven't looked at every single thing he's done, but I've looked over at his work in enough detail to see of what he's doing. And, I would say sorely lacking for anyone with a scientific mind who really wants to see what the phenomenon's going on. There's a lot of calculations and assumptions and radius values thrown in, a lot of just sort of drawings of things, not even linked to the actual observations. So I'm just saying, dude, like there's very little from what I've seen, and I agree with Travis that, you know, of actually correlating these things scientifically. So for you to say, well, it's not the 1920s, we've done all that, I think that's what Travis is asking, you know, where have you seen that? Because you know, he hasn't found it. I haven't found it. None of us can find any of that information, even at the top levels. So that's the thing. It doesn't currently exist so that we could go out and test it and validate and even isolate some of these effects, especially then getting to the thing of that we're
well, millions of people have done that, and I posted 3 links just now explaining what you're asking for. So there you go.
All right. Well, these are Andrew Thomas Young's links. You just linked 2 of his from his website, and then you linked Wikipedia. Okay, I guarantee you Travis has seen all of that. Guaranteed.
Okay, well, then his question is already answered, and for him to pretend otherwise is just dishonest.
Yeah, I mean, at the end of the day, I don't think he's looking for the answer from you. You're here having the conversation. I appreciate you trying to keep it in the realm of civility. So
he literally asked me, Travis, did you not want me to post those links for you?
No, I didn't want you to post links that I've already looked at and have determined are insufficient in their information. No, I did not ask you for these links.
Okay, well, if you're asking for something that you already quote unquote know doesn't exist, then how do you not understand that that's dishonest?
Ed, okay, just to clarify, I'm not going to attack you. Here's a clarification. Please provide a citation that helps someone, in your words, a layman, let's call him a 7th grader, middle schooler, secondary, who could do these observations themselves based on the information so that they know what day to go out on because of the temperature of the air, the water, the humidity, and the barometric pressure. Please.
Yeah, I did that. I did exactly that.
Get above this stuff.
No, you didn't.
Yes, I did. You didn't even look at them. You said you were walking outside. How the fuck do you even know what I posted? And I just posted 3 links for you, which have a lot of text in them. You couldn't have gone over all of them just now in those couple of minutes.
I didn't.
So please stop this crap.
All right, but let's just be clear though. Again, so Travis, what are you asking for again? Just so we can be clear.
If the science is clear about what causes a mirage, we should be able to test, observe, and demonstrate, thereby verifying the information.
Yeah, stop kicking around like you get above the water, Travis.
Yeah, so I mean, it sounds like Travis is asking for something that, you know, he's not finding in those links, and
he didn't look at them, Gio.
Well, dude, he has studied.
Hold on, Gio. Let me defend myself in this instance. If you have linked Andrew Thomas Young 3 times in Wikipedia, I've already looked at those sources, Ed.
Sure, buddy.
Yeah, I mean,
see, there you go. There you go.
Well, then you have your answer. If you already looked at them, then your question is answered, and to pretend otherwise is dishonest.
All right, but Ed, just looking at this more in terms of having a high productivity type conversation, I don't think it has to be about like, you know, he's roasting you and or any roastings going on. I'm not even saying he is roasting you. I'm just saying I don't think he's asking you in the way of like, you know, provide this, Ed, or else, you know, you're going to the gauntlet, you know, pull the trap door and you're going down to the pit of snakes.
Are you sure? Because I remember 10 minutes ago.
Interrupting me. Please don't interrupt me. Just let me finish. Okay, so I don't think he's necessarily asking to try to pull the trap door to send you in a pit of snakes. I think he is bringing forth the question of what he feels is information that is currently not available or is missing when it comes to the detail of these mirages and how it links to the other components. I don't even think he's linking it directly to the shape of the Earth, perhaps, but there, you know, and so on. And he's just saying, like, the first one you posted is kind of a weather type page, and it does give a very general kind of grade school level idea. And then you linked Wikipedia and Andrew Thomas Young. So I don't think he's trying to like roast you on it. I think like he has looked at those. And so I think there's information that is not there in terms of what he's looking for. And perhaps he's just trying to maybe expose in a way that this information doesn't exist. I don't think he's trying to expose you and say that you don't have it. I think it's just a matter of trying to just sift through the information. So I'm just trying to just in terms of like the productivity, you know, what information is and isn't there, and then what he's looking for. And I don't think you have to provide it in some way like this. He's just elucidating it. And if anyone could provide this, or if he could find this, it could be helpful for his work and others as well. And if it hasn't been found, then it's a missing part of the earth sciences that needs further work done on it. And perhaps that's what he's bringing forth.
All right. Well, I have provided it, and he didn't even look at the links. He's asking me, if you posted this, then that, meaning he didn't even look at what I posted. He does try to roast me, because at the beginning of this conversation, he was already calling me either stupid or dishonest for disagreeing with him. And he is linking this to the shape of the Earth, and so did you, like 15 minutes ago or something. You both told me that this refraction thing was linked to the shape of the Earth. So everything you just told me is exactly opposite of what happened.
Well, I'm just saying there's more benefit to using each other as a sounding board to either to learn or to glean further information, rather than just waiting to pull a trap door and send someone to do it.
Yeah, I know. And that's what I'm trying to do, Gio. But Travis isn't. He's calling me dishonest or stupid since the beginning.
Well, I know. We're just trying to fend off any form of like shit show brawl fight that may happen, right now. So it sounds, but just getting back to the information, Ed, yes, you have sent those links. He could look them over again, I mean, I should stop speaking and let Travis speak. I guess, Travis, could you clarify why Wikipedia? All right. Well, I guess maybe he dropped out with his connection, but he would have further information as to why those links are not providing what he's asking for. And I think that's where the meat of it is.
I'm just saying a 33-foot straw might solve this.
That's you non sequitur. You're I was going to say you're non sequituring like some other individuals non sequitur, but yeah.
No, with the whole refraction thing.
We got to build a cement foundation for it.
Yeah, you're right. It is connected. Yeah, that's true.
Yeah, we just need a 33-foot straw. We don't need any ditches. If we do, though, I mean, I'll be there with my shovel.
What's a 33-foot straw?
That's how you cut down on refract. You get a 33-foot straw. You go on a day when there's heavy refraction, like some black swan shit. Okay, we got a 33-foot straw. We got a light out by the oil rigger, the light on the oil rigger sun.
So
we look at the light. You get a theodolite. You have the straw and the theodolite horizontal at the same elevation, right? There's a little thing on the side of a theodolite that tells you where the crosshair is. You put the straw just right on that, level with that, and then you look and you should see things in different spots, because the straw is going to cut down on the refraction, because the light can't bend to get to you. You're only getting the light rays that are going straight.
It's a real straw man fallacy, Jeremy.
Still confused.
Oh, that's good. That's a good one. I like that. Who said that? You're on my list.
That's Barrel Rider. Barrel Rider for the win.
You're right.
Like, how are you sort of making sure there's no pressure gradient? Can't do that.
What pressure gradient?
Pressure gradient.
Where?
In the atmosphere.
Well, when we go out and there's a black swan. When we go out and there's a black swan day,
right?
And you guys are saying there's this massive amount of refraction. If we cut down on the refraction, we should not be able to see the oil rig through the straw, or the light on the oil rig, or whatever we're looking at.
33 feet straw?
Well, of course, it had to be 33 Freemason Illuminati shit. That's your people's. But I'll be right back. I got to vacuum the rug.
Well, I'll try to summarize it, Ruhif, and perhaps if you have any opinions on it. I'm still not fully clear on it. So we're trying to figure out where on the scale of harebrained or non-harebrained this idea is amongst all the other ones we've talked about, and try to see which of these are practical or not. So I'm still on the fence myself about it. But the idea in general is if you had a long tube of some sort that, like the idea that the laser is like the laser through sugar water, like it's bending. So if you guys are claiming that that's what's causing things to be seen over the curve, that similar sort of bending effect, then you can't fit a bend laser through a straight tube. So is there some way to have a straight tube that the light can't bend like that to isolate whether actually it is bending or whether everything's coming at you straight? That's in general the concept, I think.
Okay. Yeah, you just have the long tube. If the Earth's curved, it's going to curve with the Earth.
But again, how do you make sure your tube is straight? This is just a physical test again, right?
This one's still technically optical, really, although the tube would be physical, but you're still using an optical observational. But the 33 feet is just, Kosho had tried to do some calculations of how much the angle is it's bending around a presumed globe, and then what that would fit through, how big of a tube you'd have to have, a diameter and so on.
But then there's going to be sag in the tube, and you're going to have to prop it up. Like it's just, these physical things will never work.
No, you get
Is the tube not going to bend according to the gravity of the Earth, or just stay straight because it's a flat Earth?
We're going to make it out of metal or something. We're going to make it out of metal.
Right.
Metal still bends. Like these physical things are silly.
Metal is just going to bend?
Yes.
We can't have it supported by some 2x4s or beams or something?
Yeah. How do you verify that it's straight?
Well, if you can see through it, for one. If you can see through it.
Yeah, that's what the laser is for. If you can see the laser, then it's just according to flat Earth. If you can't see it, then the thing bends according to gravity in the curve.
If the straw's the laser lights, will I be able to see out of it?
If the laser's bending with the tube, then you'll think it's straight, and it's not.
How's it going to do that?
Through the pressure gradient, it will bend.
A small tube that's going straight ahead. It's going level.
Yeah, but you can't. How do you verify that
it's straight? If the straw is straight, we'll be able to see out of it. If it's bent, we're not going to be able to see out of it, right?
Yeah.
Well, what if the light is bending at the same rate the tube is curving?
How?
Well, we're going to have it horizontal. Well, I don't know. Can we make something horizontal for 33 feet?
How do you verify it?
That we have a straight tube for 33 feet?
I don't think you can do that, no.
We can't make something straight for 33 feet, really?
No, 33 feet is not a very long distance. You're not going to get a lot of curve, so it would need to be longer. But the whole concept, I think, is valid.
I don't. I don't think any of these physical type things are valid. I don't think.
No, that's just because you don't want that to be the case, and perhaps for your globe thing to be not the case. You just want to come in here with your same stuff and say your same stuff and do your thing. It sounds like you don't really want to work with us to actually predict.
No, but hold on, Gio. He said that the light might be bending with the tube, with the curve.
Yeah.
How would it do that?
Verify that it's straight
inside of it?
It's level.
Yeah. How do you verify that?
But if the light's bending and the tube's straight, then you can't have that bendy light that would reach your eye in the same way because it hits the wall of the tube.
How do you verify that the tube's straight?
Yeah, those are certainly challenges. Yeah, I mean, if it's only 30, 40, 50 feet, that's different than, if it has to be longer. But yeah, there's ways to do that. Yeah, I mean, that's a topic, part of this that would have to be deciphered.
Yes.
I mean, I feel like we can make something straight for... I feel like we can make something straight for 33 feet, at least. If we can't do that, we might as well fucking pack it up.
Do we need to bring up? Do we need to bring up LIGO? Do we need to bring up LIGO's straight tube for their claim of how straight they can get a tube?
Yes, LIGO is the example. Yes, because they've got a vacuum tube, so light will travel straight.
Yeah, but you just said how could you build a straight tube? But LIGO's done it, so why are you saying it's impossible?
Yeah, because the light verifies that LIGO is straight. Because you've got straight light.
Great. So then we'll make a tube, we'll vacuumize it, make sure it's straight, and then we'll pull off the caps and
No. Well, hold on, Gio. You don't need to quote unquote make it straight. You just need to make sure it's level, because then the light is going straight through it, which means if it hits the other side, then the thing is straight. But if it doesn't make the other side, then it's curved because it goes with the curve of Earth, even though it's level.
It's just not possible.
Why not? If it's a vacuum, you just said if it's a vacuum, then the light travels straight.
Yes, if it's a vacuum.
Right.
If it's
So
a vacuum,
why not just make a vacuum in the tube you're using then?
Yeah, that'd
Okay.
work.
All right, let's do this.
Just add the funding and we're good to go.
Or you could just hire a theodolite for half an hour, go and make a single measurement from one mountain to another. The end. Welcome to the globe.
Well, I'm just saying in general, the funding, once the funding is available, then that's what will be required, because there's a lot of.
I'll give you $25, Geo, to hire a theodolite.
No, that's what I'm saying. I was just clarifying that I'm not asking for your funding or anyone else's funding. That's all I'm saying. I just didn't want to make it sound like I'm asking you for funding. I was just saying in general, the funding is required for these things. Yes, the financial, because these are expensive projects and people have to take time off work and et cetera to be able to do these things.
But why not do something simple and inexpensive?
With what?
With a theodolite.
You're saying something different than what we're talking about, or?
Yeah, go up, measure, drop. The end.
Well, that's what I'm saying. So I know that's what you want to do, but it's like, I guess just, I guess you don't want to be in on this. That's all. It just sounds like you're not interested. So that's fine. It sounds like Ed is. Ed's higher on the wait list than you are, it sounds like.
Sure. I don't understand why you don't want to do a very simple, cheap method for measuring drop.
Because I'm not conflicted of the fact that optical drop happens in the environment, and that I don't think that's a way to decipher the shape of the Earth from. We already know that. I mean, there's wavering effects, as it were, up and down, like the Skunk Bay footage and other settings that show that, and so that's like
get away from the surface.
Like a warping effect, essentially. So that's not a way to measure the shape of the Earth. If you want to just keep pushing it and think it is, I guess, see if you'll get someone on your hook someday. But it's just not of enough depth to be interesting to me.
Okay. Get away from the surface, and then you avoid all the rubbish with Skunk Bay, right?
I don't agree that it's only something that's on the surface. I don't agree with that. I think it's throughout the entire medium in different ways, at different levels. But I don't think it's just as easy as get up off the Earth and just go with Ruhif's little shtick. That's not that simple.
The data says that it is. Once you get above the surface, refraction is predictable and it's downwards. So if you're on a mountain looking across to something of the same elevation and it appears below the crosshairs, welcome to the globe.
Yeah, I mean, it is a globe. We live within a globe, in my viewpoint. I think the ether is spherical, and we live inside of a toroidal field, and there's multiple scales of toroidal fields. Within those toroidal fields, there's spherical geometry, so there can be these effects that you're referring to that have a spherical component, but it's the medium. Ultimately, I think we live on a planar surface within a sphere, so there is a spherical component to it, and that sphere that we're within, the ether has a toroidal structure to it. So I'm not surprised that those effects are happening, but you'd have to find a way to isolate between the atmosphere or the ether functioning in a spherical fashion or having spherical geometric qualities to it versus the Earth having spherical qualities to it. And if you're only shooting something through the medium, then the only thing you're really isolating is something happening in the medium. Now, that medium is related to the Earth because you have your target or whatever it may be, but there's a major factor of the medium. So is the medium spherical or the refractive effect spherical, or is the Earth spherical? And if you're just going to jump to one because you have a bias towards it and then try to assert that, I don't see that as a fully valid, conclusive approach.
Okay. So you talked about going for a black swan thing through a 33-foot tube. Do you think you're not looking through the medium as well?
Yeah. No, you are. Yep.
Yeah.
Yeah, but the light can't bend like that.
Right, but the bendy light, if you have a straight tube, that's going to block the ability for it to bend. That's the thing. When you have a boundary like that, you have a boundary inside the tube.
For 33 feet over a distance of 10 miles or whatever.
Well, that's what I think is problematic about it for what they're saying. Yeah, you know, the idea of that laser, like the green laser that's bending through sugar water, if we're imagining that that's, you know, okay, the thing that's behind the curve and it's bending like that laser, if you're only got a little short tube, how much is it really bending at that 33-foot thing to make a difference? You know, like I feel like the tube would have to be way longer.
Yeah. It's still not going to stop bending. And then you got to vacuum it out, right? Like it's just, you've got LIGO. LIGO is the straight thing. And then you've got get above the surface where refraction's predictable.
Well, we may need to create something. Yeah, with all this discussion done on LIGO over these years, ironically, we may need to create something similar to LIGO as one of the several things we'll do. And so, yeah, there may be a way that will need to be replicated, because there's a lot of benefit to having a straight tube like that for a lot of different tests that could be done. Compare that to water, and yeah, being able to create a vacuum within it so you can compare that. And so, yeah, there's a lot of benefits to that. And I don't think they're going to let us use their thing, so we'll have to build our own.
LIGO. You can get the elevation profile of LIGO. It's already done.
Well, let's ask them if we can host a birthday party there, so we can just have full use of. Well, we can have full use of their facilities for 12 hours. I'm sure they'll let us.
You don't have to go there. They've got LiDAR data for the tube. You get it off the internet, and if you plot the elevation profile, it's a curve. So simple.
We already know the elevations. Blue
Right,
went
so
through it with
why
me yesterday. Did you miss out?
What? Say again?
We already know the elevation profile.
Right.
Blue said it many
know
times. As a matter of fact, I had a convo with him here yesterday. You were here, Ruhiv, weren't you?
Little bits and pieces. So the elevation profile is curved, right?
Well, Blue says from one of the arms has a 4-foot drop.
But if you plot the elevation versus the distance on a graph, like an XY Cartesian plane, you get a curve, right?
Not a curve. He says there's a drop.
Nope.
One of the
I'm
arms
telling you
has
that
a
if you plot
4-foot
them,
drop, and the other one has a 1-foot drop.
right, I'm telling you, if you plot the elevation, you get a curve. Oh, sorry.
You can say whatever you want. I'm just telling you, have you done it?
Yes.
You went to LIGO, you plotted the elevation.
No, I've plotted the elevation from LiDAR data.
LiDAR data. Do you have a copy of it?
Do I have a copy of the graph? Oh, I could make one again. It took me 10 minutes.
Oh, the LiDAR that you're talking about, because this is new. You just brought this out, right? LiDAR?
What do you mean brought it?
You're the first one to talk about this that I've heard.
No. Go to a channel called Cinnamon Control. In fact, I'll find a link for you. One sec.
I don't know Cinnamon Control. I'm talking about people here, us guys.
Let me, oops, where is he? Oh, fuck, he changed his channel name. One sec.
So you're saying, let's get this straight. You're saying the straightest thing in the universe, you're saying that is curved.
No, I'm saying the elevation profile of something straight is curved. The elevation profile.
The elevation profile of something straight is curved. Wow, that's a statement right there.
Are you saying of the Earth under it? Is that what you mean?
The dot, therefore, is curved.
That's what he's saying. You know, you're saying the tube is straight, but you're trying to say that LiDAR picked up a curved elevation profile.
Yes, exactly.
Right. And
sorry,
this LiDAR,
let's see it.
It's done from like airplanes.
I'll try and send you a link.
So you're saying the concrete underneath it is thicker in some parts than others? Is that what you're saying? How do they do this?
It has to be raised up in elevation. I'm gonna find the Cinnamon Control video.
Let's see this.
Cinecon, that's it. Hang on. Cinecon. There he is.
So you're saying the concrete is leveled. It's raised. It's different elevation due to the Earth's curvature.
Yes.
But it results in a level plane of concrete.
Hang on one sec. I can post it now and then I gotta go. All right. Let's see.
You're gonna go on.
Geo. Yeah, well, I've got to pick my daughter up. I'm at school. All right, there you go.
Well, that hardly solves anything. To be continued.
Yeah. All right. Cool. See you soon.
All right. I measured LIGO. Yeah, I bet you did. So this is what they're trying to say. They're trying to say what he's trying to say, that because the Earth is curved, there's a different thickness of the cement underneath LIGO. So I was going to ask him, does that mean it's complete level surface? And I guess we didn't get a response to that.
Level to what?
To the plane? Is it a plane?
LIGO is not level to Earth.
LIGO is not on a plane?
It's not level to Earth.
What do you mean it's not level to Earth?
Well, when you're saying something is level, you're using it as an adjective, so you need to say what it is level to.
He said that the elevation is different underneath LIGO, the cement, because of the Earth curve. And I asked him, does that mean it's thicker in different places? And he said yes.
Uh-huh.
Mm-hmm.
Okay.
Okay.
Yeah, so what's next?
You tell me.
Why? It's your argument. You were asking questions.
I was asking him, not you.
Right. But so, was there any logical conclusion to this questioning you had, or?
Well, you'll have to wait until Ruhiv comes back and I have a conversation with him, because I don't wish to have this conversation with you.
I see.
What I was going to ask Ruhiv was, are you in agreement with your buddy Blue that this level surface of concrete that you say they made, the arm that's on it, right, which is the most straight and level thing in the universe, are you in agreement with Blue that the center of the tube is lower and either end is a foot higher on one of the tubes? If you're listening, Ruhiv.
He's not here. But you used the word level again, so well, what is the LIGO thing level to?
SE.
Joe?
Man, I thought you were ignoring me, dude. And then I realized my mic wasn't even plugged in. Hey, I was pretty upset though when I hadn't realized that. But anyways, but I feel better. Anyways, my point is, a second ago you asked if we agree with blue, right?
Yeah.
Blue Marble of Science, right?
Yeah, Blue Marble Science. Did you hear the convo I had with him on LIGO?
I was not here, but I generally trust his judgment. And I heard you ask if we agree that he believes it's horizontal, I suppose, halfway, like it's leveled halfway between one of the arms, as in at that point there would be a horizontal. Is that right?
Well, he has a diagram, right? And he has the elevation profiles, the as-built elevation profiles. And one of the arms, starting from the apex down the right arm, is a 4-foot drop. And the other arm, which is on the same plane, which he agreed to, has no 3-foot drop from the apex to the other end of the arm, but in the middle of said arm, it's 1 foot lower, and either end is a foot higher on that arm.
That's fascinating.
It is, and all this is on a plane, mind you. Yeah.
Well, I have to tell you, I never thought I'd see the day where I disagree with blue. And I still don't see that day, because I definitely agree with him, yes.
So you agree with him. You agree with him that there's a plane, there's a 2.5 mile and 2.5 mile arms stuck together at a 90, and one of those arms at that point where they're stuck together is 4 feet lower at one end. On the other end, the other arm is not, but the arm in the middle is lower in the center, and either end of that arm, which is stuck to the other arm, is a foot higher. Now, the other arm that's lower by 4 foot is also lower in the middle by 1 foot and higher at either end. And you believe this, all this on a plane on the straightest thing in the universe. And you, Kosho, believe this and agree with Blue.
Give me 20 seconds. My life is on my name is on the line, so I have to just verify something. Hold on. It should only be 15 more seconds.
Process this carefully.
He's got the earpiece in with Blue right now. Blue, what do we got?
Hey, man, hold on. I can't hear Blue.
What do I say?
Like the CIA guys with the little earpiece in their ear.
His handler.
Guys, I can't hear Blue, man. Hold on.
It reminds me of Dana Carvey does, like, in his comedy skit. I don't know, he used to talk about like the George Bush Sr. and George Bush Jr. And he used to joke about how, once George Bush Jr. was president, he does this thing where he's like, yeah, he's got it. He's like, George Bush Jr. has an earpiece in, and then George Bush Sr. is like, big daddy to little daddy, big daddy to little daddy. I'm not able to do it nearly as funny as he does, but yeah, it's funny.
Dana Carvey did a good Bush. He did Bush Senior though, I thought. He did Bush Jr.
He does them both.
Oh yeah, that's right.
But his senior.
Yeah, he was good. He was good that day.
Yeah, I think his George Bush Senior one though is maybe a bit more famous in a way because he was like opening Saturday Night Live shows, like, when he was president for a lot of those, and I think he says he's met him, and they have a camaraderie.
Didn't he do the church lady as well?
Oh yeah, of course, yeah.
Yeah.
Yeah. Okay, back to did your handler fill you in? Corso?
He filled me in and he felt me up. And I'm
Yeah,
pressing
I'm sure.
sexual harassment charges on him. But that aside, hold on one second. Let me just verify again. Yes. You use meters, don't you, SE, in Canada?
I prefer not to, but yeah.
He said, okay, hold on. He said 1 foot.
He said 4 foot drop on one of the arms, and the other one no 4 foot drop, but from the center of the arm is 1 foot lower, and the other ends, the extremities, are a foot higher. So if you were to put a basketball, 2 basketballs on either end of the arm, they would roll to the center. The straightest thing in the universe.
Yeah. Other than me, of course. But do you know if he was using any estimates? Like if he was rounding, or if he was using estimates, or if he was being pretty precise?
Sounded pretty precise. He got the as-built numbers, so I'm sure they were pretty precise. I mean, he doesn't deny any of this. He says it clearly. I have the thing. I'll post it. Hold on. You can hear it for yourself. It happened here yesterday.
I'll say this then. I'll say this because Blue knows his stuff. So I'm not an expert on this. I'm actually just. I remember I heard Rumpus say this in the past. I heard him say that in the past. I would say that if I were sort of going off of what it looks like, I'd say that numbers he gave was maybe a close estimate, like rounding it to the nearest foot. But yeah, that's just about right.
Sounds about right. Anyways, if you doubt it, I posted the convo we had here last night.
I mean, I believe it. Sounds right.
So you believe something on a plane, which is the straightest thing in the world, has a 4 foot drop on one side, not on the other, and both arms are lower in the center than either extremity? This is what you believe?
Absolutely.
Okay. All right. So be it. You realize for that thing to operate, the mirrors have to be aligned within, what is it, 1/10,000th the width of a proton? I think that's pretty small. And you think there's a 4 foot difference in elevation? Yeah, you need to do some more research on the subject. Kosho?
Yeah. But I think what you're talking about is the fringe, is the what do you call that? What do you call that when they overlap? The interference pattern. That is what's within a thousandth of a nucleus of a proton or something like that. Is that right?
Yeah, it has to be aligned within that accuracy.
Mm-hmm. Yeah, the lady who, I mean, you know this because you've seen this stuff, but the lady who aligned them or worked out the technique to do that, she got a Nobel Prize for that, right?
Not so sure if she got a Nobel Prize, but yeah, I'm the one that brought up that lady. And she explained the whole thing. They couldn't figure out how to do it. And she goes, wait a minute, we have a freaking laser here. Yeah, so she figured out the pattern that it should reflect on the TV screens. And she was going through the whole thing. There's a 10-part series on YouTube on it. Anybody can watch it. They explain the mirrors, the masses, the passive system, the active damping system. They explain the noise, the Faro cavity for the laser, so on and so forth. A remarkable piece of machine, if it works the way they say it does, because I find it highly suspicious. But that's another issue.
Oh wait, maybe it was a Nobel Prize. It was a MacArthur Fellowship. Maybe.
Yeah, she explains it very nice, very calmly, and she goes through the whole thing. She even explains how they're working on another project that they want to, forgot what she said there. They want to add another piece to it to make it even more powerful. LIGO, that is.
What's that? What other piece they gonna add?
It's a while ago. I forget the exact details. Something, because they've reached the limit to how fine they can detect, and she said something about splitting light, or I forget the exact. I don't want to do it a misjustice. It's been a while since I read it, but somehow they're going to manipulate the light so they can get it to a more fine frequency, so they can detect even a finer amount.
Is it the same lady though?
Yeah, the same lady, yeah. And she explains it very, very well.
Wow. I saw that they were gonna, they heard the conversation we had in here, and they're gonna use Jeremy's idea and use McDonald's straws, straighten them out.
Well, now you're messing with strawmanometry. You're in big trouble now. I'm stepping back.
Yeah, honestly, man, that's like the last straw.
Yeah.
This will be the straw that breaks the camel's back.
It's the one.
Well, I agreed with Blue because I saw the data as well, like that thing that Ruhiv posted. It
You
shows it in
can't
the video.
believe in that. Come on, man. You can't believe a thing on a plane. One side is 4 feet lower than the other, and the other one isn't. And they're in the middle. They're straight, but they're bent in the middle, higher at either. You can't believe that nonsense, Gosho. Come on. You're backing up your buddy. I get it.
Well, I'm backing up the data, specifically the data that comes from, what was it? Let me see here. It comes from, well, they're trustworthy, I'll tell you that. USGS, that's who it is. I trust those guys. Actually, I really do trust them.
Have a look at that, man. Just have a look at that. And you tell me.
Wow.
Yay, SE is here.
Is that a football play?
Looks like it, huh?
A little bit.
A football play.
It does look like a player there. Pass it to that guy. Hike.
No, it's hike, then pass it to the guy.
Yeah, true that. So you agree with this? We're in agreement, Kosho?
Absolutely.
Okay, man.
You have to agree with everything SC Montreal says, because if you don't, that would be dumb.
No, he's agreeing with Blue on this one. Totally. He always goes against what I say.
And that always. So I like about SCs, you want to do to you bring research, you research things and you bring it you look into it before you come up with a claim. So
Why do you not do trivia over gems anymore? So bored with you not doing trivia.
It's a good question. It's the bot. You know what? Because you brought that up, I'm gonna. No, it's not. This is broken. It's a lot of things. But let me get back to work on that. Actually.
Okay.
Did you read the comment, Kosho? These elevations, this is Blue talking to Bev now. These elevations are taken directly from the as-built, Bev. Unless I copied them down wrong. That's what they are, okay? So I'm sure that answers your previous question.
Why would you see that on a flat Earth? You can't see that on a flat Earth. That's stupid.
Do you know what you're seeing there?
Yeah.
You know what you're looking at?
Well, the one on the left here, it appears to be a ship off in the distance. I can't tell because it's too small. And then one looks to be a city in the distance or an island.
Are you looking at my thing at 2 past the hour?
Oh,
You're looking at a
wrong
picture
thing.
of the ocean?
Yeah.
That's not what we're talking about.
Oh, 2 past. Oh, the fucking soccer play or the football play.
Yeah, Blues football pass play.
What is this?
3, 2, 1, hike, LIGO.
Okay. Perfect. Well, good job with the illustrating. I'll say that.
That's Blue. That's Blue's numbers. She's got one arm dropping 4 feet. Not the other one. Both arms are lower in the center and higher at either end on the plane. Yeah.
What's your problem now?
That's my problem.
Are you saying there can't be topography that's off a plane? What do you mean? I don't get it.
You realize we're talking about LIGO, right?
Oh, this is LIGO. I'm sorry, you have it covered up with the red lines.
Yeah, this is LIGO. The straightest thing in the universe.
It is.
According to Zanuck.
That's man-made.
Sure is.
Good job. The Earth is flat. Awesome. You win. Now what?
Who said anything about the Earth being flat or winning?
I just
So you
did
concede
just now.
You give up?
I just did right now. Like, did you not hear the words coming out of my mouth?
All right, welcome. I think we have fresh orange juice and donuts.
Do you? I like coffee. You gotta have coffee, fresh coffee. I like a little spot at night. It helps me go to sleep.
We had some, but Ruhif drank it all.
This is fascinating. You know, I've never seen this before, but I'm looking at the entire plans for LIGO, like the actual blueprints.
Blue sent them to you? Bet you sent you a whole bunch of literature, huh?
He wrote me a poem, sent me some pictures of himself. No, I found these
Did he write
copies
you
myself. I'm not in contact with Blue, dude.
Tell that rotten, stinking SC this and that.
That sounds more like me.
I'm not in contact with Blue.
You guys can't support this stuff, man. Come on, snap out of it.
How come she can't argue over here without getting kicked? Sucks.
What kick? Don't be saying stuff like that. People argue like crazy here.
You gotta be all calm.
If you don't interrupt
quiet,
and swear, you won't get kicked.
If I what?
When did you get kicked? When you didn't deserve it?
Man, four times in here, out of the 10 I've been over here, I've been kicked out.
Well, you must have done something.
Well, I should just say server muted, and then put on timeout.
Well, you must have done something. I repeat.
Well, I called somebody a name once. Like a fucking retard or something like that, I think, probably.
Just one time, one name like that without a warning, you were muted? I doubt that, but it could happen.
I was getting a little mouthy, but it wasn't very long. I mean, I might have said maybe
I'm sure you were.
Might have said 3 rude statements in a row, maybe, but that's it.
Let me guess, in the middle of a heated debate while a lot of people were talking?
No. It was just me and you.
Me and you?
Yeah, the last time I got kicked in here was fucking me and you.
I don't remember. Honestly, I don't remember.
Yeah. See, it wasn't that bad. That's what I'm trying to tell you.
Well, it wasn't me that booted you, so I can't speak on the matter.
It was probably Gio. He's very strict in here.
If it was Gio, no, he's very lenient, as a matter of fact. If it was Gio, that means you had to have done something really, yeah. Because sometimes he's too lenient, I think, if you ask me.
Well, I guess it's a good thing you're not server boss.
You bet your ass on that one.
I think Kosho should be.
Kosho's a mod?
Is he?
Yep.
Kosho's good like that. He can
Kosho's
stay
mom's
calm.
a mod.
He can stay calm for hours and hours while people drill him with stupid. For days on end. for somehow. Like, this is some people like that. You know what I mean? Like, sometimes if I try, like, if I go in with the right mindset, that I'm just like tell myself that I don't care what happens. I am not going to raise my voice. I am not going to say something mean. I'm just going to take whatever is coming to me and then like meditate on it for a minute and then do it. I can do it. But like after that, like, you know, unless I prepare myself, there's just like only so much stupid I can handle before I just start calling people retards and shit.
Yeah, but you see, that can't work. I'm with you on that, believe me. But that can't work on a platform like this.
Sure it can. You just get kicked.
Exactly. Yeah.
Yeah, but you can go up to that point. I mean, sometimes it's faster than others, maybe.
That's why most of the people in here, if they were in a bar face to face, they wouldn't be talking like that. They wouldn't be behaving like that. Everybody knows that, right? Like the guy in the car giving you the finger.
I have a lot of days at the bar that would prove you wrong.
Well, so do I, to be honest with you, but yeah.
But if I wasn't drunk and I was face to face, I probably wouldn't act like that. I might just
Yeah, and the people that do, they get taken care of and they won't do it again.
Yeah, I usually just walk away.
Yeah, but you know what I mean? The civility, yeah, changes people when they're not face to face.
Yeah, I mean, but that's just the problem of anonymity. You know what I mean? Like we're basically anonymous on here. Well, for the most part. You have to try really hard to, you know what I mean? But yeah, I mean, anonymity makes monsters of us all eventually.
Yeah, and enable certain characters to just come and antagonize, knowing that there'll be no retribution.
You mean like Witsit?
No, I mean like you. You're the prime example of that.
SC, do you think you act different though? Do you think you act different on here than if you were to be talking, live in front of people?
I talk the way I'm talking to you right now, but I can't get like. It depends on the aggression level on the person I'm talking to. The aggression, the behavior of the other person. Because I grew up
like that in real life too, though, right?
Yeah.
You know what I mean? Like, I just feel like some people on here act totally out of sync with how they do in their everyday life, you know? But I think that's like, I don't know, disingenuous or some form of dishonesty or something. Because I don't know, I act exactly the way I would on here than I do, if I'm with people in real life. So I don't know what makes people act different, but I don't know.
Yeah,
I guess I
like,
just
if you
don't
met
give everybody.
Yeah. If you met me in real life, I'd be talking to you the same way I'm talking to you right now.
Right? Exactly.
I think for me, it's I generally act how I normally am in life, like most of the time, like 90% of the time. But like most of my days are filled with like stress-filled requests and problem solving and just stupid people talking at me, and I gotta deal with a lot of shit all day, like in a very nice professional manner, where I can't talk back or say mean things, or it's my job or like, business.
Yeah, but that's also like not a normal situation too, you know?
Yeah, but then when I come in here, right, and then like I get stupid, because I'm like,
party time.
I take some of that stress out. I take some of that stress out because I make believe like you were the guy that called me and gave me a bunch of shit that wasn't my fucking
All right,
fault.
I can see that. That's a good point.
Yeah, at least
That's
he's
a good point.
honest. Yeah, exactly. A lot of people do that. Yeah. Stress relief. Yeah.
Yeah, if you have a tough job where you gotta swallow shit all day long, I could definitely see you know, when you're off the clock coming on here and just, you know, acting a little bit skewed towards the other direction because of it. You know, I can see that. That's a good point.
It just shortens my patience. You know what I mean? Like I said, I can only put up with so much stupid shit. I only got so much well left because it's already been eaten up from putting up with work, you know. So like I can only take so much stupid shit, and I'm just get frustrated. I'm just like, fuck you, man. You're fucking stupid.
Like, ma'am, I told you 7 times the procedure to follow. Damn it.
Yeah.
The red wire.
Stop using the emergency stop switch to shut off your fucking machine. God damn it. How many times have I got to tell somebody that? It's like written there right near the fucking emergency stop button. Do not use to turn off machine. Christ.
Ma'am, can you please check and see if it's plugged in? Oh, sorry, sir. Oh, man. Oh, you're right. It's not plugged in.
No, the ones that really bother me are like, your technician was just out here to do our regular PM, and now our machine is not running. It's like, what did you guys do? It's like, well, probably fucking nothing. It's probably your dumbass.
Yo, Damon, correct me if I'm wrong, but didn't you tell me years and years ago that you work with some sort of measurement devices that measure pressure, something like that?
No.
Something to do with the atmosphere?
I mean, pressure sounds familiar because I work with I'm an air compressor in the air compressor business.
Oh, okay.
So maybe that's.
It was like 4 years ago. 4 years ago, I think it was, and I thought you were talking about how you've worked with like some sort of device that could read something to do in the environment in the atmosphere, and like you had an idea to set those up between your position and some observed position, and so you can measure the atmosphere in some way. You don't think you said anything like that?
That wouldn't have been me. I mean, I understand all that stuff because we have gauges that are atmospheric gauge like set for 14.7 basically, and then the other ones I forget what it's even called. I haven't looked at that information in a long time, but no, I just work with air compressors. I'm pretty good at working with air compressors, but that's it. Do glass, blacksmithing, play a lot of music.
Yeah, I know you do that as a hobby, though, right? Blacksmithing.
Yeah. Yeah. Stop reminding me.
Was nothing wrong with that, but yeah. So you with air compressors, I mean, you can basically make like you can sort of make a vacuum chamber, sort of by like refiguring an air compressor, right? Yeah.
Yeah, I got a pump out here right now. I'm actually gonna change around to a vacuum. I got two older air compressors of the same model. I'm gonna put them together because one of them's got a good this and the other one's got a good that, and I'm gonna put them together to make things.
I have one of those blowers. It's like a really it's like a it's supposed to, I don't know what it's for, but I'm gonna use it to clean my computer.
Like a squirrel cage blower, or like something for like pumping up shit, or what?
I think it was for paint. I don't even know what it was originally for, but I'm going to use it to clean my computer. It just compresses air. It doesn't actually compress it. It just blows it.
Yeah.
But it's pretty powerful.
Those are dynamic pumps.
Okay. Yeah, because you can't. They don't actually have like a trigger or anything. It's just like you plug it in, turn it on, and it just blows. But I could sort of reconfigure that as a vacuum pump, right?
It depends. I mean, basically, what you're looking for is any kind of pump that has a valve system on it. Like if it's just a dynamic blower, then no, it's not going to make a very good vacuum. I mean, it'll make a vacuum, but it'll be very minimal. Like, you know what I mean?
Yeah.
It'd be like maybe a 10.
And basically as good as a vacuum cleaner.
No, well, vacuum cleaners work pretty good actually, because the way that they're set up, they're really powerful. Well, like even though they're dynamic and they have to run the whole time to keep the vacuum, that they spin so fucking fast and move so much air that they could probably pull an okay vacuum. Not like a pump though, like an actual like valved pump. That's what you're looking for, is something with a valve on it.
Yeah.
Because you can't allow that back pressure to.
Yeah, right. To just go back in there. I mean, couldn't you attach like a hose to like a vacuum tank and then like have a valve, like just set up a valve, in between the vacuum cleaner and the vacuum tank?
Yeah, I mean, literally, you can make a valve with just a piece of like a piece of decent like hardwood, some plastic, and some tape. Like literally, that's all you need. Maybe a spring to, you know what I mean, attach to the other side to force a little bit of close, and then when you're sucking the vacuum, right, the valve will open up, and then as soon as you turn the vacuum off, like the valve will close, and then it won't. You know what I mean? You just need something that once you shut that dynamic pump off, that it doesn't leak back out real quick or leak back in.
What are you guys talking about?
Vacuum.
Sorry.
Stupid shit about vacuums.
Oh, sucking air out of an enclosed space.
Yeah, the best thing to use is a piston pump, like just piston with valves, like any kind of finger valve on either side of the plate.
Hey, did someone send paid NASA Shield to the other server? To Asylum?
Yeah, I think it was Apocryphon or.
Yeah, no, he's over there and he's just ranty now. But I was trying to get him kicked off. I had to leave the server. Fuck it.
Wow.
He's just a cunt.
Sorry.
He's just going on and on about fucking sextants and celestial navigation, and I said, "What does that even prove?"
I like my new favorite one that I learned from a recent debate. Was that PhD Tony? You know how like you think about things and then you hear something, like you think you know something pretty well, and then like you hear something and you're like, holy shit, how comes I didn't fucking think of that? Like kind of like I was like, wow, that's really simple. I didn't even think about it. But 4 equidistant points. You can map out 4 equidistant points on the Earth. So which point to point is always the same distance. On the Earth, it ends up being about 7,500 miles between the points. But the only way that you can get 4 equidistant points is if you're on a 3-dimensional object. You cannot get 4 equidistant points on a flat plane.
You mean four? Yeah, he means 4 points equidistant from one another. All of them equidistant to the other 3. Not like a square.
Yeah, but what does that even show? Like,
that's
the Earth is 3D anyway, so
3-dimensional shape. Like,
well, okay, so find 4 equidistant points on the flat Earth that are 7,500 miles apart.
Yeah. The problem is we don't know how big the flat plane is, do we?
Well, it doesn't matter. I just told you to do that because you can do that right now on the Earth.
Guess.
No, you can. I can give you the points if you want.
No, I know what you're saying, and I could visualize it straight away because I've studied maps my whole life.
You have a three-sided pyramid. It's basically an equilateral pyramid.
Yeah.
Yeah, but when you draw them together, that's the shape you kind of make. But if you put it on the surface of the Earth, right, you can connect them from the outside.
Mm.
Right?
Yeah, well, okay. This is what I'm saying. This is what
This
is what these controllers do, right? You just said you heard one point, right, about that. You brought it up. All the time, the mind control globers, and their leftist handlers, they bring up one specific point to talk about. So, like, one guy's ranting about sextants and celestial navigation, and you're talking about these points on a map or whatever.
Oh.
So that's it. What does it even actually? Doesn't actually prove anything.
Well, look, okay, so I think what you're getting at is that, like, certain people have certain interests, or certain people have certain, expertise. You know what I mean? So
yes,
or like pet projects. You know what I mean? So, like, of course, they'll talk about one thing more than the other. It doesn't mean they can't. But the funny thing is that I mention this a lot. Like, a lot of flat Earth believers like to take individual bits of information and take them in a vacuum, and then remove all the knowledge that we know around it, right? And say, see, this is suspicious. And it's like, well, yeah, if you forget all the stuff we know around it, yeah, sure, it seems suspicious. But, like, you're just making shit up then at that point, because then you just took this one little tiny fact out of context and then made some stuff up about it. But, like, if you can't take things outside of the knowledge that's there, right? Like, you can't take the spider web down like
but they're
that.
making all the knowledge up.
What knowledge?
It's laughable.
Making
like, imagine if I walked up to you in the street, right? You were on a park bench. No, I'll just different angle here. Imagine if I walked up to you on a park bench 50 years ago, right? And I said to you, we live on a spinning ball. It's doing 1,000 miles an hour. There's satellites flying in the air. We've got an international space station, and you can all this other like orbit stuff, and we went to Moon and Mars and all this shit. You'd have me committed. So how does it go from a
50 years
complete
ago there
load
were
of
fewer
garbage
now.
to the modern era?
I'd be like, yeah,
where
that's
people
pretty
can
cool,
just-
ain't it?
So scientists just make up all this crap. NASA makes up all this crap. People believe it. It gets carried on through the political system and the mind and the schools and in the indoctrination centers, and that makes it all right that you can lie to people.
I mean, have you been living in a
dude,
cave
it's mockery.
That's 50 years. I mean, I don't understand what you.
It's mockery, dude.
What are they making up? I'm not sure what you're saying.
All of it.
All of what?
We know
All
for
of
a fact that
reality.
objects
They're
can't.
making it up. Well,
We
I'm
know for
sorry,
a
you
fact
can't
that
fool me
objects
on
can't
that one. I
orbit.
mean, I can see and feel and hear and touch.
We know there's no space station. We know there's no satellites flying around. Okay, we haven't been to the moon nor Mars. The rockets land in the Bermuda Triangle and they go pick it up.
Okay,
this is factual. And if you're just denying that, you've got some severe neurological problems. I mean,
Yeah, but using that logic, it's factual that cell phones don't work. I've never seen a Wi-Fi signal.
Yeah. Anyway,
I can't see it. I can't touch it. I can't taste it. Here's these people lying to me, saying that my signal is going from my cell phone magically through the air to the Wi-Fi router, but I've never seen it. Why can they get away with lying like it's?
Most of the time, I can't
just
see
radio.
heat
That's
or
just
cold
electricity
either.
in the air. Yeah.
Yeah, but you've never seen it. You've never touched it.
Who was it? Richard Nixon.
You believe the controllers who say that there's these magical, invisible electromagnetic spectrum in the air that you can't even see?
We've known about it for a long time. 1930s or whatever.
No.
So I think it was Tesla. I'm not actually sure who came up with all these concepts, but
you're just
remember Richard Nixon in 1970? He reckons he made a phone call to the freaking moon.
He did.
Like, can't you see how ridiculous and mocking that is of you people?
And
It's obscene.
And yesterday, you claimed to have made a phone call through the thin air without any wires with your cell phone. It's insane. It's ridiculous to think
like
that you could talk
arguing
through
with a
thin air.
chimp.
Yeah.
Are you a
So
pigeon? Are you
I'm
gonna
not really
shit on
sure
my
if you live in the
chessboard?
same realities. What's that, Dame?
I said, "Are you a pigeon? Are you gonna shit on my chessboard next?"
So I don't know. But how can? Why do you allow the government to lie to you all day, every day? It never stops.
What are you talking about, blah? What lies?
All of it. It's all bullshit.
Buddy, you can't say all.
Give us
or
one example.
nothing. If it's all lies,
Oh
then
my god,
how
the
do you know?
math is
How do you
wrong.
know you're even talking right now?
Okay, look, we know the only thing we know for a fact
I'm sorry, I can't
that
talk.
I know for a fact. You know how they call it nature, right? And we know we're alive. We know we exist, and there's plants and trees in nature. All this other stuff was just created, yeah. So of course these people are going to manipulate the situation for their advantage, because they know that the majority of humans are gullible, low IQ, and don't have any logic. And that's done through vaccines, medications, and, manipulation.
No, not the majority. Half of people are above average intelligence.
Yeah, but what is okay? Then you're asking what is above average intelligence? Then?
Whatever metric you want to use, IQ, whatever.
So there you go. It's over. I don't think we're ever going to get out of this trap, eh? Everyone is just encapsulated by this crap, enslaved, lied to. Nothing's ever going to change.
I think an important part of discerning whether you're being lied to or not is first having a good grasp on what you can, confirm is true, right? Because if you think that in the past 50 years, it's bizarre that people would have thought that, there's satellites in space, or say if they brought it up to you, I mean, that's people were pretty understood that there were satellites in space.
It's not. They don't exist, dude.
I would venture to guess that there were fewer flat earthers 50 years ago as a percentage than there are today.
Didn't YouTube make a lot of flat earth or cause a lot of flat earth?
But like even NASA, was it 2 days ago or 3 days ago? They had a press conference introducing UFOs. And they basically said there was no conclusive evidence or some shit. Now, they're telling you they're mocking you. You know.
Did they say that in the press conference? I saw that there was like a 4-hour press conference. I was meaning to check that out. Looked interesting. But what do you mean they're telling us that they're mocking us?
Hey, Kosho, do you know what the Clark belt is?
Clark belt? Clark belt.
After Arthur C. Clarke. See, he wrote about this Clark belt before it was apparently discovered. What are the odds that this writer, science fiction writer, would write about a Clark belt and it would be determined to be the sweet spot for satellites to go 22,000 miles above the surface of the Earth?
And was that the distance that he had said?
Apparently, Arthur C. Clarke happened to know a lot about satellites before even modern science.
What was his time era? What was his era, Arthur C. Clarke?
Just go look up at how he wrote about Clark belts, and then just by circumstance, I guess, this is the sweet spot to where satellites travel 7,000 to 9,000 miles an hour at 22,000 miles away from the Earth.
Let me see. Actually thinking about it, 1917. Oh, he only died recently. Or not recently, but 15 years ago. I've always said like science fiction and fit in science, they have like a positive feedback loop. Like they feed each other. Because, scientists read science fiction writers, know a thing or two about science, and they usually write about the implications. I'm thinking that any science fiction writer between Isaac Newton and today could have, Isaac Newton and the first satellite could have come up with the Clark belt, because it's just like a mathematical determination, like the height for geostationary orbit.
So he wrote about the sweet spot before they ever found the sweet spot. Noted.
Like I'm saying, once Isaac Newton had come up with the universal law of gravitation, and use Kepler's laws, you can use those two to determine the geostationary orbit distance.
Well, let's assume they've got levitation technology then. Tell us about. Oh, that's a possibility.
See, that guy pisses me off.
Nobody has a topic. All these people here.
Well, SE, there's actually a lot of information out there on that the LIGO and the construction. I've never seen this before.
What are you talking about?
LIGO. Like
Yeah,
all
there's
the
plenty of
blueprints and all
info.
that. Yeah, I never seen the blueprints and all that before.
Yeah, the cool thing about science is that they're not like secretive, unless it's some sort of military project. But generally speaking, they're not secretive. They want people to know these things to further science. So you can find a lot of information. You know what pisses me off is that all these damn papers are behind paywalls, though. I mean, I get why they are, but like, God, it sucks.
Yeah, why is that?
Well, I mean, it's to sponsor these sorts of things, so it takes a lot of money to do this shit. So where do you think that money comes from? Partly by these papers.
Well, government supplies a lot of money, but
Sure.
I guess most of it comes from industry.
Schools.
Yeah.
Industry, yep. What, private investors? I think some of it's the principle of the thing. You do all this schooling and stuff to learn shit, and then you do all this hard work, and then you're just gonna give it up for free. I don't know.
The people who are charging for it are the people who own the journals.
Yeah, I know. But I'm sure the scientists have to have some sort of like money that comes to them from that.
I don't think so. I mean, I think even if you do peer review, I don't think you get paid for that.
I don't think you get paid for peer reviewing. I'm saying that the places get paid, but then they also invest. Like the papers, like the journals get paid, and they invest in scientific projects.
Look, if you're a medical company that invested millions in a medication or something, sure, I mean, you should gain all the benefits and charge for the knowledge. But if you're a public school, college, university, you should be charging for this stuff.
Well, I mean, that's how you get money to continue the research and teaching of and funding of other research.
Yeah, but they charge crazy fees, tuition fees. They get government grants and all kinds of stuff. So
yeah.
At least, I mean, at least those partially funded projects should be the info should be publicly available.
I mean, there are a lot of things that are public, and you can get a lot of the information for free, even if they're published and paid journal, paywall journals here.
Yeah, I think it says here that you actually have to pay to be in nature.
Yeah. Some of them, yeah, you pay to get into shit.
No, yeah, those ones the ones that you pay to get in, like that are only pay to get in, those ones suck. But I mean, even for nature, like because you have to get accepted first, and then you still have to pay for a processing charge.
Yeah, well, yeah.
Some papers you just have to pay, and that's it.
Mm-hmm. Yeah, whatever. I think it could be better. I think that they could do better. There should be a better system.
You ever see these Nova and these things? And now we have a show, and it's sponsored by this foundation and Arthur PC, this foundation and that. All these things are geared up for their own specific, message. Let's put it that way.
Yeah. Money makes the world go round.
Yep. Whoever has the funding, their message gets heard. Yeah. Fortunately. So did you find anything intriguing about LIGO?
Yeah, I mean, just the information's here about the elevation and all that kind of stuff, so that's cool.
Didn't they just do some upgrades on that?
I don't know.
I think they just did a bunch of upgrades. They just finished it not too long ago. I think they started initial usage of it.
Yeah, then they shut it down again. They made their discovery, amazingly enough, the next day after they made it run, after the $2 billion upgrade. Amazingly enough, the day after they activated it, they found this wave that started, how many billions of light years away from us? And yeah.
Yeah,
Like only the biggest NASA fanboy could believe a story like that.
why? I think that that they can generally predict these things from observations that they've made. So, like, if they see something that's very close to a certain point, watch that area. Well, no, I guess it takes quite a long time for that to happen. Well, no, at a certain point, it goes pretty quickly.
What's interesting is that LIGO, they can sense the gravitational waves of nova, kilonova, supernova. They can observe it visually with a telescope, and they can identify it prior to both of those with neutrinos. So you can actually witness an event with 3 different ways. Just kind of a confirming, would confirm it for me at least.
Nice. I wonder if they have anybody working with the new telescope, the James Webb telescope, for some of this stuff, for some of these observations.
That's a good question. That's where the meat and potatoes is now. LIGO is old news.
They're just totally different devices for totally different things.
Yeah.
You wouldn't really be able to use James Webb to observe something that you were sensing with LIGO, because generally people, rent time with the telescope, and they have to orient it, for a specific patch of the sky.
That's what I'm saying. Like, I'm wondering there are certain observations that they've already observed from like ground-based stuff or whatever other instruments that they're like, wow, this is going to be happening really soon or whatever. Can we maybe?
Well, they did that once with Hubble, because you can't predict stuff like a supernova or something like that, except for the case of this one that was being lensed. It was being gravitationally lensed around an object, so it was seen 4 or 5 times because it was like lensed around it, and so they predicted when it was going to be lensed again, the same supernova, and they rented the Hubble for that specific date, and sure enough, they saw it again.
Nice. Yeah, I think I've seen that picture.
A reoccurring supernova.
Yeah, I don't know what you call it that, but it's just like an Einstein ring. You know what that is, right? I see, like Einstein ring, where it's being lensed around an object.
Or it's you're just looking at a circle of lights.
Yep.
Yeah, that's true, but the big difference
Do you
between
ever see
that,
them change? You ever see them
yes,
change?
yes,
They change.
that's what the whole observation is.
Is them changing?
Yes, absolutely. And so the kilonova they witnessed that they saw at LIGO, they knew that it was a kilonova at that place because there was a galaxy there, and then the next day it was a massive light brighter than the galaxy. So there was an explosion so bright it was brighter than the galaxy, and then it went away after a little while after that. But yeah, the supernova that was lensed around the other object, it was lensed like 3 or 4 times. So there was no light there, or there's no bright light there, and then there was a bright light, and they were predicting when that bright light was going to appear again on the other side of that object, and sure enough, they did.
Well, let's see the video so we can see what it looks like. You have it, or
absolutely?
It's going to be something like a few pixels, and then a few more pixels.
well, hold on. This is an Einstein ring, right?
It's like an Einstein ring, but yeah.
No, not like an Einstein ring. The Einstein rings you were talking about, I thought.
Einstein ring is when you have one star that's being lensed around an object, and that the star is then sort of stretched out into a circle. But so you can think of it sort of like that because it's one star that's being basically, or a supernova is being multiplied around an object. So same kind of idea.
No, we're not thinking about nothing like nothing. You have an Einstein ring changing shapes or what?
But I'll show you a picture, video.
No, it can't be a picture. We need to see it a change happen.
Yeah, well, it's multiple pictures or video. Hold on.
Okay. SE, look at this and let me know what's wrong with it.
Be his eyes, SE.
Driving
I can't wait. It's going to be really comical. I can't wait. It's probably going to be some smeared image. Look, you see it stretching. That's a ring.
It's being predicted.
Well, no,
again
I've seen pictures of the Einstein rings. They're crisp. They look crisp, the Einstein rings.
Yeah, yeah. Especially the new ones that they claim came from the James Webb. The first picture actually had a couple of those. So they claim.
I got a few examples, so hold on.
Is this going to be one of those things where it takes you half an hour and you still haven't found the picture?
Break that in half 2 more times, and yes.
You guys heard me?
Yes.
Okay, so we can see 14.8 billion light years away, right? How far away can we see?
That's tough to answer because light years. Let me think.
Well, the last time they made the number up was.
Well, technically, the things that you can see that are 13 light years. Hold on, let me think. Because if it's 13 light years away, 13 billion light years away, isn't it true that the light was 2 billion light years away when it was sent? So it's kind of like.
Yeah, you get some weird fucked up thing going on here with this dark energy, how far we can see, how old the universe is thing going on, right?
Yeah, that's right.
The universe is
that right? Or you just...
No, that's right. That makes it difficult to answer the question the way you asked it.
The universe is 13.7 billion years old, they say. But you can see what, 40, 60 billion light years away?
That I don't agree with.
That's no kidding. It's the most ridiculous thing I've ever heard. And of course, that's all because of stretching, expansion, like crazy stuff, man. How can you have something wider than the age of it?
Well, because when it was sent, well, first of all, it doesn't expand. It expands faster than the speed of light. So, but when it was sent, it wasn't that far. So,
not only that, it's got to be going like. Not only that, it's got to be going like exponential. Like every time it expands, it's now expanding farther or faster. Because the farther away shit gets, the faster it expands. So like when it expands, now it's moving a little bit faster. Then it expands more. Now it's moving a little bit faster. You know what I'm saying?
yeah. Well, the space is expanding. So at about 70 kilometers per megaparsec.
Per megaparsec. I know you Star Wars nerd. The point is, my bad. Go ahead, Coach.
It's like 3 million light years, basically.
I know, but the point is that every time the universe expands, right? Now there's more megaparsecs for it to expand more, and it just keeps expanding, and eventually it's going to be expanding at like 800,000 times the speed of light or something crazy.
Well, no, it's expanding by 70 kilometers a second. So for every
I know, but
3 million.
But from here to the fringe, it's double light speed right now, from what we can tell. Right?
Yeah, double light speed.
And that's only getting faster. The more and more space in between us, the faster that it keeps getting. Like it's expanding slower yesterday than it is today. Because yesterday there was less space in between us. So if it's per megaparsec, there's now more space today in between us. So now today, if it was 2 light years yesterday, today it's 2.0001 light year. Or times the speed of light.
Yeah, sure. Well, how many? 3? Let me see. Let me do the math. Hold on.
Do you understand what I'm saying though about how it's got to keep getting? I feel like you're just yesing me to death though.
No.
Are you yesing me? Now you're knowing me to death.
Hold on 1 second. Is it 13.8? Is it 13.8 billion light years? Is that what it is?
You can go with that. And while you're contemplating that, how do they know if it's going faster than the speed of light? How do they know? How do they measure it? How can they see it? If the light is traveling faster away. Sorry?
By measuring the rate. So if they measure the rate at which it's
It's you can't see it.
I'm just saying, the light that comes off a gas. If you're looking at, can you guys hear me? If you're looking at something 13 billion light years away, and the light's being redshifted X amount, you should be able to look tomorrow, next week, next year, and it should be redshifted even more because there's now more space, more megaparsecs in between us and that object, and it's going to be expanding faster. Do we observe that, or is it just the same redshift constantly?
Well, the redshift that you would observe wouldn't increase by that. Let's get a second. Hold on.
Dude, that would blow their whole shit out of the water, bro. It has to be redshifting more today than it was yesterday.
It has to be. That's their whole model.
Literally has to be by your own. Yeah, by your own thing per mega fucking parsec Star Wars nerd shit. There's more mega parsecs in between us and the thing today than there was yesterday.
Not only that, the space is expanding faster than the speed of light. Imagine that. Light can't travel faster than light, but space can. And they say that with a straight face. Because when they saw the expansion happening, they said, wait a minute, this can't happen. It's going to kill the speed of light thing. I know, somebody said, let's say the space expands faster and not the light, then we'll get away with it. And they actually came up with it and people bought it. It's unfreaking believable.
How can space expand? What is that?
It's like new space is being created. It's like space is being created everywhere.
By space?
Well, I don't know what they say, dark energy, but it's just like the creation of space. Yeah, you can't just stretch it. This isn't like pizza dough where you can just stretch it. Like you have to have more. There has to be more space.
Doesn't there have to be more area for the space to go into? Like if there's a universe, like the thing that exists as the thing that exists, how can it be bigger than itself? I'll shut up now.
Well, that's a whole nother issue with outer space. I like to call it. All right, nice work, bud. That's a whole nother issue. I like to. It's called this. So you have this space, this volume of space, and then it expands. But you have to have a place for something for it to expand into. Because if there's nothing for it to expand into, if I don't have something for something to expand into, it can't expand. You need a space for it to expand into. So
Correct.
I like to call the space is expanding into outer space. You put two outers right there. It only makes sense.
Like the outer limits. I like it.
The problem is this redshift thing, though. Like if we look at one of those galaxies 13 billion years away, light years away, it has got to be redshifted more tomorrow, and then redshifted more than that next week, and then redshifted more than that next month, next year. You know what I'm saying? You figure deal me?
That's how their model works. It expands, keeps expanding. Yep.
I know. I'd like to see the redshift, though.
Yeah,
I'd like to see the redshift,
happen.
though. Like, look at something 13 billion light years away. Show me it redshifting, and then show me it redshifting more tomorrow or next week. Yeah.
It's all a bunch of made up nonsense.
Bro, this is the expansion of space. Space is being created here. You got to understand.
Well, this is where their diletheism comes in, because they'll tell you that, no. It's not expanding into anything when you ask them. Well, what do you mean it's not? Well, no, it's
That's
expanding.
where it gets weird.
Yeah.
I know, it gets weird there when you're like, what's it expanding into? Nothing. Well, that's then so there's something there.
That would be an implosion. That would be like the mushroom bomb expanding into itself. Like, and that doesn't even make any sense. This is, yeah.
This is what I call when they hit the this event horizon. You know, they just shut down. You know.
Well, there's another problem that arises where if you don't believe that you can have empty space, with nothing in it, the problem arises for those people because this space that's being created, it can't be empty space for them because they don't think that's a thing. So now you have whatever is in the space coming out from nowhere, basically, or wherever that space came from, right? Right, Coach?
Come out from nowhere. Nowhere is a good word for what's outside of space. That's actually a perfect word for what's outside
the space
of
that's
the universe.
No, the space that's being created inside of our universe, that space, like in between us and the 13 megaparsecs away, that space is not the space that gets created. Is it just empty space?
It doesn't make the matter. There's quantum fields there, but there's no. I mean, yeah, there's no. That in itself is extra energy. So there's extra energy in that, but.
So there's no perimeter.
Yeah, there's no. The perimeter is the universe. The universe is the. There's nothing outside of the universe, so the boundaries don't even make sense to be considered.
But what's
There's
it
no boundaries.
expanding into then?
It's
But if it's expanding, yeah, into what?
It's just expanding.
Into what?
Think about it like this, dude. A baby is born and has
worse than
amount of.
Go ahead.
A baby has experiences of the womb, and then coming out the canal, and into vagina, and then the doctor's office. And this is the entirety of the collections of that baby's experience. Okay, it has X amount of experience, and tomorrow it has more, and the year it has more, and then 80 years it has even more. And where did that experience expand into? Right? It just expanded. It just increased. The numbers, the values went up. It didn't take away from something else. It just accumulated.
So memory and awareness.
I don't think that's analogous at all. That was probably one of your top 10 worst analogies.
That was bad. That was bad.
I think it was great. And it's just like time. Time at the beginning of the universe was a certain value, and that value increased. It accumulated more and more and more. Now it's more than it was yesterday. Same with space.
Same with our
analogy. The baby expanded in the mother's stomach until it couldn't expand anymore. Then mama gave birth, and then the baby had more room out of mom to expand into, right?
That's
and then
different.
it grew and grew because it had plenty of room to expand into the space where it's at. Now, how does that?
That's different, dude.
Why is it different?
Baby, that's
That's
baby.
your analogy.
No, it's not my analogy. I was describing the baby's experience, the experiences that are in the baby's brain, the things that it understands and knows.
Awareness.
The collection of things.
It's experiencing the expansion. What are you saying, Coach?
No, you're talking about the matter that's making up a human and that accumulating. That comes from the mom eating food, and then the space he's taking up is space that has to come from inside of her body. That's way different. I'm talking about the collection of experiences in the baby's brain. What the baby has as far as his experiences go. It's limited to all it's experienced. So it's only about 9 months, and it's 9 months.
It's limited to material, Cocho. It's limited to its skin and what it puts in there, and then how it grows from there. It doesn't have extra skin to like 8 million more layers. Like it's got, I don't know. There's a point where the skin would stop being expandable.
Yeah, that's right. Yeah, that's why SCs doesn't work, is because of that. But forget about the baby's brain. Okay, let's go back to time. Time is another example where just think about the time of the baby's life. It had 9 months, and that's the entirety of the length of time. And then every day that life grows, like it's like, 9 months in one day, 10 months, 12 months, 80 years. Okay. It's not expanding into something. It's not taking away from something to
That's
grow.
not a good
It's just
analogy.
accumulating.
Give it
It's
up.
not even, it's not even an analogy at
A
that point.
balloon
That's
is an
actually,
analogy, not a baby. A balloon.
An
no,
Balloon
there's
expanding.
yeah, but
an
I'm not giving you an
imagination.
analogy.
An imagination, Coach, is a better analogy. Your imagination keeps expanding and expanding to where we don't know. The imagination space, so it expands more and more.
Yeah,
It's pretty
until it
cool.
hits the event horizon, and then they do a Scooby-Doo.
Yeah, I'm not giving you an analogy though. I'm telling you that
Baby is the worst analogy I've ever heard.
I'm not giving you an analogy. I'm telling you time and space are the same in this way. When there was a small number, and then the time increased, and there was 2 days, and then there was 13 billion years, and there was 13.7 billion years, and one day there'll be a trillion years. But it's not going into a space. It's not that time isn't being built into a greater amount of time that it's taking away from. As time goes on, it will just accumulate and accumulate. And technically, there's no limit. Time will keep increasing and increasing. There's as high as you can count. There's as many days as there will ever be. Right? There's no limit. It's the same with space. There's some energy that we don't know how to explain, but it's just being. It's not coming. It's not taking away from some greater space. It's just space is being added into the universe that we have. It's just space is increasing.
Into what? All those words really didn't amount to anything. What is the current?
It's not into something. It's just accumulating.
Current balloon that we call space, the raisin bread that they say. What is it expanding into?
Yeah, if you have something expanding, you have to have space for it to expand into. Otherwise, you have no expansion.
Why?
What do you mean, why? Because that's how expansion works.
Not if you expand time. I just told you to give you an example of how you can accumulate values, and it's not taken away from anything. Instead of thinking of it as a balloon being blown up in a room, meaning like the space is increasing and it's increasing into another space, think of the space being having a set value, like 100. There's 100 cubic meters.
Okay, so
and
it's
then as
not
space
expanding.
is being added, the space is just increasing.
You said it had a set volume, then you said it's increasing. Does it have a set volume?
Yeah, it's got a set volume. It's not inside of something. That is
so
the
it's
space.
So it's not expanding. It's not increasing.
No, it isn't. It is increasing. I'm trying to give you the idea that it's not
it's
not a space. It's not a space inside of another space. It's like all the collection of space is a value, and then that value is increasing, just like any kind of accumulation number. You see numbers just going up and up and up.
So you think if you can put it into numbers, you could get away with it? It has to be expanding into something.
You keep saying that, but
that's the way. Okay, let me put it to you this way: if I had a balloon, right, and I had it in my room, and I kept it going and going and blowing it up, and it got bigger and bigger. Now, if my room was like 9 feet by 9 feet, right? Could the balloon go to 10 feet by 10 feet?
Yeah, because you just described a room and a balloon being inside of it. So
yeah, a given space.
That.
Yeah, a given amount of space that it could expand into. I mean, and everybody and anybody could understand that, right?
Okay. Well, let's think about a child. There's a child who's 10 years old, and his name is God. Let's call him God, okay? And he just got a brand new computer, a supercomputer, okay? A Google supercomputer. Who knows how much memory it has? It doesn't matter. The point is that he wrote a simple program, and in the program, he made a tiny room that was in the thing. Like he put like a little scale next to it, and there's like 1 centimeter by 1 centimeter by 1 centimeter, and that's all the space that exists. And then he made little dots in there. He's like, I want to put dots in there. And then he wrote a function that all it did was increase that space. So there's only 1 centimeter cubed. And then he kept increasing that. And every time he goes back to the computer, he looks at it, and the space, because it's got a volume at the bottom of the screen, it tells him how much space is there. It just keeps going up. It's not expanding into anything. It's not expanding into anything. It's literally just increasing.
Okay, fair enough. What happens if you run out of memory?
Oh, well, it's not gonna. There's no way to run out of memory because you can't run out of memory in this case because he's not going to be.
What do you mean?
He's not. Yeah, he's not going to be viewing all the space at once.
You're creating more space in your computer, right? You got a CAD, an AutoCAD, and you're creating more space, right? But eventually, you're going to run out of hard disk. What then?
But he's not processing all the space at once. Like he doesn't have it all in the screen in front of him at once. He can be looking at different regions at one time.
Doesn't matter. You don't have any more. You can't create any more space. Your world is so big, right? You have so many lemmings. You have 100 million lemmings now. Your hard disk can't hold anymore. You can't create any more space. That's it. You reach your limit.
No, the numbers that keep increasing. He just uses different, like he uses scientific notation once it gets too big, and once that gets too big,
you're out of memory, sir. Cannot process. Please delete some free space. Would you like us to do it for you, Norton? Norton will come up and tell you you're out of space or whatever your program is.
Yeah, but he's, like I said, he's not viewing all the space at once. Like he's not like.
Doesn't matter. We're not talking about that.
It does.
You need to expand. You need to have more space. Now you ran out of memory, right? Think of your memory as space. You can't create any more space. You need more space, or you need another hard disk. Same like this. You can't get out of it using.
He's not using his memory to process all the space at once. He just has information of how much space is and how much space there is.
It doesn't matter, Cocho. You can't use that analogy. If you're going to use memory, your memory is going to be taken up just like the spaces. And eventually you have to expand. You need a new hard disk. That's why they have banks and banks and banks of memory. They have memory hotels that are a mile long and stuff.
Well, that's why they can run simulations. But if you wanted to just, like I said, just have how much space there is, he could just use, more and more compact numbers. Like, eventually he's using scientific notation. Then he's using, factorization. Then he's using fucking all sorts of shit. Just so he can actually keep track of how many numbers are there.
You can't use this analogy, but if you continue to use it, you're still going to lose even in that argument. So give it up, Koshko. Where does your space expand into? You need to use a balloon analogy. That's the analogy they use for the fantasy they tell you live in. It keeps expanding. So you got to use a balloon analogy. And a balloon needs space to expand into.
They use that to explain to kids how, what it means that it's expanding. They don't. They're not saying that this is an example for what we mean, because they're not claiming that the balloon, like in that example, the balloon isn't expanding into anything. You know what I mean? So it's not like the balloon is in a room, and the universe is a balloon, and there's some bigger room. Like the claim is that the universe is the extent to all the space that there is. So there's no other kind of space that space is expanding into.
Yeah, that's a ridiculous thing. That's dialetheism. You have expansion without it expanding into. Now, your brain can handle that, right? But my brain in reality says that's impossible. Now, if you can make sense out of it, I mean, good on you, but don't try to convince me of that.
Well, no matter how big the internet gets, the World Wide Web, no matter how big it gets, my computer can access, any website that's on there. Most of them, if the website's not too big. That's because my computer is only accessing the information. It's not, containing it.
It's a bad analogy, but like I said, if you use that analogy, your hard disk will take up all the space and it would fill up, and you're going to need more space. Everybody knows that. Everybody here probably has an extra hard disk. Why? Because they ran out of space. So they had to expand. They had to expand to a new, well, most people buy digital drives now, right?
Only if you want to keep all the information in one, one computer. But technically, the universe, like the space, the energy that's being created, the dark energy or whatever, that's just the energy that's expanding the universe. But all the energy that's making up the matter and all that kind of stuff, that existed at the beginning. So I don't think there's any claim that that's increasing.
So energy is not increasing, but stuff is. But energy equals the mat. Like, I don't get it.
Yeah, that's another violation, right? You can't create nor destroy energy. But if you're creating more space, wouldn't that mean by definition more energy? More stuff? See, there's all kinds of problems here. So you can't create energy in this circumstance?
What do you mean, sorry?
Nobody thought of that one, huh? Well, if you're creating space, are you not, by definition, creating energy? That's a violation. Isn't that a violation?
I think it's energy that's creating the space. It's dark energy is what is expanding the space. That's the energy that's doing it. I don't think that it's in itself creating itself. You know what I mean?
So
Like it's not
the
creating.
finite amount of energy is creating space. Is that it? I thought it was expanding the space, not creating it.
That's what they say. Well,
so
that's
which
what
is
they mean
it?
by expanding it. The space expanding is basically space being created.
So it's both
the
creating
universe
it
expanding.
and expanding it. Are you sure this is the model?
No, the universe expanding because space is being created. And by space, I mean like the density is decreasing.
Yeah, but doesn't space? So just space, not new planets and that. Just space is expanding, right?
Yeah, no new planets being created.
Okay. So by definition, doesn't space have stuff in it? Even by your quantum stuff, doesn't it have vacuum energy? Quantum energy? So by definition, that is what you're creating. You're also creating energy, which is in violation. So how does that work?
Yeah, so okay. So I mean I don't know the values, but I know that the energy is constant. So whatever energy existed at the beginning of the universe, dark energy, all the energy that makes up matter and whatever, dark matter, all that kind of stuff, that's still constant today. So there's no,
it's finite.
There's no new dark energy.
Yeah.
There's no new dark energy.
Okay, so the space that this creates, that you said it creates it, right?
Yeah. Expanding the stuff away from each other.
Is it creating the stuff or is it expanding the stuff that's already there? Creating space in between.
The stuff there's space, there's distance being created between objects. You can think of it like reverse, it's like negative pressure.
So it's creating space.
Yeah, but what is space? It's not anything.
That's my question. According to all the theories, right? Ether, electromagnetic, quantum, vacuum energy, all this stuff, right, is energy. So if you're creating space and space has this stuff in it, you're also creating energy. Are you not violating a law that you cannot create or destroy energy?
Oops.
I
Right,
mean, all I
because
know is
does space
there's
not
no
matter?
violation. Go ahead,
Is
Jamal.
space not matter? Space is matter, right? Or mass?
I wouldn't say that.
It's not? Okay. So it's not physical stuff.
I wouldn't say that, but
So how are you creating physical stuff without it being a physical thing and having physical room to make physical room for its physical self in the middle of nowhere?
well, the only thing physical about space is its locations, positions, distance, volume. But other than that, it in itself isn't anything.
Space is a physical location?
No, there's locations in space. Space is a set of locations.
So space is physical.
Yeah, well, as I said, it's physical in regards to with regards to what I said. Like that is
So
that I just described its physical nature was those attributes.
physical stuff is mass and matter usually, right?
Mass, matter. Mass is an attribute of matter, and that is physical. Yeah, that's also physical.
Yeah,
And
but you
it's
said
in
they
a different
weren't.
way.
You need energy for that. That has to be energy.
Well, mass is sort of a measurement of the energy. Yeah.
Which you have no more of. You don't have. You said you only have one amount of energy, and there's no more dark energy. It's just dark energy of the energy that was from the beginning. So now, if you have no more energy or mass to create of the energy, then you're speaking in circles.
Well, no, I mean, okay. So if there is an acceleration rate of the expansion of the universe, that acceleration rate is it exists by virtue of that same amount of energy.
And where did you see a little universe expanding in like a lab or anywhere, or like to get the expansion rate and all this stuff you like supposedly know about that you've never seen before, nobody could create?
That's just based off the Hubble's observations. He just noticed that the redshift of further away galaxies appear like they're redshifted as if they were moving faster and faster as you looked further and further.
So what would you say about the red portion of a rainbow? Is it moving faster and faster the same way with its redshift?
No.
No, but yours is. That's cool.
Now, his observation can be explained in two ways. One would be our local group of galaxies is stationary, and everything, and the center of the universe, and everything for some reason is expanding away from us at a rate that was faster and faster the further away it was. That's one explanation. Another explanation is at every point in the universe there is no center, and every point has everything expanding away from it, where there's just space being created that is
it's nothing.
You know, that is more. So basically, it's expanding at a rate that the more space there is between you and something else, the further it's moving away from you, because there's more space in between you, obviously. So if space is increasing at a constant rate, then that would mean things further away were moving faster and faster.
Kosho, how do you measure space?
Well, like I told you, that's how Hubble measured it, was by observing
You
further
measure
and
space,
further.
not Magic Hubble. How did they do it? How does Hubble measure space? I want to know.
Yeah, he did it by measuring further and further away galaxies, and the hydrogen specifically from it, and observing that the hydrogen was further and further right on the spectrum of light than it was supposed to be. It was further and further away from where it's supposed to be, to the right, the further away it was from the Earth.
Except light and hydrogen aren't space, and they aren't anything expand. Like, where is space expanding? You named hydrogen and light. I'm sorry, I didn't hear any space expansion, and I still don't have my arcs. Like, where do we see this? How can we mark it from left to right or front to back? Like, what tool would we use to mark space as expansion? How do you focal point that out like a pinpoint? Like, how do you put it on the map?
It was inferred from the redshift.
What does inferred mean? Made up? Like imagined?
No, like concluded. It was concluded from
So
the
what's different?
redshift.
What's different from imagined to the concluded without a demonstration?
Well, because the only explanation for the redshift would have to be that they're moving faster and faster the further away they are. So
Well,
that's
everything
clear.
about it's no, everything about it's made up by you. You don't have a demonstration of any of that. So how can you conclude something that you just made up without the actual physical attributes of such to back the conclusion that you keep claiming every time? You just keep having an imaginary idea that backs your imaginary idea, like every idea for the globe. Like every single one of them is exactly the same.
Okay, demo.
I got some math for you, Ruhif. You ready? I got a 360-degree little sphere. It's perfectly 3959, 24,901. It's a little version. It's about 4 inches by 4 inches. It's so awesome. I'll
You
show
don't
you
need to
how
take
your
pills to
math
get
is
an extra
wrong.
inch, right?
It's showing you how your math is wrong. You want to do some math? You ready to do real math, Ruhif, or just fake math?
Yeah, I love the fake math.
You want to do
Let's go.
some real geometry? Well, don't tell me my 2D circle ain't good enough like yours, okay? All right? Because we're going to get this started, okay? Don't run. Don't say if and but, and don't make stuff up. Please, don't start asking me weird questions. The diagram's all you need. You ready?
Sure.
Okay, somebody give me permission. In about 3 to 4 minutes, I got to take my young one in. We'll get this done.
I'll try not to be here in 3 or 4 minutes.
Because you're not ready for real math, are you? It's okay.
That's correct.
It's all right. We
You
know
got
you
me.
don't like real proof. You don't like proof in math? Dang, I wish you did.
Hate.
I went ahead and posted the data for you.
I got some data for you too. If they let me post in the thing, I got a picture for you. We can all go over it. Flat earthers, globers, whoever.
Well, when you want to look in the chat, you can save it or whatever. I posted pictures of the measurements of the redshift based on that corresponds to the distance of these objects. And
objects. When you say redshift, what are you measuring? Red light?
I told you the hydrogen spectrum. Hydrogen
Hydrogen
spectrum created from the hydrogen. Yeah.
Created by what? And what's it do? The spectrum of what?
Of light.
Light. Okay, so you measured a light, and you're telling us light is space. Is that what you're telling me right now? That's what your great, brilliant minds configured, that light is space. I wouldn't come to that conclusion at all.
Last time you asked me that, Democ, I it's like if you say the same thing you said, then I'm going to say the same thing I said, and then it turns into a thing where people, no one wants to hear something they just heard. Nobody wants to watch a repeat of an episode they just saw 30 minutes ago. So
why do you keep saying light is space?
I just told you that light is not space, and that how they infer that space is expanding from the redshift. That's it.
So
There's nothing else to say about it.
When did you measure anything but light and other stuff? When did you measure the space? That's what I'm asking you. Not red stuff, not light shifting, not rainbows. You're telling me about what rainbows do. Now you're inferring the word space, which is a whole different meaning from light, I guess. It's not energy, it's not light, it's not matter, it's not none of that shit you're talking about. So you're telling us what space does when space isn't any of that. Do you understand this? Is this beyond? Do you understand what I'm saying?
I told you they're not observing the space itself expanding.
Exactly.
They're inferring that from
making
the
it up.
redshift.
Yeah, you don't make up space from redshifting light and stuff that's not space. That would be weird, wouldn't it? If I said, hey, look at all that toilet paper that's growing, but we're looking at red crayons and rainbows, the toilet paper has nothing to do with the crayons and rainbows at all. That's weird. So if you say you're measuring space, wouldn't you have space? You'd have space in the spectroscopy, right? And space doing stuff.
Let me speak in terms you'd understand, okay? Let's say that you can't see any rats in your basement, okay? But every day you see more and more rat shit in your basement, okay? You're gonna infer that there's more and more rats there, and that you have a big problem, even though you've never seen one rat. Does that make sense?
No, it doesn't.
Well, I know from experience that that's the truth. That's how that works. Because eventually you will see a rat.
Do rats look like space? Show me how they're the same. Let's go over an actual terminology that matches what you're speaking on. Not light, not rats, not shifting stuff, not radial transmissions. Space, bro. I mean, what are we talking
Just show
about?
me stuff that's not evidence.
We're not
Go show.
Yeah, quit showing me non-evidence. What the?
Yeah, that's what you want, right?
Yeah, go show the judge a whole bunch of pointless evidence. That's really gonna help you out, isn't it? It's not proof. So what's the point of useless, pointless evidence? Circumstantial. Circumstantial evidence is just like garbage. Throw it away, right? Of course. We want the only definitive proof. We don't want garbage. We don't want to sit here and look through 800 million garbage cans of evidence when we have the one thing of proof right here on our table. Who would do that? Not me. You would? Cool.
Hey, Ruhif, you won a math competition, right?
Did I win a math competition? Yeah, in year 8, I got a certificate in the Westpac maths competition, which is like the top 0.1%. Yes.
Okay, let me ask you a question. Hold on. Because I just want to, because I don't want to think about, I'm going to end up thinking about it too hard and waste my time. I'd rather just ask you. But if I have like a land area, like a land mass in front of me, right? And I want to determine the surface area of it, right? And I have a key, right? And the key tells me like how long 100 feet is, for example. But let's say it's 185 pixels, right? So if I know that 100 feet squared is 10,000 feet squared, and then I knew that a square of 185 feet or 185 pixels is 34,000 pixels and some change. And I know that that's
34,000 square feet.
No, it's 34,000 square pixels. 34,000 pixels.
Okay.
So like 100,
Oh,
like
yeah,
10,000
sorry,
square feet. Yeah. So 10,000 square feet is akin to 34,000 pixels squared, right? And that's a 3.4 to 1 ratio, right?
Cool.
Could I scale that up?
Yeah.
Like if I need,
as long as there's no distortion. Like on a big map. Yeah, on a big map, you'll have distortion from the Earth being a globe, but yeah, fine.
No, it's small. It's a small property. I just I just need to make sure that like I can do the pixel area, and I can just convert it by dividing it by 3.4, and that should give me the square foot, right?
Yeah, should be right. Yeah.
Fair enough.
She'll be right, mate.
If you fuck me on this, Rudiv. I'm trying to value this property correctly, so.
You can use Google Earth Pro and do a path around the edges, and it will give you the area.
Well, that's the problem is that I'm using a database that has all the property and property information, but I don't think they do perfect outlines of the property. And so I'm kind of having to fucking determine what the actual outline of the property is. It's a whole thing.
Okay.
Google Earth's not going to have
you can
that.
scale up Really?
Well, it's not going to have like people's properties, individual addresses.
Okay.
Separated,
like the
right?
actual boundaries. Okay. Yeah.
Yeah, right. What are you saying, Blue?
I was going to just ask if you have the corners in latitude and longitude or something.
Yeah.
If you had that, you can plot it on Google Earth easy.
Yeah, but that's the problem. Is yeah, I just don't have any of that. I have the address, and the boundaries aren't outlined very well. But yeah, Blue, you came up earlier though about LIGO.
Oh, SE. Where's SE? Yeah.
Yeah, he's here with his mic's open and everything. But yeah, I saw the video you posted, Ruhif, and
Cinema
there's a lot of
control. Yeah.
data. There's a lot of data in there. Data I've never seen all that blueprints of LIGO and all that kind of stuff. It's
Yeah.
pretty cool.
Yeah. Oh, it's such a simple argument. Like the elevation profile is curved, but the tube is straight. Therefore, the datum is curved. Like it's fucking straightforward. Trivial.
And not only that, question for you, Blue. SE wanted. So I looked at the data from the video, and he said that you had claimed there was a 4-foot difference on one arm and a 1-foot dip in the other arm. So there's like a U shape with a 1 foot below the other two sides in the other arm, which makes sense to me. Although I was wondering, were those estimates? Because the numbers that I
No.
estimated, those were perfect, like perfect 1 foot, perfect 4 feet.
Well, no, not perfect. You have to look at the actual elevations, but it's 1 foot and 4 feet are close enough.
Yeah. Okay. Yeah. That's what I got then.
At most a few
so
hundredths of a foot difference.
So the tangent point for one arm is in the middle, and the other tangent point is at one end.
It's hard to explain to those guys because they are so incredibly weak when it comes to geometry.
They don't want to get it either, though.
Yeah,
they don't want to.
There's only one tangent.
Yeah, and when you're talking about the plane, the tangent plane that the arms lie in, the point of tangency of that plane is not on either one of those arms at Livingston.
Yeah, of course. Yeah.
It's
here's my son. I got to go. I'll catch you later. Sorry.
Yeah. See you, Rude.
Blue, when you say that, because it looks like from the data, and it's almost like the tangent is parallel to the center of one of the arms, right?
Yeah, it is.
Okay.
If you take the center line of that arm that has about the same elevation at both ends, right? If you take the center point of that and project it all the way down to parallel to the end of the other arm, okay, you'll have a tangent point for the plane that is roughly, and I hope I get these directions right. I think the arm that's almost equal elevation at both ends is running sort of east and west, and the other arm's running north and south, more or less. But if you go to the south end of that eastern arm, the one that's going north and south, go to the south end of that thing, and then go west from that point about 6,500 feet, and that's just about center line of the upper arm. That's about where the tangent point is, and the tangent plane would be tangent at an elevation of about 59 feet. So you'll have about a 1 foot elevation change when you go over to the end of that north-south arm, and you'll have about a 5 foot elevation change when you go to either one of the other two corners. That appears to be where the point that they use for a tangent plane for the point of tangency.
Right. Yeah, actually, yeah. Let me see. The highest elevation on one of the arms is like where the midpoint is on the other arm, I think. Let me draw this.
Wonder what an altimeter would look like. Two of them from the center of that, going both the opposite directions. Like, how would they react to LIGO? And then to a piece of land right next to it. How would the altimeters raise in elevation or stay the same exactly as the most perfect straight horizontal plane in the universe? Probably match up, wouldn't it? The water probably matches up perfect, doesn't it? Did you hang any plums after the LIGO and then beyond? One more question that might make a little bit of sense. If you got little particles and stuff going at the speed that you claimed, what would tin walls or cement walls stop them? Like, if you're out in space and something's going that fast, doesn't it peel through whatever's out there? Don't they go right through it? So at what point would you be able to contain those things once you got them going? They wouldn't be able to take a left. They'd go right through the object that they're headed towards. They wouldn't turn. Light speed takes loops. So we have light speed particles, almost 99 point whatever, making loops and not hitting the wall in front of them. This is weird.
So they use. I think they have some of the most expensive superconducting magnets lined up. If you're talking about at CERN, I think they're like
Well, how do they
1,200
build
of
up
them.
speed? So
But
you're
those same
stopping it from doing its thing.
those same
but you're-
magnets.
Yeah, you're stopping it with magnets, but you're building light speed against the magnet by stopping it. This is awesome
It's not-
double speed.
So when they have ions like positively charged protons, negatively charged electrons, and they're going to be, they can have a field that is obviously going to, they're going to have a path. They're going to create a path for the charge, right?
Through
So
what?
it's not that it's going to be perpendicular to where that field is.
Yeah, what material is going to stop that? What tin can is going to stop speed of light particles? Can you show me, like, how does the ISS get put holes through it if the speed that's nowhere near the speed of light? So if the speed of light things are getting stopped by a magnet, why doesn't the ISS just put a magnet on there and it'll stop all the debris, right?
It's not being stopped by a magnet. It's being
So how is it taking a left?
Perpendicular to the magnet.
That didn't make any sense. A curve isn't perpendicular. What are you talking about, Kosho? Exactly. So nothing stops it. You're telling me it's getting stopped, but nothing stops it. I don't understand. I don't understand how that can be the same. How does it keep going through the magnetic field if the magnetic field stops it? I'm not getting this. And forget the theoretics of it. Like, why don't we just hang a couple plumb bobs behind it? Surely they'll have to deviate after the most straight level thing in the world, right? In the universe, the most horizontal thing in the universe. Surely the plumb would have to deviate before and after. Cut about 50 foot apart, left to right, front to back. Just do all directions. Don't do it the oblate way. Do it the non-oblate way. That way we can see the super diagonal plumb. Yeah, let's use the small side of the Earth egg. The little portion, not the long portion. I don't like that portion. I picked the other side. Hello? Nobody hung any plumb bobs behind LIGO? Before and after it? To see the how it is before and how it is after the most perfect line? The horizontal plane in the universe? That's weird. Maybe we should race to do that. And see which one deviates from LIGO. And if you can't find a plumb deviating from the plumb next to LIGO on the end of it, hung on the door of it and all that good stuff, and on the back door of the building and the building, hang in the middle of the building, hang in the middle of it, and keep going with them. Like, where's the plumb bobs going to deviate? They have to deviate from the most perfect horizontal in the universe if we're on a ball after that point. Correct? Like, doesn't that have to? Wouldn't that be the rule? Because, I mean, that's the portion that's horizontal. Any other portion beyond that wouldn't be horizontal anymore, therefore not being plumb. Correct, Blue? Kosho? Check, check. Is this mic on? Where'd everybody go? Afraid of plumb bobs now, huh? Weird. Can I put my picture in the thing? One drawing. I drew one drawing. I just want to put my 360.
Send it to me and I'll post it.
All right. Are you Kosho on here?
Yep.
Okay. It said failed. It said failed to send. I don't know why. But you got the other one above it that basically is the same thing. It's just showing you that it's a 360. So the math is proven right there. So it's a smaller version of a 24,901 from the center out. It's 3959. It's just a scaled down version of the sphere, the globe, mathematically perfect as it can be. And then I got a horizontal and a vertical, right? One that shows how the rocket will go and one that shows how the balloon will go. It's the top picture above the writing. The bottom picture didn't go, but the top picture is there. It's basically the same thing. But what I have for you is everywhere on the side of that globe, the spherical, on the outside surface, I have a right angle showing you the balloon and the rocket. All directions. Showing you no matter how you want to turn the ball, the balloon will go vertical and always beat your rocket horizontally, no matter which way you want to turn it. Whether you turn it to where the balloon has to go 10 times the distance, or to where you turn it to where the balloon has to go the same exact distance, because I have it all marked out right there. It's all perfect. The clouds represent 35,000 feet away from the surface, right? Isn't that cool? And then we need to just see like altimeters and how they react, right? So an altimeter has to raise an elevation. The voltage has to raise.
Where can we see this?
Horizontally to the horizon.
No,
when
this
you hit
this
the
picture.
sky.
The picture.
I put it in your thing. What do you mean? What are you talking about? You told me to send it to you. It's in. It's right above. It's a sphere. Well, a 2D sphere with the angles on it. It's got the horizontals and verticals everywhere, showing you how a ball really works, a real sphere.
If you send it to me, I get it.
Oh my God, dude! It's already been sent to you. The one I just sent wouldn't go. There was one already in your thing. I already looked up and saw it. What are you talking about?
Oh, okay. So I gotta look. I just gotta look at the last thing you sent to me.
You mean you really can't scroll up like a millionth of like my thumb barely touched the screen and it scrolled up like 3 pictures? What are you talking about, dude? That's weird. So anyway, post it for me, please, if you could. If you see the picture I'm talking about, right above the last writing I put writing and then the picture. For some reason, the picture didn't go. Maybe my phone's not charging now. You might have me blocked while you're telling me to send you pictures.
No, dude, I have it, I have it.
Well, people are the Globers should be like rushing to get some plumb bobs. I would. I mean, not that you have to. It would just be cool. Put them around LIGO, north, south, east, west, all around it. See how they look. That'd be awesome, Tess. Have you ever thought about spheres? Or did you put it in the chat, Kojo?
I did.
Okay, thank you. Have you ever thought about cubes? Big cubes, about 10 foot by 10 foot by 10 foot, 6-sided cubes on water. You ever thought how one would just need one to deviate from the other to be on a globe? Just one. No matter where, no matter how far away. Be right in front of your face, you just need one. Did you know that?
You need
Just
pretty
one
big
of them.
cubes. You need big cubes.
No, you wouldn't. Stop making stuff up. No, you wouldn't. You can use cereal boxes. On a sphere, cereal boxes on a sphere the size of a globe can't touch the sides and meet up. You can only have one line vertical. That would be the first cereal box's edge that you started with. No other edges can match that. So if you think that's true, go get a sphere and show me how that works, because a small sphere's outside radius acts the same no matter big or small. You can scale up the box of cereal as big as you want. It's still going to act the same on a ball, correct? Unless you got a box of cereal that acts different than mine and the ball. I mean, we can go over the different sizes of balls that all do the same thing. From 8 million foot tall balls to 2 foot tall balls to millimeter balls. They'll all do the same thing. They all act the same way. Squares won't touch on them. You'll have one square on the top and every other square will deviate. Go do it. I mean, anybody can do it. A little kid can do it.
You would want
surface, all level. Oh, go ahead, Gojo. Do you want to respond to that? Or?
Oh, that big and little fallacy again? Yeah, nice try. Let's not keep doing that. We have 360 which equals 360. A 360 with a cube on it is going to act the same as a 360 with a cube unless you got one to show me that doesn't act that way. I'd love for your claim to be fulfilled that you have a big ball that acts different than my little ball. I got a little cue ball. Scale it up as big as you want. Get a 50-foot cue ball. Show me how it's different. Go get a little square. Show me. I'll wait. Scale your square down as much as you want. I'll wait. I mean, we only have but to do it. It's not hard to get a ball in a square, you guys. I mean, this is easy stuff. No lasers, no $10,000. Just little kid stuff. Ball, square. Let's keep it simple. You get the scale. You make the size. Don't say Earth. Don't say imaginary sizes.
Okay.
You have to present the size that you claim fits your claim of imaginary globes that work the way you think
we got it, dude. We got it.
Do you have the ball that matches that?
Mike, you gotta stop.
We heard what you said. We know.
Well, does anybody have a sphere that has 3 or 5?
Dude, stop. So remember I was talking about, remember when you wanted to use fucking sprinkles, you nutcase maniac? And I said, no, we should use something more probably solid. And I had the magnetic cubes. I mean, that's basically like, if you had a level surface and you just had those cubes, there's no way eventually they would have to be separated from each other on a sphere if level's curving.
Yeah, if they were small enough cubes, like anything smaller than what is it, 50 by 50 by 50? It's 555 to 25. What is that? So 225,000 cubic feet. If they were any smaller than that, you'd have a hard time measuring it.
I mean, dude, if they're magnetic and they're always touching and they're always flush, I mean, what measuring what?
You'd have to measure a deviation of 3/10 of a millimeter from bottom to top.
You know what I'm saying? If you get these cube pieces and they're all magnetic and you put them so they're all connected and you just make a giant line on a level surface. If it's a sphere, they wouldn't be flush. They wouldn't be able to stick together or something. I don't know. What would that look like?
If they were all 1 cubic foot in volume, 1 foot by 1 foot by 1 foot, and you had them all the way around the equator, all on the level, smooth surface of water, you wouldn't notice that it was going around the equator.
Oh my God, how big do the cubes got to be before we notice?
Just told you. 50 by 50 by 50 feet.
Over how long?
Any distance. I mean, fucking any distance.
Well, I have thought any distance.
Yeah, but 10 feet doesn't matter. Just put 2 of them next to each other.
That's all we needed this whole time.
Yeah, a 50 by 50 by 50 cube. Yeah, that's all you need.
That's not that big.
Yeah, it is very big.
It's like
dude.
5 stories. It's like a 5-story building. You know?
Yeah. Made perfectly fucking smooth on each side. Perfectly,
Well, if you got plumb lines to match it up against, it's not an issue. But did you like my idea? What's that?
The amount of error that you'd have to overcome, plumb bobs are not going to do it for you.
How much error is in a plumb bob? Wait, are we talking a calibrated plumb bob?
Doesn't matter because the amount of error, they would have to be perfectly machined.
But how much error is in a plumb bob? I'm just curious.
Some.
So there's errors in plumb bobs?
Sure.
Plumb bobs aren't vertical.
I mean, nothing's perfect.
Plumb bobs aren't straight lines.
What are you using for your plumb bob?
I don't know our plumb bob. I didn't know there was error in plumb bobs. I'm curious how much are plumb bobs not plumb by.
Problem is nothing's perfect.
So all we need is a level surface and 250 by 50 by 50 foot cubes. That's it?
Assuming that they're perfect, yeah.
Perfect cubes? Well, how much are you going to be off by on the top?
I think 3/10 of a millimeter.
3/10 of a millimeter? Bro, that's tight right there.
Hmm.
Why does everything got to be so why does everything got to be 5 stories? My fucking cylinder thing had to be 5 stories.
Yep. I think it was the same question.
Do you have anything under 5 stories? Like maybe 2 stories?
Let's see. If you make it 20 feet, give me a second.
I mean, bro, you went from rainbow sprinkles to 50 fucking feet. 5-story building shit. Like, come on, bro. Is there no happy medium here? The straw was a nice 33 feet. That wasn't bad.
I did this the other day for Geo. I don't have the numbers. Hold on.
Ruif doesn't think we can get a 33-foot straw straight. What do you think about that?
No, I don't. I don't either.
You don't think we can get something straight that's 33 feet long? That's got to be well within the range of an auto level.
I don't know, man. I mean,
couldn't you make it out of metal? Could you make it out of metal and then check it against a plumb bob or something?
Yes, you could. I don't know, man. Think about it. What's the strongest material in the world? Even that's
Well,
gonna
how much
fuck
air
up.
is? Hold on. How much air is in a plumb bob? Before we even go down this road, because
Depends on the plumb bob. I don't know.
the most calibrated, best plumb bob in the world. How much is it off the plumb by asking for a friend?
You have to imagine there's always going to be some error in the device itself. If it's using a laser, if
The
it's using
device of the
string.
plumb bob. Dude, if I hang a string, that's not a vertical string.
There'll be some error.
How much error? What's causing the error? Give me something, bro. Like, what's causing the error and how much is it?
I mean, is the thing not moving? The thing that's hanging there?
Yeah, it's not. Why would the plumb bob be moving, dude? Come on, bro. It's not a pendulum or something.
Kind of is.
We're not gonna swing it back and forth like boat hogs, fucking goofy ass. We're just gonna fucking use it as a plumb line, bro. Yeah, it's not moving.
I feel like we're doing like a drug deal, dude, because they're both whispering.
Well, my whole family's sleeping.
Yeah, my girl will find out that I'm not working.
How much air is it? How much air is in a plumb bob? And why?
I don't know.
Are we at the Schehalian Mountain experiment thing?
There's one example. Yeah, there you go. There's one example.
Where plumb bobs aren't plumb? Is that plumb bob plumb next to the Schehalian thing?
Yeah, it's not perfect, no.
So you're telling me no plumb bobs are plumb?
No plumb bobs are perfect, I'm telling you. Okay, hold on. I'm getting yelled at. Hold on.
Perfect what? Perfectly vertical? You got bagged.
Did you figure it out, Kosha?
Sorry, Blue.
Real quick.
Figure what out. Figure what out. Sorry. Yeah, ask Blue the same question you asked me, but Blue, figure what out.
What?
You said, did I figure it out?
Yeah. LIGO.
About the LIGO. Oh, yeah. I was just trying to get an intuition of like how, because I'm looking at the data and I just wanted to see how it was oriented. But yeah, obviously it's horizontal. The plane that it's parallel to is going to be horizontal, or I'm sorry. The horizontal that's tangent to the Earth is going to be parallel to the center of one of the arms. So I was just trying to see how it's oriented, but it would be like as if there was a vertical from the center of the Earth to the center of one of the arms, and LIGO. Yeah.
Can you see my live screen?
Yep.
See it?
Yeah, I see it. Yeah.
That's LIGO Livingston. Can you see my cursor?
No. Oh, wait.
Crap.
I saw it a second ago, but no, I didn't see it.
There's probably something I need to turn on to allow you to see the cursor, but that's okay. Let me just.
Yeah.
That is.
Should look. It's like showing up for a second, but I don't know if that's the image switching back and forth. But yeah, I mean, you could just describe where you're. Cause I see the red lines.
That's Livingston. The upper arm here, the upper red line, and the line on the right, far right. That's the two arms of LIGO. Okay.
Right.
And the plane that they lie in is tangent down here where those other two lines cross.
Right. Okay.
About at that point.
Makes
and
sense.
That point has an elevation of about 59 feet. So you've got about a 1 foot drop when you go from that point over to the bottom end of that line, of that arm on the right.
Okay.
That's about a 1 foot drop, which means that the elevation goes up by a foot. So you go from 59 feet there at the tangent point to a 60-foot elevation at the end of that arm. But then when you go all the way up to the ends of the other arm, both ends of the other arm, that elevation goes up from 59 feet up 5 feet to about 64 feet. So the elevation at each one of those other 2 points is about 64 feet, which is what the data shows.
Okay. And does that mean that the center of that arm is 63 feet?
Yeah.
Okay.
Yeah.
That makes sense. Okay.
Yeah.
Okay. So even though it's tangent at that cross where that cross is, it's still a lower elevation than the other arm, but it's parallel to the horizontal at the center of it.
Yeah, you kind of have to think upside down when you think about elevations.
Yeah.
From 59 feet, where the cross is, that 59 foot elevation is dropping away from a horizontal line by 1 foot by the time you get to the end of that arm on the right. Does that make sense?
Right. Yeah.
Yeah, you got
the one to its right.
Yeah, you got a 1 foot drop, which means when you bring the elevation up to make that horizontal equal to the actual elevation, to make that straight, you've got to add a foot to the elevation.
Right. And so that right arm, or the arm to the right, it's basically going from the bottom to the top. It's raising 4 feet, right?
Right. So it's 60 feet down at the bottom and 64 feet up to the top. And it's also 64 feet over at the other end of that upper arm.
Right. Yeah. Okay. So you kind of. Yeah. So it's like digging into the earth a little bit. Like it's I mean, I don't know if they built it that way or if the elevation of the ground is decreasing at all. But assuming all the ground was level, they would have to have dug down a little bit in that right arm as they're going. What is that? From north to south.
If they took that entire site and leveled it to 59 feet, let's think about it that way. Make that whole thing a 59 foot elevation, and you want to put this thing on it, then you're going to have to build the dirt up there on the right hand bottom corner. You're going to have to build the dirt up by a foot to be on the on that horizontal line, that line that's running through the tangent point.
Right.
Right. And then you're going to have to continue building it up all along the length of both of those other arms.
Yeah.
To get it up to the
That's
64-foot elevation.
I
Think
don't
about,
know if you're still here, SC. Go ahead.
yeah, just think about the, well, you know, sort of like that sketch that's sitting in the chat right now. You got to fill that area in where the elevation is dropping away from horizontal. Because that tangent plane is tangent right there at that one point. It's a 59-foot elevation. But 59-foot elevation is dropping away from that plane in every direction. So now to get back up to the elevation of the plane, you've got to increase your actual elevation, right? Have to.
Made a plane that's parallel. So basically, that where that cross is, like where you made that cross, that's not attached to LIGO at the bottom left of your picture. Yeah, if you made a plane that's like you create a horizontal plane at that elevation, being the elevation of 59 feet,
right?
That would be parallel to LIGO, but LIGO would basically, okay, so right, yeah. So it would be parallel, which would raise up 4 feet as you go north.
Yeah.
But SC was saying that was impossible. I don't see why you would think that was impossible. It makes sense that, or it seems crazy that somebody would believe that, but I don't know. It's like if you need to make that, you need that to be done, measured, and created. It's not, it's not impossible. So
no, it's
hard
not.
to do, but
yeah, it was hard to do. I'm sure. That's not a trivial exercise in terms of construction. But yeah, it makes perfect sense. It does exactly
that video.
what we know it does. You've got a plane, a tangent plane, that is tangent at a particular point, which is a particular elevation. In this case, 59 feet, and the elevation that 59-foot level elevation drops away from the tangent point in every direction. So now once you move away from the tangent point, there's a gap between the plane and the 59-foot elevation, right? Has to be.
Right.
So to make the elevation match the tangent plane, the elevation has to continually increase. Further away from that tangent point you get, the more the elevation has to increase.
It's still hard for me to I'm just trying to imagine the curve of the Earth and how LIGO's I'm just trying to picture. I'm picturing that plane. The plane's at the 59 elevation. Hold on. Oh, right. Yeah, that's why it's only increasing by 1 foot as you travel east, because that's the same. It's like it's the same distance as the center of the other arm to the end of the arm. Right. Yeah.
Exactly. Exactly.
You know what? It's almost like this is probably not going to help anybody else, but it's like if you were, so the way you drew it, there's like one rectangle in front of it. If you drew another rectangle on the right side of that, and then 2 rectangles on the left side of that, and then 4 rectangles on the south side of all those, you would end up with a big square with that crosshair at the center. Even though that doesn't represent LIGO, that big square would be a tangent plane to the sphere. Or
all right, yeah, I see what you. Yeah, I see what you're saying. Sure.
Okay.
And maybe that would be more helpful to some people to help them visualize it. Because
it's just weird.
When I think about a plane, I don't think it has any dimensions. I don't think of it in terms of dimensions. It's an infinite thing that goes everywhere, right? So I don't have any problem visualizing that infinite thing touching the 59-foot elevation of the sphere at that one point. But it might be a little confusing for some people.
Well, it was just confusion. It was confusing for me to imagine that plane in reference to LIGO. But like I said, in reference to that plane and the square that's on that plane, because LIGO is, if you did it that way, LIGO is kind of an awkward. It's not really in the corner of that square, or it's sort of like. I'm going to draw it out for a second.
Is that the laser? The maybe I'm just a retard, but is that the Michael Morse?
I'm sorry. Say again.
Hold on. I need to gather my. I had to Google this so I can pronounce the name. Michelson. Is that the Michelson-Morley experiment, or is that something else?
No, this is LIGO.
What is that?
That's the Laser Interferometer Gravitational Wave Observatory, one of two of them that we have in this country.
Oh.
So it's related to Michelson because it is based on the Michelson interferometer.
Oh, something else then.
You know, the one for the Michelson Gale, that I forget how big that was, but it was fairly big as well. I think it was like 40 meters by 40 meters or something.
Yeah, something like that.
Something like that.
And what is the plot? Well, what is it? What is a?
Well, it's an interferometer, just like it's just a perfectly aligned interferometer, so that they can measure. Say what?
I think I remember seeing a video from Marbles. Oh,
Yeah, well,
you're live streaming.
Oh, he is, yeah. Lewis.
Approximately how many miles is that apart from each other?
I think each arm is like 2 miles, one or 2 miles.
Yeah. Each arm is 2.5 miles, so 13,100 feet.
So they adjust the. They have to take account of the curvature when they adjust the equipment. Sorry.
This is the one, of course, at Livingston, Kosha. When you go to the one out in Washington, the point of tangency out there would be up there on that upper arm at the left-hand end of it.
Not at the point between them.
No.
It's not between. It's not the base.
No.
Okay, so it's actually at one of the endpoints. Okay.
Yeah, it's the end point of that upper arm. That's where that one was.
Yeah, because
they say very clearly in their information that they pick the point of tangency to best suit the particular site. In other words, the way the natural terrain was lying.
Yeah, that makes sense. It's less work.
Yeah, well, you don't want to go out there moving dirt around for no good reason. The less of it you do, the less expensive it's going to be.
Yeah, I remember seeing a documentary talking about the funding and like how, at first it was difficult to get the funding, to ask for it. Like it's like it was a tall ask.
Oh yeah.
Well, I mean, because actually, it wasn't even. It was only, a consequence of, Einstein's equations. So it wasn't even confirmed when they built it, right? Like a gravitational wave.
Yeah, they were predicted, but no one had ever been able to measure one. You couldn't until you built this thing.
I mean, that would be kind of difficult to ask for. You might not find anything.
Well, the funny thing is they actually admitted to begin with that what they were building was not going to work.
Yeah, I know that there's people that work there. I know that were worried they weren't gonna find anything.
Well, they said they were pretty plain about it up front that the original mirror arrangement was not going to be good enough, but they needed to build that to find out how much better they needed to make it. So that's why you got two phases to LIGO. They built it first and tested it for quite a while, and then stopped, redesigned the mirror parts of it, the real exotic stuff, and then went back in and rebuilt it. And then they got started getting the gravitational wave detection almost immediately, actually.
Is it true that they were testing them and gave them like a fake reading?
Oh, I'm sure they've gotten plenty of fake readings. That's the reason they got two of them.
Oh yeah, right, exactly. That's what I said. But that's how you can confirm that it's real. But somebody said that they were testing them and giving them a fake reading. I think for both or something like that, just to test them and see if they would, like, if the team would measure it correctly or something.
Oh, I don't know. Maybe.
But he was trying to use that as evidence that they faked the data.
I feel like this is a little too complicated for me to understand.
It is a complicated machine, that's for sure. No doubt about it.
Well, I like to see pictures of the machine working, or see the actual observation first. That's just the way I am, and then study it. But if I don't see the observation and then I hear explanations, brain gets very confused. Maybe it's just the way I am.
Well, seeing that machine working is going to be a lot like watching Cavendish working. It's about as interesting as paint drying, honestly. There's not much to see.
Well, at least I can see Cavendish. At least we can replicate that observation. And you have videos of that too.
Got a few.
Yeah.
Actually, I got a few hundred hours of it.
You have a whole live stream where you plot it. Yeah. I'm gonna watch that.
Oh, I got lots of live streams of it. Usually around about 3 hours.
Oh, but that's good. I really enjoy those because it's hard for some of us to go to the physics labs and replicate it because some of us actually do observe things.
Yeah, it's not. That's not an easy experiment either. Not an easy measurement. I won't even call it an experiment. It's not really that. It's a
You put two masses like separated by I don't well you the idea is to watch mass attract mass. That mass attracts mass.
Well, yeah. The idea is to be able to measure the gravitational constant. In order to do that, you need to be able to measure the force of attraction between two masses. But that's a tiny number. Still quite measurable, though. Just need a special device to do it. That's what that thing is. That's what a torsion balance is. Well, what makes it difficult, though, is the the fact that, when you make measurements, most of the time you're making measurements using equipment that's already built. You've already got your anemometers or your voltmeters or ammeters or your oscilloscopes or all that, test equipment. You already have all that stuff. You don't have to worry about that. In the case of Cavendish, it is the measuring device. It itself is actually the measuring device. The only thing apart from it that you need is a ruler and a scale. Okay, so y'all squared away, Coach. That makes sense now.
Yeah, I'm trying to make this picture, but it's yeah. But yeah, like I said, I got to think about it in that weird way that I was describing. But yeah.
There's a video that I just watched. When they say gravitational waves, what do they mean by that? Like,
They're like ripples, like ripples in space time. Supposedly, like when there's a giant, like something like a kilonova, or like two neutron stars, colliding,
Or
like
like
they're
ice
orbiting
cream
each other.
sherbet.
Yeah,
no, but
exactly like that.
when they say that we detect gravitational waves, like,
Well, that's why they're using this device, is because the ripple in space time, the gravitational wave, is like it's like a ripple that's moving through space, and it's shrinking. It's like it's like a like oscillation. It's like if you space time were the ocean or something, like a sound wave moving through water. It's gonna oscillate as it's moving, and so for space time, it would like as that gravitational wave moved past a point, it would sort of like shrink and extend like a region, right? And so what they use those arms for, because it's a very small measurement, it'd be very hard to detect. And so basically, what it would do to LIGO is, as a gravitational wave is passing by LIGO, it will shrink and extend one of those arms. So they're measuring the interference pattern between the light on both sides of the arm, and they can tell by the disturbance, like by the interference pattern, if there's a disturbance, like if one of the arms is shrinking and extending, basically. Does that make sense?
oh, that helps. Yeah, thank you.
They also have like, if they, by just having one of them, like there could be errors, like there could be vibrations nearby or something, and so they have multiple of these, one in Louisiana, one in Washington, and so when a real gravitational wave is occurring, they'll experience it at both these locations, and there'll be a gap in time, like there'll be a slight gap in the amount of time, and that will kind of tell them which direction it's coming from. I hope that helped a little bit, but
No, it helped a little bit. It's just that this is just complicated. I just saw that video. So I think that's as far as I'm gonna go. As I have free time here, I'm gonna look into the Cavendish experience now. See.
oops. Oh. Yo.
Yo.
I fucked it up. I'm making this thing right now to see if it makes sense to anyone. Hold on. Regarding LIGO.
What topic or what are you exploring?
So what?
What is it that you're doing?
Making something based on what Blue was explaining to me about LIGO. Almost done though. Hold on.
Oh, okay. Right, Lego. Okay, I'm gonna look into the Cavendish now.
Okay, here it is. Yeah, I don't know if you're still there, Blue, or anyone, but yeah. So LIGO is outlined in blue.
Oh, that's the tangent point at blue.
Yeah, that's a tangent. That square is on the tangent plane, right? That LIGO is also on. That makes sense to me. It's hard to kind of picture otherwise, for me at least. Like where it is, like where it's tangent to.
Shouldn't it be like at each arm, wherever that arm is horizontal, is it simply a matter of drawing perpendicular to both of those points? That's correct, right? So the east-west arm, no?
Yeah, well, no, because what do you mean?
Well, the east-west arm, right? And you've drawn the line perpendicular to that to meet the blue point.
Right.
Is the east-west arm perpendicular? Sorry, is it horizontal at the middle of the arm?
Right.
Okay.
Yeah, it's the middle of that arm, and then
the end of the
so
other
not
one.
the other one. Yeah, right. And then the one in Washington, which is like the Blue was saying, was the horizontal or the horizontal plane, the tangent plane that it's on is at the end of one of the arms in the Washington one.
Oh, I should go and find the elevations. The website. You
Well, they
got
were in
the
that.
elevations.
Yeah, they were in that video that you posted.
That's the LiDAR. I'm looking at the LIGO website, trying to find the elevation plane.
Well, I mean, in the video you posted, there was a couple of screenshots or shots of the data, and then there was also in the description. I think you already saw that there was like the builds or like all the blueprints.
I will check it out.
I thought that was interesting because I'd never seen that before. I looked for that before.
Just a quick question. Oh, shit. Train signals.
Yo.
I was gonna copy and paste it on Discord, but oh no, I can't do that.
No, that's right, Kosho.
Yeah, but do you see how it's hard to have intuition for how that's oriented with the horizontal plane? For me, I mean.
Okay, that image that I posted.
Oh yeah, this is a question for Blue.
What?
Is that mainly what the Cavendish experiment is? Just looking at that observation, would you be able to gravitation?
Yeah, in a really simple, a very simple
That's-
drawing. Yeah, that's what it is.
That's how it is. Okay.
Those big balls are fixed, right?
Right.
Just do some math and figure that shit out.
Yeah,
The math is
I do a few videos. The math's not hard to do.
math. Yes, it's just algebra.
No, I love doing the math. I love doing that. I always figure that shit out. That's the fun part.
Well, that's the cool thing about it is if you know the acceleration based on the torsion, and you know the masses of the objects. Basically, the mass is the weight of the objects.
Just call M1,
and their
M2,
masses.
call it F, call it whatever the fuck, figure that shit out.
And you can derive
like a physics student.
Derive the big G, the mass of the Earth.
Yeah, this thing doesn't care about the mass of the Earth.
But it doesn't.
Yeah. Doesn't care about the mass of the little balls either.
Oh yeah, that's right. Yeah, just the mass of the of those large balls. Based on the mass of those larger, the mass of those larger balls, and the weight, like their weight on Earth, you can use that to derive the mass of the Earth. Because you can find the big G from this test.
Yep. That's what we're doing.
Well, people say big G is like they say it's in question when it's like when they say it's in question, it's like they know it's the 11th digit or whatever or something like that. It's like plus or minus, like something all the way to the end of it. Because somebody keeps posting evidence that like there's a school that is off by orders of magnitude or something like that. But they're talking about like 9 or 10 decimal places. It's like,
yeah, it's not off by orders of magnitude. It's known to within about 20 parts per million, I think.
I think Cavendish, didn't he get within like 2% or 1% of?
Yeah, he got within 1%. I got within about 0.6%. But I cheated. I had lasers.
That's what I was going to ask you. Isn't that another way to determine it? Because otherwise, you have to use the actual torsion, right?
No, you have to just read a physical scale, see how much deflection you're getting. And that's hard to do. It's doable. I did it on one test. But it's really, really a pain in the ass. It's a lot easier to bounce a laser off a mirror.
Wait, how did Cavendish's torsion balance work?
Same thing.
Like it was, I know, but like how precise was it? I mean, like I'm just trying to imagine like how it would have been able to measure within 1% of what we know to be today.
Well, you put a little scale on the end of the torsion balance and a window in each end of the cabinet, just like I did. I did exactly what Cavendish did. And so you've got a scale and a vernier that you can look through the window and see the scale. And you just simply sit there and write the numbers down. You visually measure it.
If it wasn't for, not that you're a weirdo, because you're not Cavendish, you just did the Cavendish, but Cavendish was a weirdo. And if it wasn't for weirdos like Cavendish and even...
What are you talking about? We're all weirdos.
Yeah, no, but these guys were exceptionally weird because, like we're talking about, like I always thought like guys like Aristarchus, he was so clever. I was thinking that he may not have, like, that seems to be somebody who doesn't, he's not even worried about women. You know what I mean? He's not worried about girls at all. Like it would seem to be, because he spent a lot of time coming up with like really clever stuff that other people, just didn't even put their minds to, basically.
Saying shadows.
He wasn't
making stuff up.
distracted by Aristarchus. He wasn't really messing around with shadows as much as angles and
angles of what?
Hey, Mark, please stop.
I'm asking a question. You don't like questions?
If you go back
Okay,
up
guys. No
Cafe,
school, no questions, no globes. Don't answer any questions.
I posted that video of mine on the right hand side. That's a view through one of the windows at the scale, and the scale is exactly the same as what Cavendish used. I went by his description of what he did, and this is something that where Whitsitt gets it all fucked up.
Can I go get that scale at Walmart?
Cavendish described them as telescopes because it was I would be more inclined to call them microscopes, but he had little telescopes going through the side of his building just within a few feet of the case. Whitsitt tells the story that the guy goes to the other side of the fucking property with a telescope or some bullshit, but that's because Whitsitt doesn't know what he's talking about as usual. That's very much what Cavendish would have been seeing through his telescope. Exactly what I was showing with my camera.
The one that Shadow posted?
Yeah, go back up at 1248.
I haven't seen the videos yet, but no, your videos. You have like 5 parts.
I see it, yeah.
It's a scale on the lower right hand side. Yeah.
Yeah.
The upper part is attached to the actual balance arm itself. The bottom scale is stationary.
Oh, okay, yeah.
That's clever. Meter.
Would it scare you guys if I posted a little picture in the back? Would that like hurt you guys or what? I mean, talk what you're talking about. I just want to know, can I like post one picture? That's about it. Go ahead. I'm sorry.
You share it with me. I'll post it.
No, you didn't. Stop lying. You're a
I said
damn
you
liar.
can
I gave
share
you
with me.
15 videos. Stop lying.
Why are you asking
I
now?
Stop lying,
Volunteers?
Ocho. Can I put the video in here or not? Stop telling me to send you something. I don't want to send it to you. That's stupid. Stop being goofy, please.
Post it
I'm
on the live
asking the
stream. Of
people
course
of
you can do
Geo's
that.
chat, bro, not you. Sending it to you is not going to help me out. Okay? Do you get that? Thank you.
Earlier you asked what Aristarchus was measuring. He measured, for instance, the angle between the sun and the moon.
An angle.
Yeah.
An angle from where? On what? On what? What do you measure an
On
angle
the
on?
Earth.
What do you put it on? He measured an
On the
angle
Earth.
on Earth. What does an angle do for you? Draw an angle out and show me what you're measuring with that, what you do with it.
He measured the difference between that angle and 90 degrees. And
He measured space. He measured the hold on. He measured the difference between space and a shadow. That's so awesome. So space and a shadow gives you ball.
Oh, for fuck's sake.
That's weird. Yeah, shadow. And
oh, shadow the person. What did you say, shadow?
Osho, thank you, whoever. I'm gonna send you a DM. I'm gonna ask you the most embarrassing question ever. So.
Okay. I'd answer it publicly, but okay.
No, just DM.
you don't have an angle on a globe. Where'd you put the angle on a flat piece of paper, a board? What'd you put an angle on? What do you mean an angle on what? An air angle? Let me see how that works. Show
Yes.
me one.
It's
An
actually
air angle.
separation
How
between
big of an
2
air
points.
angle? From left to right, what does an air angle look like?
No, it's just between the sun and the moon, wherever they happen to be.
What's the distance? What's that distance look like between
The
93
angle.
million miles?
We're not
93
measuring a
million
distance.
miles between the sun and moon? Is that
We're
so?
not measuring a distance, Demok. It's an angle.
Listen to me. Can you hear me?
I can.
The distance between the two.
Yeah, we're
Where
not
can I
measuring the
find that
distance.
out so I can make sure what you're saying makes any sense at all? Where do I
We're
get
not
the
measuring
scale
the
to go
distance,
from?
Demok. We're measuring an
What
angle.
scale do I get to measure from? Where am I going from? Where's your key
You're on
legend
the
to go off?
Earth. You're on the Earth. You measure the angle
No, that's
between the
called
sun and the
making stuff
moon.
up. No, that's
Okay,
making
Jack.
stuff up. So you say from the earth, and that means what you say, right? From the
Yeah, you're on
earth,
the Earth.
flat earth. From the earth, I get an angle, flat earth. What's next? Teach me.
You gotta open it up for people to talk to Mark. Respond
Oh,
to you.
go ahead. Go ahead. I'm shut up.
So Viriv's not gonna tell you. Well, maybe Viriv is gonna say something.
Oh, if you're facing forward and then you turn around, face the other way, you've measured 180 degrees, no matter what you're looking at.
Or if you get a pair of scissors, and you line one up with the view to the sun, and the other scissor up to the view of the Earth. I mean, of the moon, or sun and the moon, right? You measure the angle that those scissors are making, and you have an angle. Doesn't matter how big the scissors are.
Or how far away the sun is.
Right. I posted your picture, Demox.
One.
That symbol.
I got you, man.
Just
I
DM it.
got you.
Thank you. It's a stupid question, but
That's fair.
what's it? I see that on Stellarium. It has a specific number.
It's different on. Okay, so It can mean two things. Like it can mean like feet and inches, or it could mean minutes and seconds. Does that make sense?
I think on Solarium when I used that, I kind of had to figure it out, and Google fucking didn't help for some reason. It was like it was 0.60 or something. It was a number.
Right.
So, like,
So with the angle, there's 180 degrees, 52 minutes, 48
okay,
seconds.
72 double prime. What does that mean in terms like of 72 degrees and something something?
Yeah,
It should be
72 degrees. Go ahead.
Shouldn't be 72 seconds, right?
No, it's just an example. I'm just throwing a number out there. 72 degrees, something something, double prime. What is the double
so
prime?
every degree is split up into
No.
60. No.
Okay, go ahead. Sorry.
Yeah, every degree you can split up into 60 arc minutes, which is the single prime, and then every arc minute is split up into 60 arc seconds.
Don't use arc minutes. Don't use time evolve. Just use like in terms of just degrees.
That's what those primes. That's what the prime means.
Yeah.
So it's like one. Yeah, it's like 1 out of 60. So just you can convert it to a fraction if you want. So if it's like one, if it's 72 degrees and then some number prime, that first prime is going to be 1 out of 60 degrees or whatever that number is out of 60 degrees.
Yeah.
So the arc minutes. That's what arc minute is. It's like a fraction of a degree. So that number, just put it over 60.
You get this.
Just like on the Stellarium, I see that double prime when I look at angles. Like it gives you the values.
Yeah, you can change Stellarium to use decimal degrees.
Because I understand angles, but just to keep it simple, in my head,
I got you, man. I'm gonna show you something. Hold on.
Yeah. Okay. Now, in terms of distance, inches. It literally just means inches, right?
Yeah.
Yeah, feet and inches.
Feet,
so 1 prime is feet. 1 prime is feet and 2 prime is inches. Yeah.
Oh, okay.
Double prime. I mean.
Oh my god, I'm so stupid. Okay, thank you.
Yeah, it's fine.
So how many miles does that equal? Between the sun and the moon, how many miles? I mean, when do we see 93 million miles,
We're
guys?
measuring an angle, Demok. Measuring an angle.
No, 93 million miles. When do we see that? I want a picture of what it looks like. Do you understand or not?
I do understand.
Okay?
Do you understand that the angle doesn't care about the distance?
I don't care about your angle. Give me the distance, pal. You don't know the distance? Then just tell me. It's all right. If you can't calculate it, let me know, buddy.
Okay.
I'm just used
All
to
you
like
gotta do is say, I don't
meters.
know, Democ. Say, I don't know how to show you the legend of 93 million miles, and I don't know what I'm talking about because I have nothing to go by in space because I don't even know that. You can't even demonstrate what 93 million. No, it's not okay. It's not okay for any theoretical astrophysicist or anybody doing math for astrophysicism to say they don't know the distance or what it looks like for 93 million miles. What am I going by here? What are you guys going by? Imagination.
Tag you in
You
the
have
chat,
no
Demok.
scale. Yeah, scales of imaginary elephants. We know.
But what does a
Millions of
distance
miles of
look like to
elephants.
start with?
You tell me. I'm asking
I
you,
don't know.
Glover.
What distances exist? How do I tell you
You
what a
don't know what
distance looks like?
93 million miles looks like. It's crazy.
You tell me. It sounds like the only way to describe a distance is with units of measurement, like miles. 93 miles looks like 93 million miles.
Couldn't tell you. You won't show me, math guy.
You got like a picture book of different distances and what they look like that we could use for
Apparently
reference?
you do. You got miles in there too, don't you? In an atlas.
You need help, Demlock. You need help.
I'll be back. Hey,
Yeah.
let me. I want to say something real quick before I take off. Like I'm generally used to like just meters, kilometers, and the standard units because every physics class that I've took or every physics class that any person, all of us took, we don't use the miles or feet or any of that shit.
Yeah, I figured.
And I generally ignore that symbols.
Supposed to be should get it.
Yeah,
Yeah,
I got my Stellarium set.
every other science class probably uses them, and maybe I'm not acquainted with them.
You still there, Shadow? I'm about to post this thing.
Boobies. How good are boobies?
There's Shadow. This might end up confusing you more. That is funny. It does look like boobies. Shadow, I don't know if you can see that, but or if it makes sense.
You guys are asking.
Do the 45 over 3600, I reckon.
Yeah, but you guys
Oh,
are
yeah,
the
that
math guys,
would
and you're
definitely make
asking
sense
me.
too. Yeah, that's true. It's like
All the
not gonna
globe
make sense.
math
That makes
guys
more
who
sense.
make the. Well, you guys are asking me what 93 million miles looks like on your math scale that you're going by. That's pretty weird, don't you think? If you guys made the scale, how would I know what your imaginary scale looks like if you don't show it and present it in inches and feet yourself? So what's 93 million miles look like in inches so I can match it up to stuff?
What does 93 million miles look like in inches?
I don't know. You guys said the sun is 93 million miles away from the moon and the earth, right? So
Have you got a calculator?
when does that match? At what point in time in the sky do they match that distance? When can I line the legend up with 93 million? Do you not comprehend? Is this beyond you, or fifth grader can do it for me? They can go get a legend at the bottom of their map that says how many miles and inches this building is away from this one. So I can put that little legend up against everything on the map. Can you do the same for me? Or is that too complex for you?
It's pretty complicated.
Pretty complicated. So where'd you get 93 million from? Where'd you get that from if you don't have it? What scale? You don't have it.
So
You don't
fucking
have the
dumb.
scale.
Demak, you got it. Demak,
I'm
you just have to
asking you
get
for the
people.
scale.
You got to give people a
Stop
chance to
yelling my
respond to you,
name.
man.
The scale. Where'd
Then
you get it,
you
Coach?
got to give people a
Coach?
chance to respond to you.
You're not
Tag you in the chat,
responding. I
Demo.
said, where'd you get the scale? You're saying everything but. I asked you
Where do
15
you-
times for what it looks like, and you're not giving me the number or the
Where you
fucking
get a
picture
map scale
visual.
from? Someone that makes a map. Someone made it. Just a
Someone
scale.
made it. So where'd they make it at, and where can I get it? How do you know? Where's it at? Let me see it.
The map making office.
How
Go
did you do
find it.
math of 93 million miles without the thing that told you what 93 million miles was? How did you do that with no comparison?
All right, I've tagged you in the chat, Demok. So there.
What do you compare to?
Yeah. Disregard the chat. That was a dumb.
Yeah.
So how many arc degrees is 93
Bro.
million miles?
Need help, man.
Yeah, get help with your math that you don't know how to do, apparently. Apparently, your whole system just broke down with 93 million miles that you guys calculated in the first place, but have no clue of what it looks like. And you couldn't even show a fifth grader. So the fifth grader sitting here would love to know what 93 million miles looks like in inches, please. Is that too hard? Is
Do you have
that
a
too big?
calculator, Demok?
What, feet? What do I got to use? Meters? What? Millimeters? What do I need, guys? Show me how I measure 93 million miles in space from object to object. We want to do it ourselves. We want to be like you guys and do great math.
All right, I've tagged you in the chat.
Oh, thank you. That's perfect. Thank you so much, Kosho. Thank you.
Thank Ruhif, man.
Thank you, whoever. Yeah. No,
Thanks,
that's exactly what I would see. Just something simple. Okay, that's 46 divided by 60, 45 divided by that. Okay.
Yeah, each of those fractions represent a degree. Okay, so that's 46 out of 60 degrees, and that's 45 out of 3,000 or 3,600 degrees, right?
So it's
yeah.
40 degrees with the invisible plus sign because the notation in this fucking world is stupid. And
That's a good way to convert it to a decimal too. If you would ever convert to a decimal, just add those to the 40. Yeah.
I'm just gonna think of it as what that looks like. Like when I see the prime, I'm just gonna look at it divided by 60, divided by 60 square. Leave it there.
Yeah, but sometimes it's good to have an intuition for arc minutes and arc seconds though too, because
No. Like when I look at the like angle in Stellarium, I like to just look at just the angle that
yeah,
measured.
I know what you mean.
Like the
I know what you
apparent,
mean.
like the time or coming up with the model of the distance that goes the moon goes around the sun, 360 degrees is, or like I know the term arcs, minutes, and everything.
Yeah.
Because like 20, the moon goes around 1 month, which is like 30 days or some shit. 30 days already is in terms of like how many degrees does it pass in whatever minute or something, and that's probably why where the yeah, I get all that.
Yeah, there's a
So
setting in
Pythagoras,
Stellarium where you can change it to decimal degrees. Probably easier.
Pythagoras was smarter back then than 5 Globers today. He did all that by himself in sandals. He's a bad hammer jammer, you guys. He's pretty cool. No calculators, no Google, no nothing, like just sand and a couple sticks and some sandals and a cool dress. He did a lot of good math.
It's like
Oh,
Aristarchus,
yeah,
man.
Did they figure out
Yeah,
based on their
whoever
measuring
Aristarchus.
sticks or whatever tools they used that the a square plus b square equals c square, and they
Well,
figure
you
all the
guys can't even
geometry
show me
values
what
out?
93. You guys can't even show me your scale that he used. What was his 93 million miles to go by? Where did he get that from? He made it up, right? He's made shit
Well,
up.
no, that's what I was telling you about Aristarchus, dude. The angle, the reason why he measured the angle between the sun and the moon during when the moon was half full, the quarter moon phase, he did that because he understood that if they're at different distances, right? If whatever difference from a 90-degree right angle that angle was, uh, shit, my girlfriend's on the phone. She's been super loud. Anyways,
shut the fuck up.
yeah, I know that he could use that to determine the ratio from the distance of the sun to the distance of the moon.
He
Anyway,
didn't
so if you
measure
do that
very
accurately,
though.
yeah, exactly. Because he
And then
wasn't doing any
when did he
samples.
physically back that claim with physical, like up close measurements, up close
Well, we did.
calculation? Huh?
We did that.
Somebody got like 2 foot away from the sun.
Yep.
Dang, you
That's
guys
how
are
we
cool.
measured it.
Which one of you did it?
Kosho.
Kosho got. It's pretty weird. You guys are up by the sun now. All of a sudden, you have quite an imaginary imagination. You guys flying through space in your imaginary rocket, making sure the sun's where you said it was. When you can't even show me what left to right 93 million miles looks like. This is actually pretty sad. So the sun and the moon, east to west, they sit in the sky. And you can't tell me at what point, at what time they're 93 million miles apart. Is it during the eclipse? When supposedly the so smart guy thought they were the same size and so far apart, and this, so when they look like they're touching, is that when they're 93 million miles apart? Or which time of day, left to right, when I see them, one east and one going west? At what time? What are you guys even talking about? You made no sense at all whatsoever. So
It's all
during an
very good
eclipse,
questions.
well, why do they look like they're going out 10 miles and dropping, but you think 10 miles equals 93 million? And then if I see them left to right within so many hours of a day, what's that, 93 million? How many miles did that cover across the Earth?
Right.
That's not 93
It's
million.
not. We got to
So
respond
which
to your
scale are
questions
we
now. Hold
going
on.
across and against? What are we going against? Just imaginary shit, right? Nobody's ever touched the fucking Earth physically and measured the whole Earth, you know that, or the sun, or the distance in between any of that. So every
Okay. I think somebody's trying to answer your question.
Thank you. No, somebody muted him.
Peace and quiet.
I'm asking the chat GTP for this. Really helps.
Because girls is players too.
I don't know. I don't understand just the aggression.
He's got issues.
It's got like a lizard brain thing going on.
Yeah. I really want to be respectful to flat earthers now. I really don't want to insult them or anything like that. I don't think we should.
I'll tell you this much though. There's times where the mock does have a he brings things up that definitely I don't hear other flat earthers bring up. It's definitely a different way of looking at something.
Very tactful of you there, Kosho. I would say Demox says a lot of stupid shit that even flat earthers wouldn't be able to come up with.
I mean, honestly, so I was talking about the GPS test, the GPS, and so there's like dropping horizontal. But the mock would bring up things like, the buildings tilting away from each other. It's like basically plums tilted away from each other. But yeah, measuring buildings tilting away from each other is something that you could do with a precision GPS. Be an interesting test.
Yeah, but the GPS coordinates, regardless of whether they're leaning away, just the GPS coordinates are proof of globe.
You know what a good one that Demox said on that one? Okay, so you take a cube or some kind of a big square of some sort, and you're looking at it from far away. Now, let's say the elevation of the cube is like 10 feet. It's a very large size one. And so it has a top, side, bottom, a whole square or a rectangle. Now, let's say the elevation of that is 10 feet. And then let's say you're far away, it's far off somewhere, and you're a little higher than 10 feet. So maybe you're 15 feet. So over a planar surface, you'll be able to see the top of the cube.
Right. Yeah.
On a globular surface, that cube is tilted away. You will not be able to see the top of the cube, depending on the math, the calculations, the distances, and so on. Now, even to add to that, maybe put lights on the cube, in the back, in the middle, in the front, something like that. And on a globe, you'll maybe only see the front light, but you won't see the ones in the back because it's tilted away. So I think that's actually a really good thing that we could do. It's a good test.
It is decent. You'd have to rule out any kind of refractive possibilities, but
it shows the tilt because you won't. Yeah, on a planar surface, they're coplanar. You'll see the top of it. On a globe surface, because of the curve, you're not going to see the top of that thing. It's going to be shooting off the other way.
You know those pressure things we have, like little kids run in their shoes? When you smack the bottom of their shoe and it lights up? You can actually put a little thing in there, and when the plumb bob gets anywhere from zero, it touches pressure on the left or right and lights up itself and lets you know when it's off plumb. You can put a camera in there focused on the reader so you know what the exact reading is too from your phone at home. Let's go do some stuff, guys. Technology is great.
They'll always be plumb now.
We can float them. We can make floaty ones too. Don't worry, we can put them on water. It's going to be awesome. So many excuses are going to pour out now for no reason at all. It's going to be great. So many ifs and buts.
Don't forget the ands.
So what's wrong with that, you guys?
I kind of already told you.
You told me what? Show me. Show me on a little ball how that would be wrong.
If you put plumb bombs in different places and you just make them so that the sensor will tell you if they're not plumb, they're not going to go off. They're all going to be plumb.
Is this for a different one or for the cube one?
Hold on a second. They're all going to be what?
Plumb.
So the light will never go off to show you unplumb. Is that what you're telling us?
Yeah, as long as nothing's influencing them to, not be plumb. Yeah.
They're going to sit horizontally on the side of a hill, globe, earth turd.
Why did it say
how would they not light up? You okay? One hair off 0 makes them light up, Kosho. Do you understand that?
Yeah, but if they're plumb bobs and they're hanging,
No,
they're all
one
going to be
hair.
plumb.
Yeah. That's the point of flat Earth. Welcome to no globe. You can't do that on a globe. Go line up a whole bunch of plums on a ball and show me where they all equal plumb. That doesn't even make any sense, dude. You're not even making any sense.
That's what you want to do. You want to see if they were lined up. They'd all be plumb. The
Go
question is,
get
are
it.
they lined up?
The question is, where do you got a ball? Show me your plums being plumb on a ball. Only one will be plumb. I'm sorry to hurt your feelings. Go get any size ball you want. Don't say Earth. You got to get a real ball and demonstrate your claim somehow physically in reality here. That's what you guys keep wanting to run from. So, like I said, you can get the smallest little crystal cube you want. You can get the biggest ball you want that's like a cue ball. Make sure it's smooth like a cue ball. And go sit little cubes on there. I mean, you're not proving me wrong by just talking about imagination. Never. Right? Showing me would work better, right?
Girls as players do.
So Gio, do you understand that he said there's no way in a million years that any of these plumb bobs would ever be anything but plumb on the globe?
I didn't say that.
That's exact. You said none of them would light up, correct?
No, I didn't. I said they wouldn't light up because they're all plumb bombs, and they only light up if they're not plumb. Nothing's making them not
Why
plumb.
would they not?
But the question is, are they lined up? Are they parallel with each other? That's the test that you'd want to see. You want to see if those plumb bombs, which because they're not lighting up, are all plumb, are they parallel with each other? And that's
What
the
are you
test.
talking about? When they light up, it'll show you it's not parallel. Only when it lights up. Yeah,
when it lights
that's
up,
what the
it'll
light's
show
for,
you that they're not
Kosho.
plumb.
Touch, light. Kosho, work with me here, buddy. Touch, light, globe. Okay? No light, no globe. Only on a horizontal plane will they be plumb, Kosho. Only. Only. Not a non-horizontal anything will they ever be plumb. What are you talking about?
Okay, well, I drew a picture here with Aristarchus's measurement.
It doesn't matter what you drew. Demonstrate your claim on a real sphere. Drawing cartoons does not help me, SE, or Geo, or anybody in this fight to debate against you guys. We're not talking about what your imagination is, and I'm not trying to be mean. I'm saying physically, where are the attributes that you claim to be on a sphere other than your imagination? It's not in a lab. It's not in physics class. It's not on an 80-foot sphere. It's not on a 90-foot sphere. It's not on an over there sphere. It's not over here. I'm done.
You really like Dr. Seuss, man. You remember you used to always bring up Dr. Seuss. I like that book too, man. Green Eggs and Ham.
Well, yeah. Well, demonstrations I am. Sam I scram from demonstrations. I'm just saying, like,
dude, in jams, he would always do these insults, and then he'd end it with like Dr. Seuss, like say call somebody Dr. Seuss, something like that. It's always so funny.
Well, I mean, it's like you guys are saying up but down, but in but out, but over but about. Like everything you say is the outburst, inverse. Why is it so? It's funny because it's true. You're like, this hump is going down, but it's humping, but it's rising, but it's square, but it's horizontal, but it's round, but it's smooth, but it's curved and level. I mean, I should shut up.
Fair enough.
Then earlier, when all the math guys are talking about so great math and how they're so good at math, little Democ, I'll call myself dumb. I'm retarded. Democ comes in and asks one question upon math that you base your whole reality upon, the sun's distance or radius or differential and like and all this, all of it's based on the 93 million that you claim. But when a little guy says, what does 93 million look like? You guys all get goofy and start asking me what 93 million looks like. That's your basis on your whole model. How do you not have that main distance?
Democ, you need a hype man.
I know.
Someone to be like, yeah, after you say stuff.
Hey, listen, you're it.
I gotta say
hold on
something
a
very
second.
quickly.
Can I post?
It's important. It's important though, bro. It's very important.
Go ahead.
My picture is inaccurate. I didn't mean to put secant. I meant to put cotangent. Just be clear.
I'll look at your cartoon. What's your cartoon showing?
Okay.
Well, I made
that's
this
not
years
the main
ago.
one. I got one more. I can't put. I have to. You have to. Sorry, Coach.
Distance to the
moon. I thought you were talking to me. My bad, man.
The sun, I mean.
So yeah, there's a picture in there, but I want to put another one that like just shows you the main, just my main.
I think you cut out.
Well, regardless, yeah, I made this years ago. That's why it's not accurate, but this is just a description of a test that I've done, but Aristarchus came up with it based on the quarter moon phase, which is when the moon appears to be exactly half lit, which you can deduce from that observation that the angle between the Earth, between the moon and the sun from the Earth should be damn near 90 degrees, but it can't possibly be 90 degrees because of the fact that the moon's half lit. If it was 90 degrees, then that would make a rectangle, so that's impossible. But he used that difference. He used the difference between 90 degrees and the actual angle. So it should be basically like 1 degree or 2 degrees, 3 degrees, something close. He got like 3 degrees, I think. We now know it to be like 15% of a degree or something like that.
So
yeah, you can use that to determine what's the ratio between the two distances. Like the triangle that's drawn there, the side that's the distance to the moon, and the side the distance from the moon to the sun. Yeah, that should be so the ratio between those two.
From where to where,
it would be
Kosho?
the other line, but regardless.
Sorry, I thought you were done. I'm so sorry.
I feel like I explain
From where
things
to
like
where?
Quentin Tarantino movies. So what?
Well, I know, but when you say your math and your angles and your degrees, from where to where?
From the distance to the moon to the distance
Yeah,
to the sun.
hold on. Do you understand what I'm asking you? Actually, do you actually understand what I'm asking when I say from where to where? I'm talking the moon and the sun. Hold on. When I look at them with my eyeballs and I'm sitting here, they look like they're sitting still. Then when I pull out my toilet paper tube, toilet paper roll telescope, they look like they're moving. I'm chasing them. Now, can you answer me just one important question? If I have a fish that never stops swimming, can I tell you where it's at in the water?
Yes.
You can. I'd love you to do that in real life with a fish.
Well, it's going to be a function of time. So you're going to pick a moment, and at that moment, the fish is going to have a position, and so you can easily describe that. It just so happens that the moment in time that we're describing is when the moon is exactly half lit. When the moon is exactly half lit, the sun and the moon are going to have angles with the Earth as the fulcrum, and that's what you want to find out, is what that angle is at that moment.
I didn't ask you anything about shadows. I said when something never stops moving and you can't put a flag where it ever is to go from or to where it's ever stopped at or started from, it's never stopped. Where do I put the flag to start my calculation again? In a shadow on something?
So,
Not the distance to where it's at.
Kosho, what other assumptions are you using in this? If you measure an angle, they're just going to be in their position. Like they have an angular position and they have a zodiacal position. So they're going to be in a position in the zodiac. And whether you view the sky as like a flat surface above or as a hemisphere, either way, they're measured in angle in the zodiac. So if you were to take an angle at quarter moon, you would get like the angle to the sun in relation to it being 90 degrees in the zodiac.
Right. No, yeah, you that's actually perfectly, I mean, that's a perfect point, because you can use the zodiac charts during a quarter moon phase to also determine that angle. So
that doesn't work.
Point.
Right. So I'm asking, like, okay, so this has worked and been understood over a planar surface since the dawn of time. Now the globe idea has come along with their ideas. So I'm asking for you to think it has something to do with a globe Earth. What assumptions are you using, and how are you extrapolating your conclusion?
Well, I'll say that this information on its own, without any inferences of what this information means, doesn't matter if it's a globe or flat plane, because
yes, it does.
It's only a description of these two objects in the sky and what their distances are in relationship and as a ratio of one another. So it's like, from observation, without thinking about it, they look like they're the same size. So you'll think, okay, they're the same size, they're the same distance. But if they appear the same size and they're not the same distance, then there has to be some ratio of the other, right? It's like if something is twice as big and twice as far as something else, and they're the same size. I mean, and they appear the same size, then it's going to be twice as big, right?
You know,
I just said that.
no, no. And on Earth, do you know every step of dirt that I stand in is going to be a different angle? Every mud puddle that I step in, from every cliff, from every canyon that I walk to, or every little blip or sliding slope in my backyard is going to give me a different reading to what you just said. And something that's going in an elliptical or a round circular thing that you're saying you got 90 degrees. Where's the 90 degrees in an arc? Where's the L? Where's the angle in an arc?
That's
It doesn't make
inferred by
sense.
the quarter. That's inferred by the half lit moon. Moon's half
Inferred, you
lit.
mean imagined?
Not inferred. It's inferred by the fact that the moon is half lit. So the moon's
That
half lit.
means
That tells you the
imagined.
sun. That tells you that the sun is at a 90 degree. If the moon were a fulcrum, then there'd be a
Yeah.
90 degree angle between
No,
the
it doesn't.
sun and the Earth.
I'm sorry. No, it doesn't tell me anything because you haven't went up there and verified it. You said if this, if that, if this, because I think that. Now, when have you verified anything that you just claimed? You've never been up next to the sun and saw him as a big guy looking down at him and saw the do this and the timing and everything. You've never seen any of that. Days don't have the same time. Positions aren't the same. There's clouds in the sky. There is no way in heck you could ever convince me that a moving object, you're going to tell me where it's at tomorrow or any other day when it never
Fair enough.
stops.
The funny thing is, you can use like Geo's the astrology chart, or you can use timeanddate.com and the subsolar and sublunar point during the quarter moon phase. You can use the information we know to be true and get the precise angle between them today, or not today, but I mean today's in the modern day, in the next quarter moon phase. You can use that angle and get the actual ratio, multiply it by the distance to the moon, and you'll get the same value that you get if you did like the transit of Venus or something like that. So it's just the fact that these values that they corroborate one another, same value, no matter which method you use, which
If I
gives you
made
confidence that it's correct value.
If I went by an old guy's math problem he's done shown 47 years in a row, it'd be hard for me to repeat it and say it was wrong from a flat plane standpoint of view. And then to say it's a part of a globe would be weird. And you said information. Information isn't good. Information doesn't mean true. Information can be bad. You can have the worst information or worst numbers and the worst printouts you want. All you got to do is keep adding more numbers to make it right, or take away, or add a cosine or a tangent or a special little trick number that makes you be right because trick numbers, right? Because cosines and tangents and, you know what I mean, little squiggly cartoon pictures instead of numbers, right? No physical attributes, no measure in the dirt, just cosine, tangent, globe. It's pretty weird. I mean, Coach, so you know how you can make any number seem like it's 666 or add this and that and it makes 9. And just the other day, Bacon or whoever did the 1.71. Like, who can't do that with numbers to say, my number's right now? I mean, that's all you guys are doing is saying, well, look, our number's right. That doesn't mean anything. I mean, if you want to go by numbers, look at the diagram I showed you. I'm showing you that a horizon is only 35, the clouds are only 35,000 feet away from me horizontally. There is no 3959 to cross. I'm on the outside surface of the ball. So whoever gave you that number lied to you there too. I don't have to cross 3959 if I'm on the outside of the mud ball. I'm already there at 3959. That's where I'm starting my journey. You understand that? Is that hard math or is that too complex? The sky is 35,000 feet vertical and horizontal. The math and the drawing is right there. That's a 360. It's 24,901. A little scaled 4 by 4 inch version of a little globe. Right there. Do the math. It's for all whoever wants to do the math with it. It's right there. 360. It's proof. That means every inkling of every millimeter that something goes away from you horizontally, it's supposed to increase in elevation. Every millimeter. It's supposed to go 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, just more, and then exponentially. That's what's actually supposed to happen. Not 8 inches a mile, not none of that goofy stuff. You can see in the math, it's right there. 35,000 feet to the clouds. If I can put my other picture, it'll show you way better what I'm talking about. It just got the only one thing set on it. That's it. It's the race for the horizontal rocket and the balloon. The balloon will go to the 35,000 feet clouds vertically before a rocket can go 1,000 feet in elevation horizontally. I'm giving them 34,000 for free, just 1,000 foot for any object, a fucking anything. I'm sorry, airplane, anything they got horizontally. And today, when you can put a camera on something and get away from it, they're telling you got to be so far away with a theodolite to see the diversion. But now, when you put a camera on it, there is no diversion on the plumb. Only when you get away with a theodolite. How does this make sense, Kosho? Let's talk about the plumb not being unplumbed with a camera on it. But then when Jesse or whoever looks at it magically with their theodolite, now it's going to be unplumbed for them? What's going on here, guys? I don't understand. So do we have unplumb or do we have unplumb? I mean, what's going on here? Because surely Jesse Gordon said that when he looks through his theodolite, he doesn't get plumb, right? Correct? So why go by his site from a mile away or two when you could just put a camera right next to the thing? And when he goes up and does this little whatever, and you got the camera sitting there, you're like, dude, camera, the thing's plumb still. What are you talking about? Does that not make sense? So literally, if you make the plumb thing light up, and none of them light up, not even the one Jesse Gordon supposedly looks at and sees 0 point whatever degree off a plumb, all you take is anything off zero will light up the thing. Anything off zero will light it up. If the wind blows by it too strong, probably light up. Be careful for the wind, maybe, depending on how you calibrate it and make it. You know what I mean? You can calibrate the pressure as you want. So we have cameras these days, guys. What do you think? And then the altimeter. Don't get me started on the altimeters. If I bought an Australian altimeter and I dropped it, does it raise in elevation? Should be able to drop that altimeter in a hole and it should raise in elevation, right, guys?
So wait, how do altimeters know how high they are? You're talking about the ones that are air pressure altimeters?
Yeah. The globe altimeter. How does it know how high it is again?
The pressure.
Pressure. So the
Yeah.
pressure around a ball is equal, right? At the same radius around every inch on away from itself, right? From the center out.
Not exactly equal, but that's the basic idea. Yeah, from the center out, the pressure goes lower and lower.
All right, and I got a picture right there that shows you all you have to do is let anything go horizontally and the elevation should start increasing. And then it should be exponential.
Right. So if you go horizontal from any point on Earth and you keep going in that perfectly straight line, then you'll get higher and higher, and so the pressure will go down.
Right. And yeah, in reality, that would happen off of a sphere. Yes. Now, what I tell them is I want to race their rocket or their airplane to 1,000 feet in elevation horizontally. So they get up to 10 foot high, like 2 foot, a couple feet above my head, and they fly horizontally. And they can't raise up at all. They can only go horizontal or down. That's all they get to do. They can go down around a curve and raise an elevation if they want going down, but never anything other. They can't go up. They can't veer up. If you veer up, you lose. So what you have to do is just increase in elevation. It has to go from 10 feet to automatically some magic, 15, 20, 45, 70, because that's what a globe would represent live to you on the altimeter. But what I want to do is send my balloon up. The balloon will hit 35,000 feet way before any object that man made going horizontally at 10 foot. But I'm just going to give them like either probably 1,000 feet just to make it slightly fair. So once any airplane, rocket, anything can reach 1,000 foot horizontally and beat my flat earth balloons that are going vertical, then, well, we've got a globe on our hands. Because surely, 35,000 feet with a slow balloon, surely an airplane and a crop duster and all that stuff just flying 1,000 feet forward should beat it, I got the drawing, got the math. It's all right there. Check it over.
You mean the airplane is supposed to go 1,000 feet straight forward?
Horizontal, yeah, and raise an elevation. That's all it's got to do is say 1,000 feet in elevation. No, it's
Okay,
going to
so
be only
yeah,
10 foot above me. It's
no,
only going to be 10 foot in the air.
Yeah,
It's going to fly
1,000 feet
forward.
straight
Yeah.
forward is only going to go altitude of a couple inches higher.
Well, then welcome to flat Earth. It's so awesome, isn't it?
Why do you assume the plane should be faster than the balloon?
Why do you watch a rocket drop but the elevation increase? Can you show me any other airplane do that or any object drop and show me an altimeter increase? Just an imaginary rocket?
If you look down a road and there's light poles along the road, as
not what I
you
said.
look farther and farther, light poles look like they're dropping, but they're the same.
No, I didn't look anywhere. We're not looking. I said on an altimeter that you have a camera based on and set on. You don't have to guess. Stop guessing, guys. Stop saying you got to look at things from far away. We set a camera right on the altimeter. The numbers we're looking at, all we want to do is see them go from 10 feet to jump. You're telling me they're not going to jump at all on a ball after you just told me they're going to exponentially jump. Now, which one is it?
If you start out at an elevation of 10 feet and go horizontal and set a direction horizontal and then keep going in a straight line, it'll eventually get higher and higher.
Yeah. So then when I bet, if I make a bet to like the betting society, that the Earth's flat, and I'm going to bet my balloon, and this experiment's going to prove it. The math, calculations, it's all there. So I only need to go forward 1,000 feet to begin with. to get to 1,000 foot in elevation from the ball. Do you see my drawing?
Forward 1,000 feet is only goes up about 4 inches or something.
No, you're wrong. My math is back there. Do you see the math I have? Are you okay? I don't think you ever disproved my 360 degree 2D globe math.
Yo, as the head of the betting society, I'd like to know the odds on this bet.
Yeah, I would too, because I'm in on it all the way. The odds should be 1,000,000 to 1 in my favor. I should bet $10,000 and get 1,000,000 to 1.
Yeah, we're not going to take that bet.
Well, I'll take 500 to 1. I don't care. Anything's better than nothing, right?
Try that good bet organization down the road.
Try what?
Sorry, the betting society is not interested.
No, they'll turn your money back. They won't take your bet if you say I want to bet the Earth's flat, because they know you'll shut the whole. You'll own the company.
No, we won't take your bet if you want 1,000,000 to 1 odds.
What do you think the odds should be for 5,000 years of everybody proving it's a globe against one guy who's just got a pocket full of money?
It's a good question.
You don't think they want free money all day, every day from goofies like me? What are you talking about?
I'll get my
It
odds
should
guys
be free
on.
money for them. Yeah, there's no way it's flat. So how would they ever lose? Why wouldn't a betting company take a for sure win?
Well, is it a win? Because you're not going to be able to pay up.
No, you're not going to be able to pay up.
No. You said it's a sure win for the betting company.
Well,
What do they
when you
win?
bet the
They don't win
company,
anything from you.
Negator, they hold your money ahead of time.
Do you
I don't know
have
what
$1
you're
million
talking
to
about.
give
Do you
them
know
to hold
how
on to?
betting works? Do you know how betting works? I give you my money, you hold it in your pocket. We go do the thing, and when I win,
Yeah.
you guaranteed pay me my money, son.
Dimmock, do you have $1 million to bet?
No, the 1,000,000 to
Okay.
1 odds. I don't
That's
think
all.
you know what are you talking about? For what?
How
You're
much
not
money
making
are you
any
putting
sense
up?
here. I said the globe is 1,000,000 to 1 odds to pay me whatever I bet. Now, can you hear right? What are you talking about?
I hear you now, Dimmock.
No, now you do, or you make stuff
I'm
up.
sure, I'm certain that you collection of
So what would my
ne'er-do-wells
odds
and
be?
drug addicts will prove
Yeah,
this flat.
Negator has no affiliation
What would
with
my
the betting
odds be,
society.
Negator?
I don't.
When I win, what do I get paid if I bet $1? What would I get?
Are you gonna win?
When I win, what would I get?
Yes,
You don't know about
I
questions and math,
understand
do you?
that 1,000,000 times 1 is 1,000,000. I understand it, Mike.
So I'm saying to you, what do you think it's worth in your opinion of odds to pay me?
To what end, Mike?
Can you hear
Earth's
the
a globe.
question? Are you
Earth's
okay?
a globe. It
Conversation,
always has
right?
been. And there's no
You
reason to
talking
make
over me,
bets on
man.
this.
Listen, conversation's hard for you. You can't even keep one sentence in order, buddy. Listen, how much do you think it would be worth for a human to go bet the company that Earth is flat? What would they get for their odds in your mind?
What would they get for their odds?
I know. Keep up with me, buddy.
No, I'm asking who's going to pay them.
Don't care about your hypothetical answer of an answer I need.
But it's a hypothetical question to start with.
Right. So why is it so hard for you to answer your opinion? Your opinion ain't worth nothing, or what?
I don't know what that means, but
Well, your opinion's too hard for me to get it out of you. Can I have your opinion, please?
I think you need to get your attention from
Yo,
somebody else.
Dimmock, are you asking for the odds or for the winnings?
Yeah. What would the smartest, best glober pay me in odds if I proved the Earth was flat and not round in 10 seconds?
So what
10 million, 10 million to 1 ounce.
10 million to 1
Zillion.
now.
All the money in the world.
I think 10
So
million
now
to 1 is-
cartoon amounts, right? Are
Yeah,
you guys
10
ready
million
to?
to 1.
Who's putting all their money in the bucket for me? You
I got
guys putting all
three
your
ounces of
bazillion?
gold. 3 ounces of gold. So
Go
whatever.
put it. Go.
10 million.
Yeah, sure.
Are you going to send it to the flat earther of my choice to hold?
Sure, yeah.
So you're going to send the money, and we're going to go do this.
Sure.
How about we
Okay,
let you
you
live?
understand the rules, right? So a rocket or any plane or any object has to go horizontally from my feet forward only. It can't steer up. It has to just go forward, straight, beeline, and raise to 1,000 foot in elevation before my balloon hits, I don't know, 20,000 feet.
Wait, why is that erased?
Vertically.
Why does it have to be there before?
Don't worry about why. This is my stuff. Are you ready? I know
Don't
you
ask
guys are ready to
questions.
bet.
It doesn't have to make sense. Why ask questions, Matthew?
Listen, just because your incredulity doesn't help me, buddy, because you don't know about making sense. You don't. It doesn't make sense to you. Don't have. It's not my problem. You didn't
I've
think it
already
up.
shown
I
this.
did.
This to you
So
in
just
the
because you
in the
can't
guide.
handle the comprehension skill doesn't hurt me at all, pal. Figure stuff out for
I showed
yourself.
this. I showed this to you in that game, Space Flight Simulator, where I made that rocket go
Nah, we're not
horizontally.
doing games. We're doing 20,000 foot with a balloon. I know you're scared, guys. Vertically. I'm going to release it. I'll let the rocket go first, or your airplane. It can go first, too. We'll even give them a head start. You ready? You guys ready or not? Or you just got a
Yeah,
bunch of
let's do it.
excuses?
Let's do it right now. I got my balloon ready to go. You got yours?
You got your airplane ready?
Yeah. I'm on an airfield as we speak.
Equals 13. You are?
Yep.
Well, shit, in the debate. You'll win right now. Just put the camera on your thing and have somebody film you from the ground. Put like a little thing that represents 10 foot. Line your plane up with that thing right there, and they have to put a couple of them out. And then when you reach 1,000 feet, let me know before your plane dies. If your plane dies before you reach it, I definitely win the money, right?
All right, we're on the way. We'll see what happens.
Okay. You only got to go 1,000 feet, right? Horizontally.
Mm-hmm.
So as soon as you fly to 1,000 foot point and you're still 10 foot above the ground or water, I definitely need all the money you got, right?
Wait, so a rocket's going horizontal from your feet. It'd have to go 38.7 miles before it would be 1,000 feet.
No, your math is wrong. I put the drawing in there for you. 360, 3959 from the radius out, 24,901 around the circumference. Do you know math? That's a
No, I'm talking about-
360
talking
degree
about the
sphere I
speed.
got right there. It's a 90-degree angle. Don't tell me you don't understand math. It is 35,000 feet to the clouds from the surface of that ball. Where am I wrong? Where's my math wrong?
8 inches per mile squared.
Where's my math wrong in my picture, buddy? No, stop talking about magic. My picture, I have the math for you. I don't know what you're talking about, dude. My diagram is right there. Do you understand math? It's right there.
It's right there in
So
the
what kind of
picture.
math you doing? Where you doing math at? Not with my picture, right?
They rated it in demo.
My picture's right there. It's got the vertical. It's got the horizontal. It shows you from the surface of the turd dirt earth. 35,000 feet horizontal and vertical are the same thing. Starting right there, right at the beginning. You just go 1,000 feet. Are we ready to do our betting? The math, the picture's right there. I know you're not arguing with your globe math.
Right
Are
where?
you? In the chat. Don't tell me you can't read chat. My name, buddy. Oh my God. So you guys figure out orbits, angles, and stuff, but you can't look in the chat. Okay. Everything's just beyond you, but everything's beyond everyone else. It's just weird how this works.
I scrolled up pretty far, but how far do I need to scroll up to see this diagram of yours?
Yeah, I don't
Well, if I could put my picture in there, I'd put another one in there, and it would just sum it all up for you.
Oh, so you're talking about a diagram that's on a piece of paper in front of you, but we can't see?
Yeah. The same 2D globe you got. 2D math, 360, 24,901.
There you go,
From the center out, 3959. It's the same math.
There you go, fellas.
Oh, there it is. Thanks.
Yeah, that's not the right one, though. I gave him that a long time ago. I sent him one other one, but it didn't go through. I'm trying to get you guys that one. That's the main one, but it's basically the same thing.
Fair enough.
Do you see the right side of the ball? On the right side, where the L is the same distance, top to bottom, leaving the surface?
Absolutely.
Okay, that's what I'm talking about. Now let's go bet. All you got to do is go 1,000 feet and reach elevation height, boys. Let's do this. My balloon's definitely already won. I mean,
From here, I'm winning.
From what?
I
haven't
told you I was
seen
on
any
an
of you
airfield. I
guys.
launched my plane already, so
Yeah, well, from 10. Well, when did it rise? When the Earth gravity pulled it down? Is that when
Yeah,
it rose in
I think the
elevation?
Gator won. Are
Oh, he
you
did?
willing to pay up?
What did he win?
He won all your money, it looks like.
Yeah,
I don't think he's got. I don't think he
I only
has
bet-
anything next to him. I think he's imagining stuff like globes. Listen, when the airplane gets pulled down to the ground and crashes in the ground when it runs out of fuel and gravity takes hold, and you haven't hit 1,000 foot elevation yet, horizontally.
It happens in the opposite order.
So when So what's going on now?
Nothing.
So vertical, my balloon is going to go vertical up from the plumb bob that's hanging, and yours is going to go horizontal from the T, from the top of the plumb bob. We're going to put a line on that top of the line for the plumb. It's going to make a capital T. You guys' airplane's going to fly straight horizontal. Mine's going to go vertical. Isn't that going to be sweet? Show me on my drawing again where, put some cubes on there, Coach, on my drawing where they wouldn't deviate right next to each other. I mean,
depends on the size of the cube and the amount
yeah,
of
I know
deviation
you
you're
keep
capable of
saying it
measuring.
depends. I'm asking you to show us physically and stop saying imaginary depend words. It depends on the depend and the amount of poop for the depend. We know. But can you physically draw some squares and demonstrate your depend?
Tell me that you're not wearing depends right now.
Tell me that you're not touching a sphere right now.
I'm gonna make fun of my girlfriend, but when I first met her, it was fun. We were just talking about. I was asking her about what kind of underwear she wears, and she said depends. Like, I thought that was funny. She didn't mean to say that though. But anyway, let's get back
There's the math. There's the geometry. I mean, have fun, boys. Fight over it. It's your globe math. And I want you to draw or show me on the biggest cue ball you can get in real life, any glober, please, and put some squares on there and show me where they meet up. Any of them. Just two. Just make two meet up.
Just out of curiosity, do you talk to people in real life about globe and flat Earth?
Do you ever touch globes and squares and like ever touch physical attributes of anything?
Democ, you gotta
Come
have a real
on,
conversation, man. You gotta have
Yeah,
a real
I know.
conversation.
I'm asking him the same question. And in real life, do you ever play with globes or squares? Do you know what they are?
It doesn't like no one gets points for being witty
Well, no
here.
one gets points
I'm
for you
just
asking me weird
genuinely.
questions either, weirdo.
I'm
Stop
genuinely
asking me weird
curious.
questions that don't have to do with the ball or a square.
Well,
I'm
no,
here
no,
for
no.
a.
Okay.
Stop running from the math. Just go show me where a fucking square does what you guys keep claiming. Or stop claiming it. Please stop lying. You guys are the worst liars I've ever heard in my life. You would never play poker good. Ever. Just one little demonstration that helped your whole situation out, guys. Don't do that, though. No, that's not okay. It's okay that you can't. Welcome to Flat Earth, okay? Well, you heard it here first. No Glober actually wants to do shit. They just want to sit there and talk and write numbers on papers and imagine stuff. They don't want to go fly 1,000 foot away from their house and show us the increase of elevation. As soon as they get 1,000 foot from their house, there should be 1,000 foot increase in elevation. So simple. Do the math. It's right there, guys. I drew it out for you. I mean, come on, man.
I mean, like
the math.
When you go to like Home Depot, do you spend 20 minutes sort of blathering on about flat Earth to people like this?
When you ignore the math in my picture and blabber about nothing that has anything to do with nothing, does that help you present your non-mathematical sphere that you can't back?
Or like when relatives come over, do they just ignore you when you do this? Or
does your math teacher ignore you when you make up shapes that don't exist in real life? I don't know. You tell me.
It's just a strange way to carry a conversation.
Strange way. Who are you talking to? I never remember carrying a conversation with you.
No, I
You talk
get
to
it for a second,
yourself.
but
You
I
make
think
shit
that's
up. You don't answer any
core of the
questions.
issue with his
You
inability
haven't
to like hold a
demonstrated anything.
conversation.
You have never demonstrated. You talk over people the whole fucking time. Then you're gonna say I talked over you, of course, right?
No, you guys are talking over each other. So let's dial it back a second, okay?
I'm just saying, have you ever did any math, any real math on a real sphere, or just cartoon angles? I mean, in real life, do you go tell people about angles and cartoon stuff and moon distances and degrees that don't exist anywhere? In 93 million miles, you can't show what it looks like. So you got invisible 93 million miles. You can't show poor little Demont. And that's weird. You do that in life to everybody? I bet you do. Don't worry about what I do in my life, pal. If I felt like telling you that, don't you think you'd already know? I talked to you way back on Poncho Pete's probably about 12, 13 years ago, buddy. If I wanted you to know anything about my personal life, you'd probably be DM'd from here to Sunday. And you've been not showing anything ever since for 13 years. It must get old never holding the ball in your hand for 13 years and never putting a square to it so you can demonstrate where we're wrong. Not just say, oh, because I believe. I believe you're wrong, Namak. Well, I like you believe stuff. You guys got really great beliefs. Demonstrate them for once in your life. In reality here. Like SE said, in reality, man. And every little kid can go fly any object they want tomorrow. Any fifth grader to any adult in the world can go take a altimeter and throw it. If it doesn't increase when you throw it forward, you're not on a globe. If it doesn't increase when you drop it, you're not on a globe. If the altimeter only increases vertically from your feet going up past your face to your head, you are on flat earth, baby. Don't let anyone ever lie to you. And it only takes 50 cents to falsify a globe. If you can't falsify the globe, it doesn't exist anyway. It falsifies itself. That's how science works.
Demok,
Thank you.
the betting society has agreed to take on your bet at your 1,000,000 to 1 odds on the condition that we can examine your balloon before we run the race.
Yes, you can examine my helium balloon.
All right.
Yeah, I'm waiting to go over the math. I'm waiting for him to argue how I'm wrong. When the math's right in front of them, there's really nothing to argue, is there? Sorry.
What you eating there?
Cane's chicken. Raising Cane's. It's okay. They don't really season their chicken, but it's okay. Sorry for eating. I guess the sauce is the big crave there. So how you been? Who is that? Percentage?
Yeah, what's up?
How the hell
Good,
you
man.
been?
How you been? So, did you say where have you been?
No, I said how the hell you been?
I've been good, yeah.
Nice to
How
hear
about
from
you?
you. I
How
didn't
you
hear from you
keeping?
in a while. And you other guys too. You two, Negator, and everybody. Nice to hear from you guys. Geo, everybody. I'll shut up for a minute now. You guys do your thing. Sorry. And look, flat earthers, if you guys think I'm stupid, I mean, the drawing's right there. If I'm not making any sense, there's no 3959 needed to ever leave this planet horizontally. Just every single millimeter from in front of you. I promise you guys, please don't believe their math. Any kid can do the math of a circle.
Demok, you're a gem, man. You're one of a kind.
I know, isn't it? You see that? You see that percentage? Isn't that sweet? The math, baby. They can't argue with their own proof, right?
Numbers don't lie.
That's right, baby. Numbers don't lie. You know what they told me? The others Globers told me? They told me my horizontal and my vertical are diagonals, really. They said, that's diagonal. That's not vertical and horizontal. I said, what? That's an L. Like, what? Then they were telling me, that, oh, man, you should have heard the magic. It was so funny, but it's all right.
They're talking about the tangent, the horizontal.
They told me that when I drew an L, a 90, an L, like a capital L off the side of a sphere, the right side edge. They told me that was a diagonal line. Both those lines. Does that make any sense? One of the lines was clearly vertical, and the other line was clearly horizontal, the bottom of the L. The top's vertical, the bottom's horizontal. Right?
Yeah, that doesn't make sense.
Right. A diagonal would be a 45-degree right between that, splitting it right in half, correct?
Yeah, but like
exactly,
if you
baby.
if you like made a point, the point is right on the sphere, and
Exactly.
it's equal, then it would be diagonal. But if it's
That's
one
where we
straight
stand.
up, yeah.
That's our point. That's where our feet are.
But that's relatively simple, so I imagine they just misunderstood you. Unless there was like a drawing with it.
Well, I mean, they made me do math. I told them I didn't want to, but then when they make you. Like, no math's proof. And I was like, man, I've seen McToon so many times. I was like, okay, man, if the only thing he listens to is math, I'm going to have to prove him wrong with his own 360. And there you go. There you have it. So now let me guess he's going to have all kinds of excuses for, yeah, my math's not math. That 360 is somehow different than their 360, which would be the weirdest thing in the world to ever say. One guy told me, he said, that's only 2D. I said, well, I know. Your globe is 2D math on paper. There it is. I mean, that's it. That's the globe on paper. It could be no different. I mean, mark where a globe would be different on that paper to a 360, a 360-degree sphere. It would never. And then when they talk about getting down to the microscopic nitty gritty and 0.001 of a degree and all this stuff, where in their equation for 360 of a smooth level sphere do mountains and dips and valleys and mud puddles, cliffs, waterfalls, where do they come into the equation? Can I see the waterfall equation of Earth in the 360, 3959? You ever seen that percentage?
No, I never even heard of it.
The mountaintop, waterfall, cliff, mud puddle equation. The Mr. Potato Head equation, we'll call it. The Glovers claim perfect geometry, but they have Mr. Potato Head geometry. Isn't that weird?
It's not weird if you're Mr. Potato Head.
What'd you say?
I said it's not weird if you're Mr. Potato Head.
You're right. No, but I think it's funny. Coach Joe said none of them would light up, bro. Who in the right? How could you be in the right state of mind if you think that a plump like? I just don't. I don't know. That kind of gives me a headache even thinking that that's not like that's weird. that if you literally had a camera inside the plumb on it, set on it, hooked to your phone, showing on YouTube Live, 50 plumb bobs, right 10 foot apart, or cubes, whatever you want, for one of them to not deviate after miles, 8 inches per mile squared drop, squared exponent, but none of them are going, they're all going to be perfectly horizontal. That doesn't make any sense. How can that make sense? Where is a cue ball perfectly horizontal to where you as a little dude will be able to do that on a cue ball? They can't demonstrate this. They can make the cue ball big too. You ever seen somebody put a ruler sideways on a ball, on a cue ball or a bowling ball? It's like the smallest focal point you could imagine. It's not a line. It's like the smallest focal point, touching. And no matter how big you make that ball, that line is still going to be the same line. It's still only going to touch that little focal point. That's it.
Yeah,
I
it's
mean,
called a tangent point.
right. Fulcrum, a focal point, the teeter-totter point of love. I mean, you know, the globe is a scale of justice, baby. Well, I mean, where do you put things anywhere that you see a teeter-totter other than a hill? You know, you don't put boards on water and they start teeter-tottering anywhere. That doesn't even make no sense. And if you think they're following the curve of the earth, turn it the other way, son. Now you got a happy face. Is it teetering, tottering? No. No ball. Turn. You know how they say turn that frown upside down?
Yep.
They're talking about globers. They were like, turn that curve upside down. I mean, do they even understand that an altimeter is actually supposed to like prove their globe like the easiest way possible ever? Like shoot it out of a gun, send it that way, shoot anything, like shoot something that at a certain pressure or altitude, you know it turns this color or reacts this way, and you shoot the thing, and it goes fast out of the barrel of the gun. The bullet is supposed to leave the earth. When can we shoot a gun anywhere on earth and have some lines on the wall and literally see this bullet deviate from the path of trajectory to the target and see it leave that line? Can we watch that in slow motion? That should prove the globe right there, right? That the earth leaves the bullet and comes back. Correct? Everybody forget about that in school? When they said, hey, when you shoot a gun, little Demont, the earth leaves out from underneath it and comes back and meets the bullet towards the target. Did you guys know that? So all you got to do is have a wall. Yeah. All you got to do is have a wall set up. Huh?
I said that sounds ludicrous.
I know, isn't it funny? Globe stuff you wouldn't understand. You know what I mean? It's above our pay grade, you know. But all I know is supposedly that's what's supposed to happen when you shoot a bullet, because it leaves the muzzle, and the velocity times mass times acceleration is supposed to be greater than the rate of mass that it's resisting. So the propulsion rate, you can see the V and the M and the square. It's all in the math, man. It's so simple. But it leaves the earth. Now, when can we measure that? If I shoot it diagonally from me down to a target, can it then jump over my buddy's head? When can we see the bullet jump over our buddy's head like refraction and everything else? Literally, I swear to God to you, this is supposed to happen. You shoot a gun, the bullet leaves out from underneath the gun and comes back. So when you shoot a gun, any car or building or object in front of you, the earth should leave, then come back. When do we? What's the deviation? What's the differential? Which bullet can we use, and how far does it deviate?
I don't get why it would leave and come back.
Hey, man, why does the Earth leave the apple and come back? I don't know, man. Do you know when Newton said the apple was in the air? The apple floated. As soon as it released itself from the resistance of the tree, it stayed floating in free space until the Earth met up with it. Did you know that?
No, he didn't say that.
Oh, he did. 100%. He said the apple is levitating and the Earth comes up to meet it.
No way.
I promise you, bro. I'm not fucking lying to you.
There's no way Newton said that.
There is a way.
So Newton's like the Flat Earth Society? He thought the Earth was going up to meet the thing?
Yes. Yes.
That's the first time I've heard
100%.
that.
Yeah, mass attracts mass. So the Earth has to go up to the apple. You understand that,
Well,
right?
okay, ever so slightly, but because
Hey.
the mass of the Earth is like infinitesimally, infinitely more than, not infinitely, but a lot more than the apple, it's hardly moving. The apple, it's attracting the apple a lot more. That's what he believed.
Einstein said that the Earth was moving up to it.
Oh, Einstein did?
Yes, Einstein.
Oh, I could have. So why do they use Newton in his apple? So why do they use the apple and Newton? Why wouldn't they just use Einstein?
I don't know.
Newton
Maybe they both postulated. Hold on, through relativity. Okay, I got it. Yeah, it's the same. When you use the word relativity, everything's the same. Never mind. I'm sorry. I'm goofy. I forgot. It's all relative. So yeah, it actually was both of them. Yeah, they both did the same problem, the same math, a different way. One's energy, one's resistance and mass. One's energy and acceleration, which equals mass, acceleration, speed. Right? They both equal 0.
I don't know about you, but Newton was way smarter than Einstein. Einstein's a retard.
Yeah. Well, I mean, I think they both were like not all right, but you know,
But at least Newton didn't try to say that these physical things like time and space had physical properties. Metaphysical things have physical properties. Newton was never that stupid.
That's good. That's really good. I like to hear that.
Well, Newton also said that if you believe in mass attracting mass, you're basically a lunatic. He didn't
Spooky
even
action
believe
at a distance.
You told me Newton's misunderstood. He's like
Spooky
the card.
misunderstood at a distance. So Newton said spooky action at a distance, right? I'm with him.
Hey, when you guys eat fruits, do you guys eat the seeds?
Depends. Strawberries, yeah. Apples, no. Bananas, yeah. What? Tomatoes,
You eat
yeah.
the seed of a banana? What do you mean?
Yeah.
Like that little thing at the pit?
Well, they're all up in through the banana. Actually, I mean, well, in the base.
Those are like some natural bananas. They don't make them like that.
Well, I just heard this thing. Yeah, I mean, don't they grow like a grass, like a stalk of grass anyway, like bananas, and that has a start?
What about watermelon? Do you eat the seeds of a watermelon?
Probably the premature ones. I don't try to eat the regular ones. No, not at all. You do on accident. Pretty sure on accident you eat the little seeds.
So do you spit them out or do you swallow them?
Spit them out.
What if you were supposed to swallow them?
Well, maybe not. You poop them out. They don't really break down like corn and everything. Like
yeah, I think that's my point. Like, if you swallow them whole, right? And you poop them out, then that acts as like the necessary
Fertilizer.
environment for it to grow, to fertilize and to grow. So I think maybe we're meant to be eating seeds, not necessarily chewing them, but swallowing them whole, so that when we poop, we grow a tree.
Well, maybe we're supposed to use our own poop for fertilizer instead of cow poop.
Yeah, we're supposed to use all poop.
Yeah. But I mean, either way, if you germinate the seed, I'm pretty sure it's just as good.
Honestly, yo, cities are scams, man. Like they have, you know, the sewage system, the water system and what have you, all of that so they could basically take your poop and your urine and then sell it back to you.
Well, yeah. Coal and
They
water.
charge you to you know, dispose of it, and then they sell it back to you. And they sell you the food that they made, that they grew using it.
Natural gas and fertilizer, yeah. Why wouldn't they?
What a scam.
What about coal being gasoline when you had water? That's a pretty good scam, too.
And same with like the compost bin and stuff like that. They charge you to have like a compost bin or like recycling bin or whatever. And they take that compost,
yeah.
and then they use it to make fertilizer and stuff like that. And then they sell it back to you again in the form of food or in the form of actual fertilizer for your lawn or whatever it is.
Yep, and the oil for the fuel in your diesel cars and stuff. Actually, by that grease that they use, yeah. I mean, you can, you know,
Like having a municipality or having a city it's a money maker.
yes, every waste is a big money maker. Waste is fuel. The offset of something makes helium. You understand that, right? So the offset of something being called the waste is the fuel. It's the potential amount. Why not?
You know, as I get older, I see the benefit of starting my own commune. I think I might pursue it. Have my own commune with multiple wives. Be like a cult leader type thing. You know, there's something called compost toilets, where basically it just captures your poop, and you can compost it later.
Good idea. I think they do that in China already, don't they? To cook their food and stuff. They have like a tube running down to a pit, like a thing on top. Probably not.
On the subject of urine, you know that in ancient Rome, they took their urine and they would use it to bleach their clothes and their teeth. They'd use it to whiten their
Bleach? You
clothes and
mean
their
yellow?
teeth.
You mean to yellow?
No, to whiten the clothes and teeth. Then when it was sat in the sun and like basically like oxidized or turned into like ammonia or whatever, they used that to stain their leathers and stuff.
Oh my God! Imagine the smell. You ever been to Chicago or New York on a busy day with like lots of bums walking down the street? That's what it would smell like back in the. They're like, oh my God, oh my God. Jim Bob, don't drink so much coffee. Damn, that's strong. You said they use urine to whiten? Oh my god, no.
Yeah, to whiten their teeth. Yeah, because like nowadays they use like hydrogen peroxide or like carboxide or whatever it is, right?
Yeah.
Very similar to ammonia. And like I think
Right.
in terms of
Like
the chemical.
Neosporin.
Yeah, the chemical form of it.
Neosporin,
They use urine and it does the trick.
They probably also used it to break down material, break down certain rocks and stuff. Like a bird.
Yeah. Man,
There's
urine
a
has so
bird.
many uses. Like, well, urine concentrated is like a weed killer. It's like a herbicide, and then in dilute, like when it's diluted, like 5 parts water, 1 part urine, it's
Plant
like a
food.
fertilizer.
Yes, sir. A bird. Some dudes were doing a study and looking at these birds, and they could have swore these birds would like go get a certain leaf and start pecking on it and leave. When they came back, just the bird pecking on that leaf, there would be a hole in the rock when they left. Now I was wondering, I was like, well, if a woodpecker pecks hard enough at a stone, while it's got a material there on the other side, a cushioner of leaves, plus the chemical of the leaf, like bang, smashing down into it, like the pressure, and then it leaves, right? So it kind of starts the reaction and then leaves. And the dude kept watching, and he came back and he said this chemical was eaten into the stone that normally was too hard for you to even dig into or carve. But these little birds would put a leaf there and go tap 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 and come back. Yeah, they figured it out. They figured out this leaf had an acid or an enzyme in it that ate through the fucking. So you could turn any material you want, from granite to whatever, with this liquid. It's the same
Do you know
thing.
what leaf it was?
Shakarua, fucking. It looked like I gotta remember. It sounds like that. That's what it sounded like. The chacarena. But it looked like a creosote plant. But they called it the chacrona, yeah, something weird. It was a while since I read it, but I was just remembering that it was pretty interesting stuff, and we were talking about it the other day too. Yeah, what's his name brought it up?
What is it?
You guys heard of the Gracie family?
Boyce Gracie, the fighter, yeah.
Yeah. There's I think it maybe Nenzo's son, maybe Hickson's son, but there's a fighter named Crone. His like nickname's Ice Cream Crone, Gracie, and he does MMA. He started off doing jiu-jitsu, now he's doing MMA. But he's a flat earther. And whenever he's like going for interviews or something like that, people still ask him, "Are you still a flat earther?" And he's like, "Yeah, I don't like to talk about it, but yeah."
That's what's up, man. Did you know that Floyd Mayweather doesn't know how to read or write?
I did not know that. No.
Well, I mean, I don't know if he learned now.
I don't think that's true.
I mean, that's. I think he admits it. He never learned how.
There's no way.
I mean, he learned how to fight when he was 2 years old, 3 years old. He's one of the richest athletes, highest paid athletes in the world. Probably the highest paid athlete.
There's no way he's illiterate.
Let's see.
And I like what you did there. We're talking about one being a flat earther, you go to illiterate. You bastard.
Floyd Mayweather, he's a Glover though.
Cora says he's not illiterate, but I've heard him say he was illiterate.
Boy, he's my favorite Glover. I mean,
So he says he's illiterate. Some guy on Quora, though, says he's not.
what did he make him read? Sign your signature, boy. No.
And he says, I would be perfect at reading if it's how I made my living.
Oh,
okay. 50 Cent, so both 50 Cent and Floyd Mayweather say that Floyd Mayweather is illiterate. But like I said, some guy on Quora says he's not. So.
Well, 50 Cent also said.
What's the argument the guy on Quora has?
He says he's not an MBA, but he's not illiterate. I don't know. I mean, anybody can. Scott Veach writes on. No offense, I'm just messing with Scott Veach. But yeah, let's find out. Let me read this, guys.
50 Cent said he could beat him up, too.
Yeah, okay.
I'm serious.
Destroy him.
50 Cent said, I'll beat Floyd Mayweather. He ain't got nothing on me. He said, when you're standing next to listen, he said, the weight class between me and him, when we're live in a room, he is not going to beat me up. He said, now in the ring, he might be able to get a lot of points on me and do good. He said, but physically, real life, I'm going to beat him up.
That's true for a lot of people, though. Yeah, and because like Mike Tyson could beat him in a fight, I think easy. That's because Mike Tyson's they're not in the same weight class. He'd probably kill him.
Oh, Mike Tyson walked up to him and flinched, and he like got scared as fuck. 50 Cent even got scared of Mike Tyson. Yeah, 50 Cent talks about it.
Even Mike Tyson got scared of Mike Tyson.
I think so. One day he looked in the mirror. He's like, "Me, you motherfucker." He said, "Who's trying to brush my teeth?"
Let me see.
He go be knocking on my door tomorrow and be like, "Oh fuck."
So a lot of people are saying he can read. Some people say he can't. He says he can't. So I don't know.
It probably depends on what though. They're probably like he can read if and like Dr. Seuss books and stuff. He's probably pretty good.
So it said, okay, here's Black Entertainment Television, BET.com. Here it goes. I'm going to take this one as the final word. After being dubbed illiterate by 50 Cent, his former friend, boxing champion Floyd Mayweather is clapping back with a challenge of his own for the Candy Shop rapper. Mayweather challenged his nagging rival to donate $750,000 to slain teen Michael Brown's family. That's not a challenge. My God. Okay. So this is the worst article to read. It doesn't say anything about if you can read or not. I kind of wish there was a fucking... What's it called? What's that website called that has like the debunks on it?
Snopes?
Yeah, Snopes. That's what I'm looking for.
You know, if you got close to Floyd Mayweather and like you're like, you know, whatever, and you like bet him some money, you can win a lot of money off that. He likes to gamble. Fuck.
Oh,
so if you're close to Floyd Mayweather and did what?
And he likes to gamble, and you gambled with him and you win, you have a chance to win a lot of money. I mean, he's got it to pay. I mean, he might want to fight you eventually, but you know, I'm just saying, you know, fuck it.
Yeah, hold on. No, dude, there's no Snopes on it. I can't believe there's not a Snopes in this one.
I'd love to be able to play Texas Hold'em with them. You know what I mean? Yeah. As long as they didn't pull no funny shit.
Did you say
or, you know,
you'd love to hold him in Texas?
No.
And just wait until he pulls some funny shit?
No. No, that's not. I think you're reading Floyd's cue cards. You're reading them wrong. You're reading them all wrong. Turn it upside down. Turn it back the other way.
Oh shit, this
Read
is
it left
Freud.
to right. Read it left to right.
There. A Freud cue
Floyd
card.
said, turn that cue card around. I'm reading it upside down. You said, no, it's the right way.
I'm done with Core, dude. Here's another. So far, Core says he can read, even though he says he can't. Or he's not illiterate, even though he says he is. And and then also Cora says that he's like the highest IQ of any boxer of all time. The fuck?
That's
To
awesome.
be
I
fair,
like
you could
that.
have a high IQ without being literate.
Yes, that's true. He's the
Yeah,
highest
yeah,
IQ
you're right
boxer.
about that. That's
Hold on. You have to take that in context. He's the highest IQ boxer. That means in the ring as a fighter, his fighting IQ is higher than every other boxer because he hasn't been defeated. You understand what they're saying, right?
Yeah, well, I mean, you guys both are kind of
Yeah,
making the same point, sort of. And that he doesn't have to be intelligent to have a high IQ. That's true.
but they're talking about boxing,
No, they're talking about fight IQ.
right? Fighting,
I
right
don't
in
know
the
if they
ring.
are, man. It says, "What is the IQ of Floyd Mayweather?" And then somebody says he's got the highest IQ of any fighter.
Okay, they're not talking
Fighter,
about
you
fight
keep
IQ. No, but they're just comparing the IQs of fighters of that category. That doesn't mean they're not talking about fight IQ in the ring.
Nah, I've never in my in the ring. I'm talking
No,
about
they're not
reading a
talking about
book
that. You can
and
tell by the
writing math.
question.
Like if you did trivia with Floyd Mayweather, you're telling me he's beating every other boxer in trivia.
No, trivia is not IQ,
man.
So it's in fighting.
No, not necessarily. It's just in general.
Yeah, it's just like your. It's like your. What's it called? The What do you call that? Your.
That's all part of fighting, guys. You got to duck. You got to.
No, definitely it could apply to fighting. Absolutely.
Right. You got to anticipate.
But IQ
gotta,
is just like how like the ability to kind of like connect the dots, or to make sense
Make
of
a
something
punch.
faster than another person or what have you.
What's the word for that again?
Pattern. Part of it is pattern recognition.
No, there's a single word.
Memory.
What's it called? When you have the ability to learn something, or you have a.
I'm not saying he's dumb.
Fucking that's gonna bother me.
Didactyl ability.
No, it's like that's like when you have
autodidactic.
When you have the potential, you have a high potential of being good at something or learning something or whatever. I forget the word.
Cognitive ability.
No, it's just one word. I can't. Goddamn, it's gonna bother me now.
Oh,
And
a savant.
you have
a savant.
Like not an aptitude. You have a no. That's not
A savant, basically. Somebody who's really good at what the fuck they're doing.
That's not helping me at all, man.
That's the word you're looking for.
No. I think it's gonna bother me.
I'm just saying, what other IQ, what other thing would he need as for his IQ based on anything else other than the ring to be the winner and never get hit? I mean, to me, that's the only thing they could be talking about. I'm not saying he's dumb. I'm not saying he doesn't know stuff. I'm just saying, like, I think that's what they're talking about mainly is in the ring, his IQ of fighting against the person and what to do next. And in that situation of fight or flight, and you get the points and you get to win and you get to knock out or the points, he's the smartest. He doesn't get hit. He does the cheap. He knows what he's doing. He's smart.
Yeah,
and
no, there's no question about that.
Right, very tactical. So that's what I think they're saying.
That's not what they're saying, but what you're saying is true. He has a high fight IQ. He knows how to fight.
Right.
But the question that they posed is who has the highest IQ from all fighters, not who has the highest fighting IQ.
Well, how'd they test it though? How did they test it?
They would have to have each of these guys do IQ tests. I don't know if they did that, so I don't hold much stock in it.
Yeah, that's what I'm saying. Now, if you're talking about people that have been knocked out or after 10 years of fighting, or if there's some stipulation to it, it's not just like a set base, like he's smarter, you know what I mean? Then there might be a lot of things that fall into it. Like, because if I got knocked out and I can't talk tomorrow, then of course his IQ is going to be better than mine.
I wonder if your IQ drops with concussions, getting knocked out.
That's what I was wondering. There might be a study to that. It might actually increase your IQ depending, like if you get hit one time versus a whole bunch of times over and over and over and over again. You know what I mean? Think about that. I think one single impact with someone could probably increase their IQ. like a shock to the system. Instead of like, you know what I mean? Get that spark and just create, I don't know. And then if somebody abuses that, or get your head rattled or shaken too much, of course that's going to damage it. Beyond. You know about the slap your computer thing, right, Coach?
Yeah, I do. Give me 30 seconds.
Yeah, that's all it's based on. Sometimes your computer be glitching and fix it. You just gotta give it a little smack, brings it back. So maybe one smack can be good for people sometimes, but too many. Yeah.
One smack is definitely good for some people when they acting up.
100%. So lightning in the palm, the shock value. No, I'm just thinking in my mind, like, how to make Jesse Gordon's reading like a double slit, how it's going to do two things at once. So if I say, hey, you got an auto level plumb, whatever, yeah, like whatever, right? Shows you plumb, right? And you're saying it's off. Well, if you had one that if it was one hair off of zero to the left or right, any deviation would make it light up. Now, Jesse says when he backs up from it, it automatically lights up like magic with a theodolite looking at it. But in reality, physically for it to do that or to deviate, not just looking optically, the actual material would touch physically, show you it lit up to deviate. But Kosho said it would never do that. But Jesse's telling you his deviated. So, like, what's going on? I don't get it here. So we either got a guy looking across the lake or looking across some stuff and sighting through a theodolite, and he sees an angle of tilt or a degree of off plumb, right? But then Kosho tells me if I start putting a plumb bob every foot for 1,000,000 miles, they're all not going to light up on a globe when the globe's only 24,901 miles. How would this even make sense at all? So if you put the light up plums that had a camera on their reader and lit up to even show you from a distance, hey, did that light up? So when walking away doesn't make it light up. The actual thing not being plumb lights up. So you put them on water, like the floating plum. So you get like a container, like those little quarter containers you get from the thing to get like to put little candy in them back in the day, and a little like the little clear thing. You get like a clear container, and you put the string hanging from the center in there, and you have it plumb, and you have some little sensors, a little sensor all around it. And if that little thing swings and touches any one of those sensors, the floaty ball lights up. And you do it on water that's settled. You don't do it in wind. You can either do it in a building or you can do it in a canal or something. Not on a super windy day. It's like it's your best whatever day. Line them all the way down it. You can put one every 10 foot, one every 5 foot, for a mile, for 2 miles, whatever you feel like doing. They glow when they're off plumb. You don't have to do any goofy guessing. You don't have to make up verticals and drops and make up stories. You say, hey, this water's tilting right here because this one's off level in the water floating as a plumb. It's off plumb. Why is this too hard for Globers to comprehend?
Well, I didn't.
Clearly, if you see a plumb be off plumb through a theodolite, when I set the same plumb next to yours, it should be off the same, right? Or no? Mine should light up, right? Or does it only light up when Jesse Gordon gets across the water and looks at it through a theodolite? Is that when it'll light up? Well, let me go set my other theodolite up. This thing's plumb right here. I'm going to go set this one up and look through it. Oh, now it's not plumb. Well, is it lit up? No. Looks like we got some kind of stories going on here. Somebody's very unconvincing. Sorry to ruin your guys' angles, Blue Marble. And your hopes and dreams of 0.0001 or 003 degrees. 0.03 degrees per mile with tilt. Yeah, right. And what's a degree of tilt on the theod or on the plumb when a degree of tilt on Earth is supposed to be 69 miles? What? I mean, what? I don't even know, man. Anyway, if the auto plumb lights up, it's deviated. If it lights up, you're on a globe. That's got to be simple, right, guys? I mean, how hard do you want to make it for yourself? You want to make it cost $1 million? You want to make it be not for little kids to do? Here, little kid, you can't grab this little plumb bob or this square that's got a plumb in it where this little ball touches any side anywhere at any time. It's going to show you this isn't plumb. Here, builders, don't use this. Get down the way. Look through the mirage of life. That'll help you. That's really how you can judge measurement. Don't put a camera on the reader. Don't have a digital reading or a manual reader right there where the needle shows you. Thing lights up. Check your phone. Look, my camera's facing right on there. Let me see what that is, Jesse. Jesse, that says 0 on it, not 0 point anything. See, because you know how we know? Look, it's not lit up. And look at the camera. It says 0. Oh, man. Kosho, how could 24,000 miles worth of plums all be plum? That doesn't make any sense. So what the Globers tell me, Kosho said all the plums will be plum tomorrow. That means that's a flat earth. Can't have anything but one plum on a globe. You only have one.
Yo, if you took a peach and you put it at the bottom of the string, like a plumb bob. Right?
Yes.
And then it stops moving. Is it a peach or a plum?
It's both. You tricky. You're very tricky. It's a peach plum. A plum peach. It's plum crazy. I don't know, but what do you think?
Upside down, right? And things swinging, and then it stops swinging. What do you call that?
A helium balloon, Demox helium plum. An inverted plumb bob is a helium balloon. That's what I call it. You can even tie a helium balloon up, yeah. It'll do the same thing as it'll show the 1 degree tilt too, or the 0 point whatever. Everything will, if it's there. Yeah, I call it a helium balloon.
Okay.
Well, I mean, a helium balloon is an inverted plum, right? You hold onto the string, and if it was facing to the center of gravity and you had 1 million of them around a ball, they would do the same thing as the toothpicks, right? Correct?
No, I'm saying you hang a plumber upside down.
A plumber, I'm sorry. I thought you said a plumb bob. I'm so crazy.
No, you hang a plumber by his feet upside down. When he stops swinging, what do you call it?
Plumber's crack. I don't want to hang no plumbers upside down. That's called globe plumbing. 101. Upside down plumbers. Man, that's the funniest shit. If I tried to draw plumbing on a globe, how it would work from city to city to town. Like, how would hey, Bob, I'm going to poop in my outhouse towards your outhouse. Like, what the hell? Hold on. You're going to be pooping towards my outhouse. You poop towards your own. That'd just be just the flow.
It's all relative.
Yeah, relative to imagination. Exactly. It's all relative to your imagination. Draw it out for me, little plumbers. The world's best plumber. Draw plumbing on a globe. I wonder if Blue Marble knows how plumbing works on a globe. Or any of the other globers. Not to be funny or anything, but I just wonder if they know how their own model actually pulls down water through a P-trap and puts it up at the same time. How does it climb down and go up the P-trap at the same time? It's got to be crazy. No, but what do you think about the Jesse Gordon thing? Now, Jesse Gordon gets back and cites us the ad light and says he sees one off plum.
I have no clue what you're talking about.
The Jesse guy that looks through the theodolites and comes here. I don't know how long it's been since you've been in
I
there.
know Jesse, yeah.
Okay. He says, I look through my theodolite to the other one, and he says he does his dips and all that, and he measures off plum by 0.01 or 3 degrees per mile, right?
Yeah, he's saying that the plumb lines aren't matching up.
Right. Now, if I have a plum and I have a camera on it reading the digital reader and the manual, you can have a little needle. It'll make it, and you have a pressure on each side to where if this plum moves any deviation from 0, perfect 0, the fucking thing lights up. It lights a light on top.
Okay.
So now, Jesse, he puts his auto level and his plumb right there. Then he goes across the water. Now, do you think because he looks through his theodolite that one's going to light up all of a sudden now? When it's not lighting up?
No, I think locally they're both plumb, but he's saying between them, when you look through the theodolite, when you measure the angle between them, there's a mismatch.
You're not, okay, clearly from him to the other one can't be plumb if in the middle ain't plumb.
No, they're both. He's saying they're both plumb because he's saying that, on a globe you have different plumbs. They're all plumb, but they're different from each other.
Yeah, the glowing plumb would show you different. Anytime a plumb is different from another plumb, it would glow. The thing would glow. So you don't have to take Jesse Gordon.
Is that how it works, or is it just that it glows if it becomes off plumb, like locally in and of itself?
Yeah, off plumb. Anything off plumb, right? So
Yeah,
what that tells
you can't
is
compare. You can't compare different stations, though.
You're not listening.
Go ahead.
You put them on water. And if one doesn't deviate or glow after a mile, then there is no glow. Then if you go 2 miles and they're all still, they don't light up. Then 3, then 10. You could take the ones that are behind you that you know didn't light up. Now put those back in front and keep going.
Yeah, there's no issue
None of them will ever light up. Do you understand?
I understand what you're saying, but that doesn't prove anything.
Yeah, that proves flat water.
No. Well, yeah, sure. It proves stationary water, right?
No,
but
horizontal water.
The issue, no, not necessarily, because the issue isn't that that there is no deviation within. Like for any one of these plumbs, it's not going to move, and it's not going to glow. There's going to be no deviation within that.
Right.
Like
Welcome to Flat Earth.
for that area, right? But he's saying
all
that
area for the whole 24,000 miles, buddy. I don't think you get what I'm saying.
It's like a meta thing.
You're trying to tell me the same thing as Kosho around a full ball, which makes no damn sense. You'll never be able to put more than one toothpick if you put a zillion of them on a ball. Whatever kind of magic you're trying to say right now that doesn't have any bearings on reality, doesn't make any damn sense to me at all. Only one of those toothpicks can you line up with a ruler, put it on top, and it's only going to touch that one. Therefore, that's the only one that's plumb. All the other sticks on your ball showing you in your reality how a real ball works, every toothpick away from that one will never touch that ruler. Therefore, they all would light up in reality if they were the plumb. They would all light up except one. Only one wouldn't. You understand how a sphere works or not, bro?
Hold up, Dima.
Whoa,
So let's take your
whoa,
toothpicks. So let's say you have a bunch of toothpicks sticking out of an orange. All right?
Toothpick plumb.
Yeah, these toothpicks are all plumb. They're all coming out of an orange. They're perfectly in line with the center, right? And they're sticking out of the orange at the same exact amount, and they're all perfectly straight, perfectly plumb, right? And on each one of them in the center, you have a line.
No, that's not right. They're not straight. They're around a curve. To the center of a curve is not plumb. That's where you're wrong. That makes no sense. Stop saying that, please. A horizontal line, you show me a million little plumb bobs on a horizontal ruler, and then show me a sphere and show me where they match. They don't match ever. They never match. Stop saying they match. You guys have something wrong with like your idea of spheres and straight lines. No, I'm not holding up. They don't match.
Of the ball
No,
is plumb.
no. Nobody's in the center of a ball.
On their model, the plumb is going to the center of Earth.
No, they don't have a model. They never produced anything. What model? Okay. Imaginarily, if we dug to China and stopped halfway, then we'd be on their imaginary model. And from that point, we could dig outward and do everything you're saying, and we'd get their readings imaginarily. Cool. In Dr. Seussville, I'm with you on Dr. Seuss ball in cartoon land. That doesn't exist in reality. In reality, a sphere only has one plumb percentage. One.
I don't understand what you mean by a sphere.
Go get a sphere and show me anything different than that, please. Go get a ball and put a whole bunch of little plumb bobs around it, your peach, your ball, your globe. In real life, sit it on a little stick, put a whole bunch of little plums around it, and they all light up when they're not plumb, and you'll see what I'm talking about. A real ball, reality. Versus a horizontal plane with a whole bunch of plums on it. All your plums are going to light up except one on your ball. Every one of them are going to be lit up except one. I don't know what you don't comprehend about this. And if you put them all on a horizontal plane, none of them are going to light up because they're all going to be plumb. Unplumb means glow. No matter whether they're facing to the center of a fucking imaginary ball or not, they're still unplumb with the first plumb bob. You understand that, right? I don't care if it pulls to the center of the globe. That means it's going to be off plumb on the stick. It's not going to be plumb. It's going to be pulling toward a fucking center or something. That means diagonal, bro. That's not vertical or horizontal in my book. Now, if you think diagonal means vertical, then something's wrong here. Really?
Your book doesn't match their book. That's the issue.
Do what? Diagonal
Your book doesn't match their book, but you're trying to address their book.
What's off plumb to you?
Off plumb is anything depending on what we're talking about. If we're talking about their paradigm, reality is different than what they're trying to argue, right?
No, reality is all we got. So in reality, right now, when we put plums, what are we going to see? They're all plumb. Now, when we can match their imaginary ball with one of them not being plumb, that's all we need is just one. Isn't that kind of hard? We can't even find that one, but everybody keeps arguing like stuff that makes no sense. Listen, percentage. If I put the plums around a ball and put magnets on all of them, and then put a sensor on the left and right of each one of these plums to say, if this thing moves from the center of where this point, I got it holding in free space, it's plumb. Now I'm connecting it to the ball. It's going to light up. You understand that, right?
Light up, bro. No, it's
Yeah.
not.
Show me. Go get a ball.
Your thing with this glowing. Hold up. Your thing with these glowing plumb lines or whatever, that whenever they deviate, the light up, or that's not going to happen on a globe or a flat Earth. It's an inconclusive. It's a useless test.
I've never seen you touch a ball and do it. So what are you making up right now exactly?
My point is, these plums,
You don't
whether
have a
it's a
point.
ball or not, they're not going to move. It doesn't prove anything.
No, you got a ruler that proves you wrong also. Go get a ruler and touch it to the same ball. You don't even need light up ones. Put all the toothpicks the same distance off a solid ball. You can even get darts. You can stick them and lick your tongue on there, right? They're all the same. Now stick the ruler on the one and make sure the other ones match that you think are like in reality.
Yeah, no, that would prove it. That one would prove it. But the issue is, it's not realistic to have a giant ruler to do it with the Earth or whatever. It's, you can't
A giant ruler. All you need is a T.
What?
The letter T is already that. The shape, the letter T, we put two plumb bobs hanging off left and right.
A huge giant letter T to lay on the Earth or
You
something.
Why do you guys keep thinking you need big stuff to show you 8 inches of drop somewhere? You're telling me you're telling me it's an imaginary drop forever and ever till Toto comes home, till the never-ending story never ends. What do you guys aren't making any sense to me, man. If I have a box of cereal, if it drops 8 inches, the box of cereal will move 8 inches away from the next box. Do you understand this? I cannot put them on the table
You'd
and
have
have
to
them
have
look
a
the
really
same
long
again.
box of cereal to do that.
No,
to actually...
I don't. An 8-inch box of cereal dropping 8 inches is just fine for me. I don't know what you're imagining, dude.
Okay.
No, it's not okay. Go get a box, drop it down from the top of a ruler, 8 inches, and show me how that fucking sits next to the same one. Show me how that's a perfect box of cereal. Looks like it's diamond tilted to me. You don't notice that? Right in front of your face? Something's wrong. Okay? We're talking reality here, bud. If I'm in hardware store and I say this shelf's off 8 inches, I need you to lower it from this point to that point 8 inches. You're a mile away. You would drop it 8 inches. There's not going to be a guessing game. It's not going to be a funny, silly joke. So where is the drop?
How are you going to tell us off by a mile away?
Listen to me. If we go into a hardware shop and I say drop this object's corner 8 inches, how hard is that for you to do?
That's not hard. That's easy. But that's not.
Okay, let's see it match a cereal box. Why didn't you comprehend this, buddy?
Try again.
Why don't you comprehend
really
this?
not
Why?
getting you.
I know it's hard because you've been indoctrinated. Oh my
What
God,
are you
I don't
talking
get it. Dude, a box of cereal, if you move it from fucking perfect horizontal on top of your table, and you take the other one and drop it off your table 8 inches, how the fuck are you telling me they look the same? Go
They don't
show
look
me
the
that.
same. But you have to increase the scale to a mile. for it the inches
Are
to make
you
sense.
okay, dude?
You can't do it off like
Are you
8
listening
inches
right now?
difference
Listen to
over
me. Listen to
a
me.
distance of
Listen
like
to me
a
real
foot.
quick.
Go
Holy
ahead.
shit, dude. Stop making up stuff. Listen. We just went over how the box to the right would look, right? Not vertical, not the same. It would be a tilted Tony the Tiger box. His face would be pointed that way, right? So now
Okay.
you have your buddy down there zooming in on the box the whole time. You get away. Does that box or that box ever to your buddy in the side view ever look like they're tilted 8 inches or tilted like Tony the Tiger on your table and floor? No, no globe.
So you're saying that my buddy can zoom in through a mile
You
to see
don't
this
have.
tilted
Oh my
box?
fucking god! What is he zooming
No, you
into?
have to. You
Dude?
have to compare the two. So there
Yeah,
has to
you
be
have
some
to
sort of
look
link
at the
between
box
them.
and see it not level and horizontal. Do you understand?
Yeah, but in order to look at it and see it's not level, he has to come to me, right?
No.
How can he see it a mile away?
He's going to be the side view, dude. The hell are you talking about? You're not going to look
So
forward.
a mile away side view, he can compare both boxes.
How are you going to compare him looking forward, pal? But you can't do it to the side? What are you trying to tell me right now?
You could compare it looking forward because the box would be tilted, so you wouldn't see it like as a rectangle. You'd see it as like a different shape.
So a cereal box proves flat Earth.
What's that?
So the cereal box does prove flat Earth because you would see it tilted away from you, right?
Only if you could get eyes on it, but you can't reasonably get
So
eyes
you
on it. That's why I'm
can't
saying
see a
it's not
cereal
realistic.
box
It's not
from.
pragmatic.
So you can't see a cereal box from half a mile tilted 4 inches? A little
Probably
box
not.
tilted itself 4 inches, half a mile? Let's do it. Let's minus it so we can make it noticeable. Why are we trying to make it not noticeable for a flat earther percentage? If you want to
It
do the
doesn't matter. It's
percentages, you would
proportional.
make it visible for a flat earther, right? You would say, how would I make this so easy a kindergartner could do it? Not say, hey, kindergartner, I want you to get 50 miles. No, 80 miles. No, look through a theodolite, kindergartner. No. You would say, hey, kindergartner, drop this box of cereal compared to this one right here, 8 inches. And they would do it. It would be so simple. There's no stupidity involved. Getting in like, to make it complex is only the person being goofy.
The
Right?
issue
Somebody
is
who can't
there's going to
comprehend
be
maybe it's not.
sure, but there's going to be sources of error. There's going to be a margin of error when you introduce with any test that you do, right?
Margin
and when
of
you increase
error.
the scale, when you increase the scale, you move away from the baseline margin of error that you have with whatever
Scale of
thing
8
you
inches
do.
drop. That's the scale.
Yeah, that's what I'm saying. If you increase the distance, then the margin of error is going to play less of a factor, right? You're
No, we're
diluting
getting
it, kind of.
closer. We're going to use 4 inches.
Then the margin of error is going to be huge because you don't have much distance to kind of account for it.
Distance. Listen, dude. Listen to what I'm saying, dude. The box of cereal is the same as a plum. You fucking comprehend what I'm saying?
I
So when the
comprehend what
box
you're
of
saying.
cereal tilts to the side, it's going to light up for us. We don't need to make guessing games for everybody. Go on here. Can you see a light? You don't see a
What if
light?
the boxes
No
of cereal?
tilted box.
What if
Why do
the
we
box of
keep
cereal?
making it complex? Percentage. Make it easy on yourself. Make the box light up if it deviates the 8 inches, just like the cereal box me and the kindergartner showed you in the identical imaginary process of the theory of a sphere. You can agree with it for a little kindergartner to come and drop the corner and us in the hardware store to drop the corner. You can see that deviation from right in front of our face, but now all of a sudden you can't see the deviation. To me, this makes no fucking sense here.
Hold up, Demok, you're not making sense right now because before you were
No, you're
arguing,
not.
Hold up, before you were arguing the different plumb lines, right? This difference between
Yeah, the 8-inch tilt makes
now,
it light
you're talking
up.
about drop.
You
Now
don't
you're talking about
comprehend it. Same thing. It's all the same.
It's not the same
Stop
thing.
dividing 8-inch drop tilt with 8-inch drop tilt, bro. The plum is supposed to have 8-inch drop tilt. What are you talking about? It's supposed to do the same as the cereal box.
You could have something. Listen, hold up. You could have something a mile away and it drops 8 inches, but it's not plumb. It doesn't. Plumb has no bearing on that. So
Cartoon guy. I don't know what you're making up right now. In reality, if I take a plumb
the
bob
cereal box doesn't.
and I take another plumb bob, two of them cannot match on a globe ever. What are you talking about? No matter how far. 1 foot, 2 foot,
Relax.
50
Relax,
foot.
man.
Just show me the ball where they can. You're making shit up, dude.
Just
Stop.
hear me out
I'm
for a
getting
minute.
tired
Hear
of
me
the
out for a
circle
minute.
jerk. I'm getting tired of you making shit up all day.
Relax.
Why are you
You're
laughing?
going
Go get a
back and
spear.
forth between
You're
two different
annoying me
topics.
with no ball. I'm going
Demok,
back
you're
and
going
forth with
back and
somebody who
forth
doesn't
between
have
two
a
different
sphere,
points.
but they're trying to steel man a sphere argument without a sphere. Please stop doing that. You can't do that. You can't
Please stop
steel man
talking
your
over me.
imaginary
Demok.
sphere of your idea of what someone else's imaginary sphere is. Because if I ask you in blue, you're going to have a different opinion. Stop for a minute. I'm trying to tell you something. I'm trying to enlighten
Yo,
you.
Kosho, you here? I don't want to mod my own conversation, but
Well, you and Blue and Kosho would have a different opinion on what I'm talking about right now. Not the same, correct?
no, I'm not looking for an opinion. I'm looking for moderation. I don't want to moderate you.
Yeah.
as I'm talking.
Demok, you gotta let talk percentage.
Well,
I
what's he
appreciate
talking
it.
about? No ball in his hand. How's he showing me I'm wrong? I'm waiting for that.
My point
he
here.
can
Here's my
talk till
point,
he's
Demok.
blue. Thank
Hold
you.
There's so much wrong in what you paint, Demok.
Show me. Yeah, I know.
Well,
It's
hold
a
on. Let me
cool
just say this.
story.
Let me just say this. Demok, you're going back and forth.
Listen,
It's a cool story without a ball, man. That's all I'm saying. Just think like SE. Get the ball. Show us what you're explaining. Show your magic ball.
Listen. You are
Show. Show without listening, because listening is just imagining Papa Smurf balls. You guys are talking about fucking imagination you don't have. You don't have a ball.
You are
Demok,
fucking,
you realize if this cereal box is a mile away, right? It doesn't matter
No,
what
I don't
orientation it
realize
is.
anything you're saying.
It doesn't matter what orientation it is. It could be standing straight up. It could be sideways. It could be whatever. It doesn't matter what orientation it is. There's still going to be the 8-inch drop. So for you to combine the tilt and stuff like that with it does not make sense. You're combining plumb with drop. It does not make sense. And you keep on going back and
Drop
forth.
and tilt are the same thing. Shut
No,
up.
they're
with that
not.
kindergarten ignorance of yours, because you can't comprehend incredulity of your ignorance. Don't tell me 8 inches drop ain't 8 inches drop, or a tilting box when it drops 8 inches from one side. I've never fucking seen a straight vertical object drop and tilt 8 inches ever in my life, unless you're dropping downstairs. We do not live on a stairway. Stop trying to say that. We live on a sphere. Explain a sphere to me, not a stairway, son.
Drop and tilt.
A stairway is 8 inches drop vertical. Plum, 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 plum. Pal, stop acting like you're smart, because you're not playing that dumb game. Go get a sphere and keep showing me where I'm wrong. A cue ball as big as you need to make it to prove your lying point, please. Stop just making shit up, you guys. That's why Flat Earth is never going to go anywhere, because everybody keeps trying to make shit up without proving their point with an actual sphere. You can make it as big as you want, except imaginary. It has to be a physical thing. Show the kids. They don't believe it either. They can't believe your imagination all day. No one can. We can't. We just can't. We can't afford this anymore. No one can. I mean, come on, man. You guys don't take lighten up plums. You don't take anything. You don't take a digital reading. So now when some globe dude backs up from something, his reading of imaginary looking through space is great, but a light up plum that would just show you everything without guessing doesn't work for you guys. Something is wrong here. Something is totally wrong with these guys, somebody's brain in this, and it's not mine. I'm telling you that right now. Right now. Yeah, I'm positive, funny boy with no ball, with no sphere to prove your point. You're real funny, right? Yeah. Thank you. Thank
What
you
makes
for
you think that I need
imagining
to
and
have a
helping
ball?
nobody. Thank you for teaching the
Demok,
kids how
I'm
to
trying
imagine ignorance.
I'm trying to correct you, man.
No, you're not
You're
correcting
coming
shit
in
without a
half
ball.
cocked.
You ain't correcting nothing without a ball. You're making shit up, dude.
I don't need a ball.
Yeah, you do. To talk about a ball, you sure the fuck do. To talk about horizontal and plumb on a ball, you sure the fuck do.
No,
you
we
sure
can
do.
internally
No,
criticize
you
their
can stop
model without
imagining.
it being the truth.
No, fuck all that, Glober.
We can poke
No, we're
holes
not
on
gonna
it,
imagine we
poke
live
holes
on
in
a
it
planet.
because it's wrong.
No, you're wrong. You ain't got no ball to prove me wrong. The fuck you talking about? I implore you. You want to bet your money that I'm wrong or right with the real sphere? Stop making shit up.
Yeah.
All of
No,
you
I don't want
guys.
you to implore me. I want you to beg me.
No, bet, I said. Bet you real money that the dog shit you say is not true at all. If you drop a stick, it's going to drop. If you say 8 inches of a ball and you got a ball so big and it's something can drop 8 inches or tilt 8 inches, there's going to be no difference. Go show me where I'm wrong at on a 50-foot
Okay, so
ball.
Demok. All right, so we're a mile away and there's 8 inches of drop, right?
Yeah, stop imagining. No, I can't imagine nothing, dude, without a ball. Why the fuck are we imagining when we have spheres, right? We do have these things.
Why are you
You guys
talking about
know
these
that,
cereal
right?
boxes tilting then if you're not imagining it?
Why are you talking about balls when you ain't on one? when you ain't going to demonstrate one.
You were talking
That's
about
why
it.
I'm demonstrating how
You were
balls
talking
work.
about 8 inches per mile
Something you don't
squared.
want. Yeah, ball. Yep.
Yeah, so
You
you're
all
talking
right?
about imaginary stuff, and now you're saying let's not talk about imaginary
No, I
stuff.
said go get a real sphere and show me where there's more than one plum. Are you okay with that?
Go get a real sphere and show me how there's cereal boxes
I don't
tilting
have
because
to
of
do
8
shit. I
inches.
don't live on a sphere, pal. You're the
You
one
said
trying to
that.
prove a sphere.
You
You
said
said
it.
I was wrong about a sphere. Go show me where.
No,
What
I
I
said you
just
were
said was
wrong about
wrong
their
with a
model.
sphere. No, what? Where's their model at? Go get it, motherfucker.
I don't know where it is, man.
Exactly. So what the fuck are you talking about? What are they talking about? Nothing. There is no model.
Their models everywhere, bro.
Yeah, that's a cool fucking story. Everywhere that's plumb and perfectly vertical. That doesn't make any sense. There's only one
Everywhere on the
vertical
internet.
sphere ever. Go prove me wrong with a real sphere. I'll wait. I got my money waiting.
Have you ever been silenced before, Demok? If you go on like that, I'll do it. And you make us listen to you, and you say, listen, you don't listen, but you don't listen. You got
Said the
something
guy with no sphere. Oh, I thought you were done. Stop making so long of a pause, please. I couldn't tell. So go get a sphere and stop not listening then, listener. And I'll listen to you when you get a sphere, because that's what I'm talking about. What would I listen to? Garbage imagination? Well, I'm tired of listening to your fucking imagination or his about nothing. How does an imagination win a debate? You tell me that, please. How can an imagination win a debate on reality?
and you yourself
Drop the
are,
mic, baby. Drop the mic. No ball getter. I know.
you
Yeah,
yourself
keep talking about nothing. Thanks, man.
you yourself are constantly
Do
talking
yourself a
about
favor and go get a ball.
Demok, stop interrupting, please.
Take a breath, man.
Yeah, tell us a
Let's
whole bunch about
somebody
no
else
balls.
talk.
Take a breath with no ball in you.
Just breathe. Let somebody else talk for a minute, bro.
He's constantly talking about an orthographic side view model that he has in his head, and he calls it reality. And he doesn't listen, he doesn't look, he just forms an image in his head. What a lot of people are doing with this orthographical side view of a ball that doesn't take into account any sizes or distances. It's annoying.
What size of a ball and what ball where? What distance of a ball? Where?
One of your balls.
You're not. Where's a ball at? What are you talking about? It's annoying. You keep talking about being on a fucking ball. You don't have a ball anywhere. You're talking about some kind of view on top of a ball is going to be different than a left or right view on a ball.
I'm
Go
not
get
on
a real sphere and show me that right now. Show me how a front view, side view, or back view is going to be different on a real sphere with a little pinhole camera. I'll wait for you to demonstrate your lying claim. Stop lying, please. I'm calling out all liars who can't prove their claim. We're going to weed you liars out. Stop claiming shit that makes no sense. Go get a camera.
Who's making the claim? Who's making this claim that you're? I didn't hear percentage make a claim. Which claim are you so hostile about?
I think Light would have wanted to respond to that. I've just muted Demok temporarily.
Yeah, I'm not talking about a globe. I'm talking about an orthographical. He is talking about a ball. He's constantly talking about a ball. What are you on about, Demok? You are pulling.
Show me how I'm wrong about a ball. I don't know how many times I got to keep telling you this. Are you okay? You want me to send you a personal message that says that sentence for you, so you don't have to repeat it to yourself? What are you on about? Not showing people how a real ball works? Thanks for nothing. Gracias por nada.
But you're shutting out vision and perspective and how it works, and that's the whole point in it.
I'm showing them how a sphere works without what? What the hell did you just hold on? Did you just say I'm showing them how a sphere works? They can do that themselves. They don't need me at all. I could be dead tomorrow and they can go grab a ball and do all they want and they're never gonna prove me wrong. So I don't know what you're wasting your breath talking about, dude.
I have no interest in proving the wrong. I'm only interested in proving myself right about things.
Well, go find a plum that's not plum, and then we'll be on a ball, and we won't be on a flat earth, and I won't be a flat earther, and nobody else will.
So most
Let's do it.
That's why you come in like a shuffle, trying to shove everybody away because Denmark has an idea in his head.
I didn't shove any. Listen, that's not. Hold on.
That's not conversation.
How long has the plumb bob been invented for? What do you mean, Democ's idea of plumb being not on the ball more than one? That's physics since the day one that physics has been invented, dude. Has nothing to do with Democ. I'm just arguing the simple truth of the matter. That physically, you only have one vertical on the ball. Not imaginary shit you guys keep saying. I don't know what the fuck you're talking about. No model in the fucking world of a ball does anything of what you guys are talking about. Ever. Not a real ball. Ever. Ever. None.
You get a plum. So drop a plum around now. 200 meters away. I agree with you. On a ball, they won't be perpendicular, but how are you going to prove that?
They light up. You put a little camera next to the reader. It tells you digitally. It's next to your phone. Your phone says 0.000. No off plumb. How are you going to read that? Look at your phone. Google it. It'll send it to you by Wi-Fi and Bluetooth. We have technology today. Stop trying to untechnologize the globe. Let's use the technology to prove it. Globers. A glow-in-the-dark cube would prove your globe. Why the fuck is this? Why would you run from that? Dude, if you got one glowing on the water, you got level water there, it's a calm day, you get one of these plums to light up, no one in the world can ever become a fucking flat earther again. I don't understand the hardness of this. And it's nothing to do with my idea. The Flat Earth Society and Globers have been arguing for too long. It's a compiled idea of everyone in the world. I didn't make a plumb bob. I'm just trying to make it to where you ain't got to go look through fucking somebody's guessing and imagination to get your answer. It'll light up for you. There'll be a number digitally on it that reads. Your camera can be on it while you're away. You can be at home and read your buddy do it. Let's fucking get technological here. You guys don't want to help me out. You want to fight me on it. That's fine.
I don't even know how to irony globes anymore, Denmark. Also simple to prove. Simple anymore. You probably should just get some worldwide broadcast and you'll solve it. Get a couple of floating glowing cubes. That's it. That's the end of the argument. Or a couple of plumb bobs with a digital vertical designed by the people who design all the technology to prove the globe. You want to now trust that technology to prove your side of the argument.
And you can also have an altimeter. And what you would do was you go down a mile or 2 or 3 from where your plane is. You have your guy in the plane waiting. You go stick a stick up in the air. You stick that stick up in the air so high, right there. Pilot, you get 5 foot off the ground. By the math, you should go straight at that stick and miss, not hit the motherfucker with your plane. Then we're on a globe. So now the pilot flies forward at 5 feet off the ground. He doesn't have to do anything but stay at that 5 feet and make sure that he's not going down. As long as he's not going down anywhere, you can have a side view reference to make sure he's not going down, curving down anywhere. And all he has to do, is miss the pole.
You don't want to listen to anything, do you? The altimeter
I
works
was in the
from
middle of
ground level.
saying something. You could have waited 1 more second, you idiot. He's going to miss the pole, was going to be my last word. You didn't want to hear that, did you?
No, excellent. So now you're finished. Here we go. Now you realize your altimeter gives you an altitude from ground level or sea level, which is on a globe is curving. So how is your altimeter going to help you to miss the pole? See, flat
It's
Earth
not going
people.
to raise an elevation. Listen to me. Your
I'm still
altimeter needs
talking.
to raise an
You don't want
elevation.
me to, but you don't want me to finish, do you? Because I'm still talking. Yeah, flat Earth people don't trust gravimeters, altimeters, gyro, all these things that I hear people arguing about all day, every day, and now you want to use it as a flat Earth proof. Over.
Don't you love it? Rub it right in your damn face. Listen, it's sad, right? Now you're going to disprove your own technology. So what? Globers don't like globe altimeters all of a sudden? What, you against the globe altimeter to prove your globe for you? That would be weird, wouldn't it? Wouldn't that be weird? Now listen, if the airplane, one second, if the airplane is going straight and it doesn't raise an elevation, you're not on a globe. So if you go down around an imaginary curve, guess what you don't do? You don't prove a globe. You have to raise an elevation to prove your globe. Do you not comprehend what a fifth grader comprehends?
You've got,
No.
so
You
you're
stick your stick 8 inches up in the air, plus a.
Can I get a word in? Can you take a breath, bro?
Yeah,
If
I
you're
know.
flying at 100 feet, it's all good. It's all good. I'm the big boy.
Okay.
If you're flying at 100 feet, Demok, and your altimeter is keeping you 100 feet off the deck, if the deck is curving because the world is a ball, I'm saying if, then you will just maintain 100 feet elevation from the curving deck. Do you not understand that, my friend?
Disproving a ball, my friend. You need to raise an elevation from the point that you leave the fucking dirt, my son. Every millimeter. Do you not comprehend what a sphere is?
Now you're saying to maintain an
You're only
altitude.
going to
That's
be.
what you're saying.
I'm saying you're going to be 5 foot off the ground. I'm going to go down the way and stick a 5 foot 8-inch pole in the air. You're going to fly straight and not hit the motherfucker. Do you comprehend? Over.
Straight according to what?
According to straight, a computer screen, not Earth. A computer screen line you got sitting there. Fly your buddy across it 5 foot off the ground. Is that too hard, pal?
You couldn't do it.
This goes back to the same argument of a plane going off into space when it takes off.
Exactly.
Oh, so what? Hold on. You're telling me that if the airplane follows a fucking computer screen that has no bearing in reality on a fucking ball, it just has a bearing on the lines on the screen. If that fucking plane, if I got the side fucking thing right there to stick and the plane from start to finish on there recorded and the plane hits the fucking stick, what the fuck are you telling me? And it's a perfectly straight line across that screen? That's not no fucking ball. That ain't got shit to do with gravity. It ain't got shit to do with your imaginary anything. It's an arbitrary line of its own, set in its own base point, its own mean line, and its own reference frame. What the fuck are you talking about?
It's attached to the aeroplane, Demok. Your straight line is attached to the aeroplane. So if the aeroplane
No, it's
dips or
not. My
dives,
straight line is on a computer screen. The airplane's in the air down the road.
I'm tapping out of this one. Good luck.
You tried. You tried.
You're flying an aeroplane with a computer screen, but the computer screen's not in the aeroplane and is not attached to the aeroplane, but you're flying level with the straight line in the computer screen. I don't even know where to go. Because your buddy's got it down the road somewhere. What?
Complex, isn't it? I know it's so hard. You guys don't like technology. I wish you guys were walking around in sandals right now so you could prove your globe so good for us. Listen, on your computer screen your buddy has, Jimmy, he's only got 3 lines on his screen. It's a video camera and there's 3 lines on the screen. They don't have fuck all to do with on the plane or nothing what you're talking about, goofies. It's going to be seeing the plane. The plane's going to be 5 foot off the ground. It's going to follow this arbitrary guy's line that he's got on his phone perfectly fine. Thank you very much. And it's going to hit the stick. Thank you very much. That's going to be 8 inches above and a mile away, and you're going to see both in the same fucking view. What about this don't you understand?
How is it staying 5 foot off the ground? How is it doing that? How do you know it's staying 5 foot off the ground?
How do you know it's not? Because I have a fucking line that it's flying with across the screen that's going to be matched. Go to 5 foot, pal. Okay. Damn, look. Line my screen up. Now do your thing, buddy. My screen's sitting there. Thank you. You're fucking still flying along it? You're still good? Damn. Oh, you're still good? Oh, you hit the stick? You didn't fly over it? Sorry. Too fucking bad, no glow. I'm sorry, it's beyond the...
You can have a funny conversation, but you're just furious at the world, and that in itself is amusing. I'm kind of done with this bit. Someone else take over.
No.
Also, I love how Demok accuses flat earthers of being globers. It's hilarious. Everyone in here is a glober, apparently, except Demok.
And me. I'm not a flat earther.
No, I know, bro. I'll just say, like, he just.
Oh, yeah.
Everybody's a hostile witness to Demok. It doesn't matter. Even if you're on his side trying to help him, he will hate on you somehow or other. It's hilarious.
Yeah, no one's on his side, that's for sure.
It's just funny. 6 months ago, I tried to help him when he was just destroying him. Not his argument, but in the conversation, he was just turning the whole room against himself. I was trying to help him, and he's just mad at me for trying to help him. Like I said, I do find it amusing.
Even trying to break down this scenario of something of being of an altitude of a certain height. That's...
Yeah, I don't know how you maintain an altitude without using an altimeter, which is going to orient you to the grounds, which therefore you're proving nothing.
Well, you're bypassing the well, you're using you can use the altimeter, but you'd be climbing. If that's what he's thinking.
No, he's saying it's to stay 5 foot off the ground. So the only way that doesn't prove flat or curved. Like if it's orienting to the ground, it's orienting to the ground.
It just means you're maintaining it at constant altitude. Yeah.
You're 5 foot off the deck, no matter what the deck's doing. The argument makes no sense.
Yeah.
In a thought experiment, maybe, but not in the real world.
Sure, Demok doesn't come with subtitles. It would make it easier.
Yeah, it's just funny. He's calling percentage a glober, calling me a glober.
How does he think that makes it an insult or not? Someone called me a flat earther. I'm not going to feel offended or whatever.
No, it doesn't even, doesn't it? Yeah. Anyway. Anyone got another subject we can have a chat about?
I haven't been on all day, so I haven't had a feel of the room to see what's been going on.
Gee. It's bizarre. I don't know what's going on. I don't know whether the northern folk, the Americans, have got a weird start to their summer, but we've got a really weird start to winter.
In what way?
Oh, just warm temperatures. Like it's this time of year, you know, our daily maximum would normally be 15, 16. We've been having 23, 25, and it's like really, really strange for this time of year.
Are you in New South Wales?
No, I'm in Adelaide.
Oh, you're cross. Yeah, you're the same latitude. Yeah, as me, roughly.
It's really unseasonally, and it's funny. Like I was at a place yesterday, and there was a deciduous tree that was starting to bud as though it was spring. But at my house, I've got a nectarine tree, and an apricot tree, and they haven't even lost their leaves yet. Like they should have lost in autumn. They've still got all their leaves on it. It's like nature doesn't even know what nature's doing.
Yeah, we just had a tree lose its leaves a few weeks ago. I thought that was a bit late.
Yeah, my apricot tree is still full of leaves. Like hasn't dropped any.
Wow.
It's bizarre. It's bizarre. And I've got strawberries. That are flowering already. The first week of winter, I've got flowers in my strawberry bushes.
But for us, I'm sure our last several winters have been a lot warmer than usual. Not wetter, just warmer.
Just a bit warmer, yeah. Today, like the last 24 hours, we've had huge thunderstorms, big dumps of rain, tons of lightning. It's not wintry. It's more, it feels kind of springy. It's just really odd. I'm just curious whether it's only like a local phenomena that we got here, or whether other parts of the world are having a bit of a strange.
Don't they say the El Nino or La Nina thing, ocean temperature thing, all that stuff?
Yeah, La Nina's. So we're on an El Nino watch at the moment, but it's not El Nino. It's kind of neutral, but it's an El Nino watch right now. But we've only just finished, only just come out of La Nina about 3 or 4 weeks ago. I don't know. It's just a curiosity. Like I said, it could just be a localized thing that I'm experiencing, but it'd just be funny to hear whether people in America are saying, yeah, you know, our fall is strange, or you know, unusually cool, or unusually hot, or whether it's just normal. But I think they're all asleep at the moment, so I can't ask them. Seen Vandy lately? Seen him anywhere at all, Terry?
No, he's completely gone off the radar, which is very unusual. I don't even. I mean, I can go through some channels and maybe find out where he is, but I'd have to take a bit of digging.
Oh, mate, I could. That's 45 minutes. I could drive to his house. I can't find him. I was just curious.
Yeah, knock on
you know,
his door.
whether he's. Yeah, I might just to see if he's all right. But yeah, just I'm also just to see whether he's popped up anywhere else, and he's just sort of not here at the moment. But I've not found anybody that has seen him.
Well, he's not on Discord at all. I don't think. I don't even think he's still showing up in messages or anything even.
I've DM'd him. I've still got him. I've got DM'd him, but he just always shows us off. So
I DM'd him twice the last year, and he doesn't respond.
Oh, okay. Yeah, well, he disappeared.
He was planning to go to America on a long holiday with his wife.
Ah, okay. Well, there you go. That may be where he's gone.
That could be it. Yeah.
Oh, well. Good luck to him
Last
if
time
you
I
have
did message you. It's been a while since I messaged you. I thought
Yeah,
his
I gave
name's
him a
not
wave a
in.
couple of weeks ago just to see if he'd pop up, but
He didn't change his name, did he? It's always been Bansal.
yeah, always Bansal Bandit.
Yeah.
And the other two that were on we're always on like this server and also back on Brandon's was Base One. I haven't seen him for ages.
Oh yeah,
And
Aaron. Yeah, I haven't seen him for a while.
Aaron, also Aaron, the Australian Aaron.
Oh yeah, the Australian one too. Yeah, I haven't heard from him either.
Yeah, guy in South Wales. Yeah, he just vanished. Yeah, and Face One and Bandy. Oh, they were all and Paige. I'd see Paige for ages off.
Okay.
Maybe people just get sick of it all and disappear.
Mm.
But as you know, it can get a bit toxic sometimes in some of these places.
Yeah, I haven't even live streamed for a while
Not
since
yet.
my computer's mucked up.
I'm going to go outside and see my wife on the right home. So have a good day or a good morning or a good night all. We'll see you again.
Roger.
Cheers.
What happened? Did Dima kill the chat? What's going on? Hello. No one's here.
I have developed a test for Globers. Denmark inspired me. So, Globers, to prove that the horizon is geometric, they can stand behind it, be obstructed, and then let a flat earth sniper zoom in on the refracted version of the Glober and shoot the refracted looming version. And the Glober is so sure that it's only refraction of light that they will survive and the bullet will hit the earth. It's the perfect test.
Hello, hello. Is there anybody out there?
Yeah.
Did you hear about these 17 million minks in Denmark that were culled? Did you hear about that?
I haven't heard about the minks.
Yeah, I just learned about this tonight, and it's a little problematic for me. This was during the pandemic, and
You have
I
a
guess
soft spot for minks.
No, I have a soft spot for math. 17 million minks in 365 days is 46,575 minks a day. And they claimed to have gassed them all in gas chambers. I'm not making this up. I will link the article. There's just no way.
Yeah, I'll look at it. That sounds weird. So, like,
It's
symbolically copying the Holocaust with mink.
It's just weird. It's just very weird. I'm not buying it.
You want to hear my new far out globe Earth test?
Yeah, absolutely.
So what we do is we get a glober who's 100% sure Earth's a globe and the horizon's geometric and obstructs things. We get them to stand behind a hill or the earth or a wall, and then we zoom in with a flat Earth sniper from far away until the glober is refracted and loomed up past their horizon. So they know they can be seen, but they believe they're only a refraction. And then we get the flat earther to sniper them in the balls. If the bullet hits the Earth, the glober was correct. It was just a refraction. If the glober dies from a bullet wound to the balls, then he was wrong.
Yeah, I mean, that would have to be a really high caliber round. And when it's traveling at those velocities, covering over a mile, it's going to explode a person, basically, because of this hypersonic wave. But it's a great test.
That's the risk of being a glober and being sure.
Isn't that true? Crazy.
Right, let me look at 17 million. I mean, just off the bat, that's a huge number.
Yeah, no, I just made a little. I just made an Instagram video about it because I call BS, dude. I posted that in the chat too. If you want to check out my my little reaction, I posted it 10 minutes ago, and I've already got nice.
There's a photo of some minks. Obviously, they did some mink. Maybe they had one gas chamber or some gas chambers.
I don't know. 17 million of anything is like a lot, and like, yeah, I'm not buying it.
It takes a few hours on farm to collect a few hundred rats with dogs.
Right. Yeah, I mean, well, that's not even the craziest part of the news article. Like, I guess they once they gassed them, they did a mass burial of them, but like there was some sort of decomposition gases that were building up in them, which forced them to resurface out of their graves. It was pushing decomposing mink carcasses up out of the ground like zombies.
What?
Yeah, I mean, it's just very weird. What's that?
So, are you thinking it's like a weird psyop for Denmark?
Well, yeah, I think it's absolutely a weird psyop. I think most of the news that you read is just either written by an AI and just kind of like reviewed by a human, or there's like a think tank of people that are like, okay, well, we need to like do some symbology. We need to reference some things without referencing them. We need to like send some messages to all the noticers out there. I don't know, something like that, maybe. I'm not sure.
This has got the key terminology: gas chambers.
I mean,
and inflated numbers on purpose.
I think so. Yeah. I mean, I took the opportunity to just deny the numbers outright and basically make the same arguments you would make when challenging any other mass murder of anything. You know, I just question the numbers, I question the narrative, I question who benefits from this. Yeah, and I call it fake. So. I mean, I try to be lighthearted about stuff. I try to like get people to laugh, but at the same time, it's like, come on, guys, who's actually believing this?
And even if it's true on a small scale, they've got the terminology to rise out of their shallow graves.
Yeah, that's bizarre. It's very bizarre.
I would suggest the psyop maybe to scare people about farms and to not trust farm food. Oh no, there's reanimated COVID corpses of pests on the farms. Oh no, maybe we shouldn't eat beef anymore.
Well, it's like they're killing a lot of farm animals lately. I mean, these minks were for fur. Obviously, they're not milking them, but it's just weird. It's just weird.
Oh, sorry, it's actually mink farm. What if it's an evolution? Oh, sorry.
What if it's what?
What are those people that really love the environmentalists? What if it's an environmentalist psyop and they killed the mink or something?
Yeah, that's possible. Very possible.
Oh, I like your green screen. You're gonna get some clicks with that.
Oh yeah, the green screen. That's funny.
Is it just a phone app version?
It's on Instagram. It's just like a filter.
Amazing, isn't it?
It is amazing. It's really easy to make content, and it makes it. Yeah, it's just very very fluid process, and it allows you to like make fun of the media instead. Like when you just get a headline like that, and you just start asking really simple questions and making silly faces, like
I think you get it.
Yeah, people are gonna laugh at
Gas
that.
chambers, and then you like give a funny look.
Yeah. It's like, wait, you guys are serious? Like, who's believing this? This is insane.
That means they'd have to catch them all live, then herd them up, then put them in a gas chamber. That doesn't sound like the best way to do it.
Dude, can you imagine doing 46,575 in one day? Like, I'll tell you what I did today.
Yeah, how many teams in how many areas would you need to do that?
Dude, I wasn't really joking when I said every man, woman, and child 367 or 365 24/7. Like, it's because okay,
it would be a huge effort. I give you that.
Well, here's another thing too that I didn't bring up. These are fur animals. They're for harvesting their fur. So once they're dead and you've got the fur, like whether they had the disease that they said they had or not, they said that disease was transmitted not by fur. Like you treat the fur with chemicals and all that stuff because you're making coats. So like, why would they just destroy all that fur? That doesn't even none of that makes sense. None of this story makes any little bit of sense to me.
No, even if it's the government that says we can't trust mink anymore, sorry, we're going to have to kill them. We're bringing a mobile gas chamber and you're going to have to herd them all in. But that's just a lot. And it doesn't make sense, even at that level.
Yeah, I know. It's just silly.
I know people have said some animals can get COVID, but that's very rare. But it's unbelievable that they would spread COVID or have COVID.
After being skinned and having their fur processed. Yeah, that's ridiculous.
Oh, after that, yeah, they're not going to have it.
Exactly. And
the breathing
so
thing,
like,
isn't it?
Yeah. I mean, I think it was about destroying the middle class, possibly. if that really did happen, if they really did kill that many.
Yeah,
But
if it's true in that angle, they're doing
yeah,
something about people that use mink, and they're against that.
yeah, just about. I mean, think about what a mink farmer does, right? All he has to do is process the animals and keep them alive long enough for them to get to the mature age of harvest. Like, how many outside government inputs is he relying on? You know, he's probably pretty savvy at keeping his operation down to like minimal inputs. I just see them. I see any farmer as like an incredibly self-sustainable or community sustainable system,
They don't like
and
farmers.
they don't like that. They really don't. So they're going to do everything they can to mess with that.
Yeah, and maybe they managed to wiggle like a grey area because it's mink, and then they made up the COVID excuse and they got their paperwork, and they went in and just wrecked the farms, took as many as they could, and then inflated all the numbers.
Yeah, it's definitely weird.
Ta-da.
Hey, anybody here? Check, check.
Hey, what's up?
Not much, just jumping about.
Turtle reach, how copy?
I can hear you.
Is the earth still flat?
Most definitely.
It's most definitely not, but it's good to hear that you're still here on the in reality. Good sir.
Still here under the dome. Life is great under the dome.
Under the dome that doesn't need to exist, because you don't need a container to contain nothing.
So your blood, it just contained within itself? Is there some magnetic force that's containing your blood in your vessel?
I know we're talking about gas pressure, which isn't, again, anything to do with blood, and it's definitely not anything to do with the atmosphere, because the atmosphere is not under gas pressure, it's under atmospheric, or we'll call it, just to keep you calm, we'll call it atmos pressure.
Your lungs don't need anything to hold in the air?
I know they do, and that's why at sea level you're all good, but when you climb to the top of Mount Everest, that's why you need oxygen, because there's a pressure gradient, which is it wouldn't happen on a flat Earth if there's a dome.
Even jellyfish have a containment system. Even the simplest cell has a container. Everything has a container.
No, humans don't. That's why airliners are pressurized to make us live when we're at 30,000 feet.
That's a false equivalence.
No, it's not. It's because why do you think, I don't have kids myself, but why do you think in an airliner they say if we have a rapid depressurization, put your mask on first and then your kids? Because if you fuck around and put your kids' masks on first, you'll get one kid's mask on, and then the air's so thin that you'll pass out and you won't be able to save your other two kids.
No, yeah, I understand you're saying because oxygen density is greater at sea level than it is at higher atmospheric levels, that therefore therefore there's no container. I understand your logic, but even within a hold on, go ahead.
It's fact. It's pure fact.
No, I agree that there's higher densities of oxygen at sea level for sure, and the higher you go up in elevation, the less oxygen molecules there is, right? I agree with you, but what you don't, that doesn't equate no dome or no firmament, right? That's because you got to understand that even within even within I'm trying to think of a good example. Let's think about propane tank. Let's think about propane tank, right? Even within a propane tank,
that's the worst one.
Well, no, because the propane tank, even inside it, it's not equal. It's not equally distributed. The densities aren't equally distributed. So even within it, like you'll have liquid at the bottom and there'll be some air at the top. So, right? Because if you look, in everything's separated by its weight and density. Even the geological strata, right? The collection of sedimentary rock, it's separated by weights and densities. So you have the heavier atoms or heavier molecules at sea level, and then the higher you go up, you'll find that you'll have helium at greater amounts at the anyways, you know what I'm saying? I don't have to keep on talking about it, but you already know.
No, I know what you're trying to struggle to say in order to make gas pressure and a vacuum a thing, but it's not working. Because basically at the end of the day, the atmosphere, or the atmos, just to keep you calm, is not under gas pressure. Every gas within the atmosphere is under gas pressure. Yeah, sure, you need a container to create the pressure. But the atmosphere, however, is its own thing. And there's a pressure gradient, and it goes all the way up to nothing, which is the Kármán line, which is space. And when in the history of mankind have you needed a container to contain nothing?
But that's what you're not understanding. Even within a pressurized system, right? Even within a tank, a propane tank, or anything, or a fish tank, anything that has a container, you can still have a separation of weights and densities. You think that you can't have that and there be a firmament, right?
Why?
So
hold
on. We're seeing a separation of weights and densities. We're seeing that as the higher you go up in the atmos, the less molecules there are. Therefore, there's no firmament. There's no dome. That's what you're saying. But I'm telling you, actually, you can have both. You can have a firmament and a dome and a separation of weights and densities. One does not negate the other.
No. You want there to be that, but there's not. And it's provable. And you can just go up in an airliner. Or you can go up in a small aeroplane and not take oxygen, and you will pass out and go to sleep and eventually die, which I don't want you to do.
Listen, you can get a glass container, right, or a bulb, right, and you can fill it with helium, with hydrogen, with oxygen. You can fill it up with all these different gases, and you'll realize that these gases will separate, and they will separate by